Hey guys, I welcome you all to the live session on MS SQL full course by Intellipaat. This session is conducted by multiple experts who will be teaching you everything about SQL from basics to advanced level. This session is specially for those who would like to learn SQL and make a career in it. So guys, before we begin the session, make sure to subscribe to our channel and also hit on the bell icon so that you will never miss an update from us. On saying that, let's see the agenda of the day. Firstly, we will begin with Introduction to Database. In that, we will tell you what is database and what are the types of database. Then after that, we will be learning SQL and different commands used in SQL. Then post that, we will be learning about DBMS and RDBMS. And also we will tell you the difference between those two. Then after that, we will be learning about different applications of RDBMS. Then we'll move on to SQL Server Management Studio. Then after that, we'll be learning few core concepts of SQL like aggregate functions, indexes, encapsulation, and lot more interesting topics. Then finally, we have covered how to become an SQL developer, followed by SQL interview questions and answers. So guys, this session is going to be very interesting. So stay tuned and watch the video till the end.
I'm going to take you guys a few decades back when we started we started performing calculations and stuff like those, and when we started having computers. Okay, and the sole reason for having or building a computer is was just for the processing capabilities, right? Because intelligence, all of the intelligence, okay, it could be arithmetic calculations, it could be logical calculations, okay, it could be decision making. The human brain is always more than capable of performing any of these, right? Any of these operations. I mean, obviously the human brain is the most intelligent of the all. Now the intelligence was always there, but what we lack is the processing capabilities. Like sparing the wonder kids that are there, the calculator kids as we call them. uh, Normal human beings can process only a certain amount of operations, certain amount of data at a given time frame, right? Let's say in a minute, how many calculations can you perform? It depends on the complexity of the calculation, it depends on the numbers that you're using to calculate and stuff like those, right? So this is what we had to leverage with the use of computers. Now computers were built only for their processing capabilities. Okay, the so the computers could process more and more operations, perform more and more operations in a given time frame when compared to a normal human. Right now, the human brain had intelligence, the computers had the processing capability. So we had to find out intermediate communication system using which we can tell the computer, or we could talk to the computer and share the intelligence and cascade the intelligence, right? So that the computers can become good at performing the operations. They understand what needs to be done when I say 3 plus 2, right? So I had to tell them, we have to somehow communicate to them saying that, okay, if the plus sign is used between two numbers, add them up. If the star symbol is used between numbers, multiply those numbers. Okay, if the slash is used between two numbers, divide them, right? So to communicate with the computers, we needed a medium, and that medium is known as programming language, right? So programming language is the medium that we use to communicate with the computer. Okay, telling them what should they do when the plus sign is given between two numbers, when the multiplication sign is passed between two numbers, right? Now each of these are basically instructions that we are passing to the computer so that they can leverage the processing capabilities and our intelligence to perform the necessary operation. Right now, when we bundle up multiple instructions like this, right, multiple instructions into a single bundle, that bundle of instructions is called as a software. Right now, the programming languages that I spoke about, which is in intermediate, is nothing but a few examples could be Java, .NET, SQL, Python, R. Right, so all of these are programming languages in which we pass instructions to the computer as to what they need to do. Right now, when we compile, when we write huge number of instructions and compile and bundle them together and install on a computer, that particular bundle of instructions is known as a software. Right, so a calculator, a normal calculator in the laptop that you see or your personal system that you see is nothing but a software. Right, because it has a bunch of instructions written inside which helps us add, multiply, divide, and perform a lot of other operations. Right, so then came the era. So this was when we were so this was when we were in the Windows softwares. Then slowly came the internet, right, wherein we started having websites, we started having applications hosted on the internet. Right now, until and unless the softwares were on the desktop, were on Windows itself, it was not much of a hassle, it was not much of a problem. But internet uh, uh, brought out a huge disruption. That is when we started having websites, we started having so online portals and stuff like those, which helped us in our day-to-day activities, which helped us in simplifying and solving a lot of our day-to-day problems. Right now, a consequence of having those all these websites gaining popularity was the data that was getting generated, the information that was getting generated out of all these applications, right, out of all these websites. Right now, as the usage, okay, so there came a phase where people became more and more aware of the internet, and they started exploring more and more internet, or what was there in the internet, and they tried to use them a lot, and that is when it used to generate more and more information on an everyday basis. Right now, the biggest challenge that the companies had with them was how can this information, because they realized by now that every information that the user shares or the user stores is very, very important in the context of the organization going forward. So they started, the computer application, or the website owners or the application owners started realizing the importance of having a good database storage system. Each of the software applications started churning out a lot of information day in and day out. Now, the first challenge that they had was how to store this information efficiently. Because, I mean, in the internet era, right, the requirement from the users keep changing. Okay, the users have become a lot more demanding these days. They want to update their data every now and then, they want to see their data now and then. Okay, they want to do a lot of stuff with the data, with their own personal data every single day. Right, so that is when the information must be stored in such a way that it is easily accessible and retrievable at any point of time. So that is when the information, okay, the first thing that was done, which was a big change, was extracting the data out of the information. Right, information could be a lot of things. Now we need to make sure that we only store the data from it. We just break the data points, we just break it down into smaller components, and then smaller data components, and then store it in a storage space. Now, where do we store it? The first storage system that we had was called as a DBMS, or as we also call it as a database management system. Correct. Now, in this type of storage, the data is stored in files. So when I say the data is stored in files, let me show you what I really mean. So if you, for example, let's say you have you're working on an organization database, right? So in an organization database, you can have multiple departments like admin, HR, payroll, software. So to store the data related to the organization, we create a folder with the name organization, which basically becomes our database. And then we subdivide the database into departments, which is the admin department, HR department, payroll department, and the software department. And then every employee, let's say we have 3 employees in the software department, Dinesh, John, and Smith. So each of them will have one file each, and all the data related to Dinesh will be stored in dinesh.txt. And when I say data related to Dinesh, I'm referring to the first name, middle name, last name, address, date of birth, a salary, designation, department, everything related to Dinesh. Okay, similarly, we will have a file called john.txt, which will have all the details related to John. We will have a file called smith.txt, which will have all the data related to Smith. If I take you back to the organization folder again, for example, let's say we have a couple of employees working in the HR department with the name Leo and Santosh. So similarly, they'll have all the details stored in their respective file. Correct. So this is how the data is stored in the form of files. Now the data is generally stored in either a hierarchical form or a navigational form. Am I right? So if you go back and take a look at the structure again, this is how we navigate, right? So let's say I'm looking for the details of the niche. So I need to navigate through the organization folder, which is basically my database, go into my department, which is the software, and then only when I open the file dinesh.txt, I'll be able to locate all the data related to Dinesh. So this is the hierarchy in which the data is stored: database, department, and then inside those the file. So this is just an example that I'm giving you. Okay, the data is generally, as I said, stored in either a hierarchical form or a navigational form. There can be, okay, this is important, there can be, or there might not be a relationship between the files. Now, if you notice here, all these 3 files, listen to me carefully, all these 3 files are related to the organization via the software department. Correct? Because Dinesh, John, and Smith, all of them work with the software department. So all of these files are related to the organization via the software department. Similarly, um, both these employees are related to the organization via the HR department. Correct? So that means we have a certain level of relationship which has been maintained in this particular structure. Now let's suppose that there is a new employee who has joined the software department with the name X. Now by mistake, while uploading the file, while storing the details, we placed the x.txt file, which was supposed to be in the software department, we placed it here in the HR folder. So obviously, the relationship that was there earlier is no longer valid, because now we have violated the relationship by placing a file which was supposed to be in the software folder in the HR folder, right? So that's the reason I say there can be, okay, if you maintain it diligently, there can be relationship between the files. With a very minute confusion or a mishap, you can easily ruin the relationship between the files. Now, very interesting again, now that the data is stored in files, you can share this over the network. Okay, so for people who are not aware of what a shared folder or a network folder is, uh, So let's suppose that you are working on a huge file, okay, which you can neither share on your email because there's a limit of the maximum file size that you can share over an email, that you can send over an email, right? So how do you share such huge files with your colleagues? Let's say you have to share it with 10 people. How can you do that? Now, in our systems, in our computers, we have an option to share a folder on the network that we are in. So let's say you work with Microsoft. Once you are connected on the Microsoft's network, okay, you will have a LAN cable or maybe the Wi-Fi, right? Once you're connected on the Okay, so if you want to share such huge files, you have to share your folder, right? Now, once you're connected, let's say you work with Microsoft, and once you're connected to the Microsoft in your office, once you are connected to the network, to the LAN, or to the Wi-Fi, then all the colleagues or all the people on the Microsoft network and you are all on the same network. So now if you share your folder, so you can easily share your folder like this. For example, if you want to share your HR folder, you can always go to properties and there is a sharing option here. You can share your folder. Okay, so once you share this, it will generate a path for you. Windows will generate a path for you, and you can share that path with everyone else, okay, or whomever you want to share your file with, and they will be able to access your folder. Okay, so again, you can control who will have access to your shared folder. Okay, you can choose to grant access to a few, and for the rest of them you can disable it. Okay, you can basically give it to grant it to certain set of people, correct? So now using the network folder, okay, we can share our database, isn't it? Because our data is now stored in a sorry our data is now stored in a folder, right? So I can easily share this folder with whoever wants the access to the data, and they can view or modify any of these data that they want to, right? So this kind of the database on a DBMS can be stored in a graph form, which can be seen in the network model. It can be basically exposed on the network, right? A few examples of DBMS are file system that I just showed you. XML, so we can store data in the form of an XML file as well. Windows registry, I have not worked on it, but I know that this is another example of a DBMS. Now with the DBMS, we have a lot of limitations, right? For example, the non maintenance of relationships. Okay, there is no hard and fast rule, or there is no validation that can validate the relationship will hold true if you add some data into your folder or not. There is no check whatsoever, check and validations. Second is the access. Okay, let's suppose your data is stored in Excel. Okay, not more than one person can update, or user can update the Excel file at the same time. So accessibility is also a risk. Plus the management of this. Okay, so now let's say you have three employees working in the software department. This is easy to maintain. Imagine having thousands of employees like this, right? It's going to be a big chaos, right? Because I mean, going through thousands of files together in one shot is going to be a big task, right? So maintenance of the files are going to be a tough task. The last thing is on the accessibility. Let's say you are given an assignment to collect the date of birth of all the employees. Okay, if the data is stored in this manner, boy oh boy, it's going to take you forever to be able to retrieve the date of birth of all the employees from each of the files, because you have to open them manually, get the date of birth of each of the files, and then consolidate it somewhere. So it's going to be a tough ask again. So keeping all these things in mind, and the main reason, okay, the main drawback was the volume of the data that could be stored and managed in a DBMS. Okay, this is not an ideal system to store huge volumes of data, especially huge volume of relational data. That is when we came across RDBMSs, which is Relational Database Management System. Now, in this, the data is stored in a tabular form. That means instead of storing them in files, we now store them in tables. So let me open just to give you a hint about how it looks in a table. So let's talk about the same data, right? So here we can have a table called employee, right? And then this might have the different details like the employee ID, name, designation, salary, department, um, address. Okay, for example, all of these details the table has in it. Now, for each employee, earlier we used to store a file, correct? But now with this method of storing the data, we are going to have it here as the form of rows. Okay, so let's say software engineer, sal salary is $1,000, and India, and then address. Oh, sorry, department is software engineering, and then address is India, right? Similarly, there can be a second employee with the name is John. Let's say he's a senior software engineer. The salary is 1500, the same software department, and the address is US, right? So each employee now is stored in one row, right? Now there are a lot of good things in this. First, the management. You can clearly see the differences now, correct? Earlier, when we used to manage 10 employees for 10 files, now we are only maintaining 10 rows. Second of all, the accessibility. Tomorrow, if someone asks, hey, can you get me the name and the salary of all the employees? It's all easy, right? I mean, we'll see how to retrieve, store, and retrieve everything in real time in the SQL Server database. But just to give you a hint on how a table looks like, how the data is stored in the tables. Data values, as I just showed you, will be stored in the form of cells. Okay, so cell is basically every single box that you see in here is called as a cell. So each cell will have a single value, and these are called as data values. So this is the salary of John. Okay, this is the department of John. This one is the address of India. Sorry, this one is the address of the niche. So that is how we store the data values inside a table. This is where it gets interesting. There will be a relationship between the tables. Okay, now why do I say there will be relationship between the tables? And I talk on the behalf of all the RDBMSs here. Okay, so while creating a table, you're going to establish relationships. Okay, we'll talk in detail about the relationships. Okay, but the good thing is that once you establish the relationship between the tables, the RDBMS itself, it could be SQL Server, it could be Oracle, they will ensure that the relationships are always obeyed. Okay, uh, so any data, so how does it obey it? Any data that you try to insert into the table, it'll validate if the data obeys the relationship or not. If it does not, then the data won't be inserted. Okay, and if it obeys, then the data would be inserted. So at no point in time you will have a record or a row in the table that violates the relationship. Okay, so this is how we force relationships, or we build relationships, and then the RDBMS itself enforces, makes it a point that no data that violates the relationship is pushed into the table. So end of the day, okay, end of the day, you will notice that the relationship is all still intact. Moving further, every value stored in the relational database is accessible, and it can be updated in the system itself, right? So as I said, the expectations from the users have increased a lot, right? So okay, let's say you in a DBMS, okay, using a DBMS, you were able to gather the name and the date of birth for one time. Okay, let's say, okay, I want to still go with the DBMS and I want to store, okay, 1,000 files in the DBMS. I'm able to I'm ready to extract all of that one time. But the requirement from the business or the users have changed a lot, right? The expectations have increased. They want to modify the data a lot of times. They want to see the data a lot of times. So you need to do that more often, and that is where it gets very time consuming. But in here, in RDBMS, it'll ensure that all the data is accessible at all points, and also accessible in an efficient manner. Okay, it's not like you make it available but it is difficult to retrieve it, right? So it is accessible and retrievable in the desired format that the user needs. um, at the same time, it can be updated at the wish of the user. Okay, and the update mechanism is so well maintained that it will not it will not prevent you from updating your rows if there is someone else updating the data. Okay, let's say some other employee data is getting updated, it won't prevent the RDBMS won't prevent you from updating your employee related data. A few examples of the RDBMS. I would say there are a lot of RDBMSs in the market right now, but clearly the front runners in the market are SQL Server and Oracle. Okay, SQL Server is built, marketed, and distributed by Microsoft. Oracle is built by Oracle Corporation, and they are the ones who built and marketed and distributing it right now. We also have Teradata, PostgreSQL, but again, we are going to confine ourselves to study more on Microsoft SQL Server going forward. So let's move forward. So what we discussed till now was the difference was about DBMS and RDBMS. This is a quick comparison of both the systems. So here, to compare the DBMS and RDBMS, the first point is DBMS, we store the data in the form of files, as I've shown you earlier, whereas in RDBMS applications, the data is stored in tables. This is pretty clear, right? The next point says in DBMS, data is generally stored in either a hierarchical form or a navigational form, right? That means we in case we want to fetch the data, we need to follow a certain hierarchy or navigate through the folders to be able to retrieve the data. In a RDBMS, on the other hand, the tables have an identifier called the primary key, and the data values are stored in the form of tables. Okay, now in a RDBMS, what happens is every employee will have its own unique key, which is the employee ID. Okay, we call that as the primary key. I will discuss in detail about the primary key. Okay, so just for you to know, we will have uh, employees each having one unique key, and based on that we can fetch the employee related information. So for example, if I want to fetch the details of John, I just try to fetch the details of 2, because I know that each of the employees will have their own set of IDs. So you will have the IDs like this, each employee having their own IDs. Okay. Coming to the third point about normalization. Normalization is not present in DBMS. Now, what is normalization to begin with? Normalization is a very interesting concept again, but a very advanced concept in which, so we can have a situation wherein while designing a database, while designing the tables inside the database, we can have redundant columns, right? Redundant columns is when, for example, let's say I'm storing the
Just a quick info, guys. Test your knowledge of SQL by answering this question. Which of the following SQL clause is used to delete tuples from a database table? A. Delete. B. Remove. C. Drop. D. Clear. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
employee name in multiple different tables. Okay, so I store the employee name in the employee table, I store the name in the employee date of birth table, I store it in the employee's salary table. Okay, so that means I'm storing this data over and over again, which one takes a lot of space, right? Consumes a lot of unnecessary space because we have it in the main table, right? We don't have to store it in all the tables. Second, it causes data discrepancy because not always when you're spelling names, right, you run into manual errors a lot of time. So you might spell a particular name in a certain way in one table, in the other table you might spell it differently, in the other one you might also spell it differently. So this leads to data inconsistency, right? So we try to redesign our tables in which we will try to reduce this data redundancy, okay, so that we don't have the same text value stored over and over again in multiple tables. This concept of restructuring our tables or redesigning our tables is known as normalization. Normalization is not present in DBMS, whereas normalization is very relevant in RDBMS. It can bring in a lot of efficiency to the database as well. Plus, it keeps your data more, I would say, the data is more in a proper format or more consistent, I would say. Coming to the fourth point about the security, right? DBMS does not apply any security with regards to data manipulation. There are three concepts here. Okay, first is uh, the one thing which I told about the access, right? If I am making modifications on a file, there is no one else can open that file in the write mode, okay, or in the edit mode because I'm already editing it. Second thing is, if two of them are somehow editing the file, okay, at the same time, one of them will be able to save the change, the other will not be able to, because the new version is there. So unless you get the new version of file into your local system, you'll not be able to make any changes. Okay, so there are multiple problems with DBMS regarding the security with regards to data manipulation, and also you cannot control the degree of data manipulation a particular user can do, because if you have worked on providing permissions for users or to files, you must have realized that they only have read or read and write. Okay, they don't have any other specific privileges defined, whereas in RDBMS you can control which user can insert data, which user can update, and which user can delete also. Okay, so it is classified such beautifully in RDBMS that you can provide specific privileges to specific users of your own need and choice. Okay, and also regarding the manipulation, I think someone was asking a couple of questions as to if I'll be able to modify the data if someone else is modifying at the same time, right? This is where transactions comes into picture and the asset property comes into picture. Again, we'll talk about this in detail, but just for you to know, the the transactions in the RDBMS help us perform all of these parallel updates in a more systematic manner, right? So data manipulation is more controlled and more robust in a RDBMS when compared to a DBMS. Coming to the next point, DBMS uses the file system to store data, so there will be no relationship between the files. And as I've already explained this to you earlier, it's a very simple misplace of a file that could cause the relationship to go for a toss. Whereas in a RDBMS, we can maintain the relationship, we can establish the relationship during the creation of the table, and RDBMS will ensure that the relationships are all obeyed during the insertion of the data, during the creation of the new records. So if the data in some way violates the relationship that are already set up, then the record won't be inserted or stored in the table. If it does not violate, if it abides to the relationship, then the data row is inserted. Coming to the last point, DBMS has to provide some uniform methods to access the stored information, right? Wherein we need to follow a certain hierarchy, we need to we need to navigate to the specific folder, and at the same time, the RDBMS, on the other hand, has a tabular structure and a relationship between them to access the stored information. Again, we're going to see how we are going to use the relationship to combine data from multiple different tables. Okay, so that is another interesting part that we're going to discuss when we explore more on SQL. Okay, so these are the differences between a DBMS and RDBMS. From now onwards, we will be focusing our complete attention on RDBMS, to be specific, the SQL Server RDBMS, which is a Microsoft SQL Server. Now, tomorrow, can I launch an application? Can I build an application and say, okay, this is a RDBMS? No, not really. Because there used to be a computer scientist with the name Dr. Edgar F. Codd, who has done extensive research on the relational model of database systems. Okay, wherein he came up with 12 rules of his own, which are still called as 12 golden rules, or Codd's rules, which according to him, a database must obey in order to be regarded as a truly relational database. Right? So when I say it is a truly relational database, I'm also referring to the RDBMS also. So all of these 12 rules are not only applicable for the relational database, but also for the system that is storing the relational data. Okay, so every application or every system that is being built that is to be marketed as a RDBMS should follow these basic rules from Cod. Okay, so for that, sorry, function F2 2021. Oh, PowerPoint. Let me close this one. I'm sorry, one more. Give me a moment, please. Let me cancel that. Okay, I can maybe do this later as well. Yeah, don't worry about it. So let me use this one, and just in case I forget, 2021. Yes. All right, so these are the notes. All right, let me also open the introduction. All right, so these 12 rules, as I said, are very important, and as and when we move forward to discuss each of the components or each of the property in SQL Server, I'll try to bring you back or relate that particular component back to these 12 rules. Okay, so just make sure that you follow each of these, and let me know if you have any questions. So the first rule, come on. So the first rule is called as the information rule. Again, you guys, so the first rule is called as the information rule, and this particular rule states that data, it could be of any type, we're going to talk about both of these, okay, in some time from now, should be stored in a cell of the table. Any type of data that is in the RDBMS should be stored in the cell of a table. There should be no files involved whatsoever. Now, what is the two types of data that we are talking about here? One is the user data. Now, what is user data? Data that we create and store in the database. Like for example, let's say we are working on a sales application, right? So the sales application will have customers, will have products, will have sales, will have prices, right? So we will be creating multiple tables. Now, all of these data that we are going to store in these tables are user data, because we will be creating the tables and storing the data in them, right? For example, the products we are going to fill in the table. The sales, we are going to fill them. Customers, we are going to insert them into the table. So all the data that we store in the database are called as user data. Then we have the metadata. Now, what is a metadata? Let's say I create a table in the database. Okay, I have a database, and in that I create a table. What the RDBMS does internally is it'll try, so the moment the table is created, it'll try to store the name of the table, the creation date and time, the modified date and time, the columns, the owner of the table, and all the related details of that particular table in the RDBMS itself. Okay, and this, remember, is done by the RDBMS automatically, and these information are known as metadata. Okay, metadata is details about the objects. Okay, details about the tables that we store um, in the database. So every table that we create or any other object that we create, it'll try to store the metadata of all of them without you explicitly specifying it. So you don't have to specify mentioning that the metadata should be stored. It's the responsibility of the RDBMS to store the metadata automatically. Okay, so any type of data, may be user data or metadata, all of the data should be stored in the tables and obviously in the cells of the tables. Moving on to the next rule, this is called as the guaranteed access rule, and this states that any data value in the database can be fetched using three parameters. Okay, let me take you back to the table that we created earlier. So let's say I'm asked to fetch the address of India. So come on, the the address of Dinesh or the address of John, let's say, right? So now any data that we want to retrieve from a table, from a database, can be fetched using three parameters. What are those? The first one, obviously, we need the address of John, right? So if I need the address of John, I first need to locate in which table do we have the details related to John. So let's say John is an employee. So obviously we will find the related details in the employee table. So the first thing that we need is the table name, correct? Now, once we have the table name, the second thing that we would need is the unique ID. So we know that the this table somewhere has the address of John. But first we need to narrow down. So we now narrowed down to the table. Next thing that we need to narrow down is to the row where the details of John is stored. And how do we do that? By locating the ID of John, the unique key of John, which is the, as we call it, as the primary key. Okay, so the next thing that we need is the unique key so that we can narrow down to the record or to the row where we have all details related to John. Now, the third thing that we would need, the third parameter that we need is, now that we are on this particular row, what detail of John do we need? So we need the address detail of John, correct? So the third parameter that we need is the column name. So once we have narrowed down to the table, then we use the unique key to narrow down to that particular row, and then we narrow down to that particular column wherein we will reach at a, single cell. The intersection point is the data that we are looking for. So this is the address of John. So US is the address of John. So the guaranteed access rule states that any data value that you're looking for in the database can be fetched using three parameters: the table name, the row identifier, or as I call it as the unique key, and the column name from where you are trying to fetch the data. Similarly, if I would have needed the date of birth of John, I would have used the date of birth column, right? The table will be the same, the row identifier will be the same because I'm still looking for John's date of birth, but the column name is going to be date of birth instead of address, right? The rule 3 is called the systematic treatment of null values. Now, what is null in the first place? Null means nothing. Okay, let's say you're given a feedback box. Okay, so let's say you entered two spaces there. You're given a feedback form online, and you enter two spaces there. Basically, you are inserting a blank feedback, right? But it is nothing. I mean, you cannot use null in there because it still has two spaces. That means you are still trying to give it a value. Null is basically when we have nothing in there. Okay, it's a void.
Just a quick info, guys. Intellipaat provides SQL online training in partnership with Microsoft and mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
Right now, a null can be used in three situations. One, when the data is missing altogether, or when the data is not applicable, or when the data is not known. Okay, so data is missing when basically we have the data but we don't have it in our database, right? The data is present somewhere, we know the data but we haven't stored it in our database. So there are three situations in which we can use null, wherein the data is missing. Basically the data is there somewhere but we don't have it in our database. In that case we can use null. Where the data is not applicable, so let's say we have a column called a date of resignation in the employee table. Okay, date of resignation, that's a date of resignation in the employee table. Now let's say Dinesh has resigned from the uh, organization on 1st of January 2021. But John is still working in the organization. So that means this can have a null because for John, date of resignation is not applicable because John hasn't resigned yet. He's still an active employee. So that is when we can use a null, when the data is not applicable. The third thing is when the data is not known at all. That means we cannot quantify the data. Okay, I cannot recall an example, but yes, I mean, you understand what I'm trying to talk about, right? So the data is not known, we cannot quantify it, we cannot weigh it, we cannot calculate it, right? That is when the data is not known. So if the data is not known, we have no idea what should be there. In that case we use a null. Now what does this rule, which is systematic treatment of null value, states? It states that the nulls should be used only in a single scenario all throughout the database to maintain consistency in the data. So that means if I use null, let's say I have created a first table and I store null when the data is missing, then I need to ensure that in all the other tables that I'm going to create in the database, I store null only when the data is missing. Okay, for not applicable, I can store NA. For data not known, I can store NK. I don't care. But again, in wherever I find a null, I should be able to do an educated guess saying that, okay, the data must be missing. That's the reason there is a null in the cell here, right? That is the consistency that we want to have in the relational database, wherein the nulls are provided with a systematic treatment. The fourth rule is called as the active online catalog rule, and this one is directly related to the metadata that we were discussing earlier. You remember the metadata that we were discussing earlier? Now, the information rule stated that the data, user data or metadata, should be stored in a table. Now, the active online catalog mostly speaks about who is responsible to store the metadata. It says every RDBMS should store the structured description of the whole database in the form of a metadata dictionary. Okay, that means every RDBMS should automatically store the structured description of the whole database. That means, let's say I'm creating a table. So all the details of the table, like when was it created, when was it modified, who created it, what is the name of it, right? All of these details related to the table are stored in the form of a dictionary, basically in a table, and that too automatically by the RDBMS. So it's the responsibility of the RDBMS to store it. So what we do is we just create the table. Okay, storing the metadata is the responsibility of the RDBMS. Okay, and this is what the active online catalog rule states. So the RDBMS keeps actively looking for any tables that are created in the system, okay, or in the database. Now, coming to the rule 5, this is called as a comprehensive data sublanguage rule. Now, what does this rule states? It states that, so what are the main operations that we are supposed to perform on a database? Obviously, storing data, and also, as I said earlier, the expectations of the user has increased a lot, so we need to have enough um, processes and capabilities to better manipulate or manage the data and also retrieve the data whenever necessary, right? So these three operations, these three are the main operations that needs to be performed on the tables inside the database. Now the comprehensive data sublanguage rule states that all these below operations should be performed using one single language that has a linear syntax. That means the all these operations to store data, modify data, and retrieve data should be performed using one single query language. Okay, I'm talking about a language, okay, not a command. One language can have multiple commands, right? But all of them should be part of a single language. So you don't have to use C# to store data, Java to manipulate data, Python to retrieve data. Okay, it's something of that sort. It should be one single language that should be used on the whole RDBMS to perform all of these operations. That is what the comprehensive data sublanguage rule property states. Now the rule 6 is called as the view updating rule property. Okay, the view updating rule states that any type of data that is visible to us, except for the metadata obviously, and that we have write access on, should be updatable, right? So any data that is visible to us that we can see with our naked eyes that are stored by the user, and obviously provided we have the write access or update access on it, we should be able to update it. So anything that we see should be updatable provided we have full access. Okay, if there is a data, if there is a table that has some data, we have full access on it to make changes as well. But if the system doesn't allow us to do it, it cannot be called as a RDBMS. Okay, it should give us all the privileges and we should have all the rights to be able to update it, provided we can see the data in the table. Obviously, if there is no data, then you cannot update anything. Provided we see the data and also we have write permissions on the table. Coming back to our seventh rule. So the seventh rule is called as the high level insert, update, and delete rule. Now this particular rule states that a database or a system must support high level insert, update, and delete, right? That is obvious. This is where it gets interesting. More importantly, for multiple rows. So tomorrow, there cannot be a system that comes into the market and says, hey, if you want to update 20,000 records, you need to write 20,000 update statements, update queries. Obviously, that doesn't make sense, right? I mean, who would want to buy and use a system wherein you have to write 20,000 updates when you want to update 20,000 records? Right? That's baseless, that's nonsense, right? So that is what the court's rule states. I mean, every RDBMS that comes into the market should allow high-level insert, update, and delete. And most importantly, for multiple rows at the same time, bulk operations one time. Rule 8 is called as the physical data independence. Okay, this particular rule states that irrespective of the physical location from where the application is accessed from, the underlying data should not change. So the rule 8 is called as the physical data independence, and it states that irrespective of the physical location from where the application is accessed from, the underlying data should not change. Let's take the example of Amazon. Okay, let's say you have an account with Amazon and you order some stuff in there, right? Let's say you have ordered a laptop. Okay, that's the only order that you have placed. Now let's say you are in India, you have ordered the laptop. You walk into, let's say tomorrow you walk over to another country and try to access your Amazon application again. Do you see a different set of orders placed from your account? No, right? Because the underlying database is the same, the application is the same, the account is the same. So obviously the underlying data should not change. And that is what physical data independence states. Irrespective of the physical location from where the application is accessed from, the underlying data should never change. It should be the same if you're irrespective if you're in India, you're in the US, you're in the UK, anywhere as such. Okay, no RDBMS should give different data based on the location. The next rule is called as the logical data independence. Okay, now imagine a situation wherein there is an employee table. Okay, now the employee table, let's assume, has a lot of details. So let's say for some reason we want to split this employee table into 4 tables, like the basic details of the employee, the date of birth. Let's say I want to create another table for the to store the date of birth of the employee, the salary of the employee in another table, the leaves of the employee in another table. So basically I want to split it into multiple tables to manage the data in a more better way, right? So now I have replaced my employee table with these 4 tables, right? So I have changed the way the data is stored in the database. So now what is going to happen is the employee table is no longer there. So the application that is there, the front end website that is there, it'll keep looking for the employee table, correct? And obviously it's going to fail because it will not find the employee table anymore. So in a situation like this where we are modifying the logical layer of the database where we are storing the data, the RDBMS should provide us the flexibility or a feature using which we can create a virtual employee table. Okay, this one is a virtual employee table which looks exactly similar to the previous employee table, but is now derived from all these 4 new tables. So now when the application is run, it finds the employee table and it doesn't fail anymore. But this employee table is not the same as the last one, although the structure and the data are the same, but it is not a real table. It's a virtual table derived from all these 4 tables that were split earlier, that were created earlier, right? So the logical data independence states that the RDBMS should provide us the flexibility to create a virtual logical layer, which is the employee table in this case, so that any modifications on the logical layer does not have to cause the application to fail. So how we started it was, let's say the employee table was there, we had to split it into 4 tables, the data into 4 tables. Now the employee table is no longer there, right? Because all the data are being stored in these 4 tables now. But the application is going to fail because the application will still keep looking for the employee table that was present earlier. So in that case, the RDBMS, in this case where the logical layer has been changed, the RDBMS should give us the flexibility to create a virtual employee table that looks an exact replica of the previous employee table, okay, so that the application doesn't have to fail. And this employee table is derived from all these four tables. And we have a feature in SQL Server, Microsoft SQL Server, that allows us to do this. Okay, so coming to the rule 10th, right, this is called as the integrity independence. Now this rule states that any modifications that we, so in SQL Server, okay, let's just pause for a bit. So in SQL Server we have certain integrity constraints. Okay, now what are integrity constraints? They are basically rules that we can apply on columns to bring in consistency in the data. Okay, so for example, let's say I'm building a senior citizens table. Okay, and in that I have the age column. So in a senior citizens table, obviously I don't want anyone to have an age less than 60. So I can put a constraint on top of that age column saying don't accept a value which is less than 60. Those kind of rules are called as integrity constraints in SQL Server. There are many such rules that we're going to discuss in detail in maybe maybe in tomorrow's session or the next Saturday. Okay, so any change, okay, what this rule states is that any modifications that we do on the integrity constraints for the database, basically on the columns of the table, the application should not be forced to be changed or modified to support this. And the sole reason is integrity constraints, as I said, are rules that we apply on the columns of the tables to bring in consistency into the data, right? So this is more of a column level setting, or a common level column level rule that we set up. Now this in no way should be related directly to the application. Okay, so obviously if I'm changing any of those rules on the column, the application should not be forced to be changed or modified to support this very thing.
Just a quick info, guys. Test your knowledge of SQL by answering this question. Which SQL keyword is used to retrieve a maximum value? A. Most. B. Top. C. Max. D. Upper. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Okay, that means once I change the setting on the database, that should be it. The application should not fail at any cost. Basically, the application should not be tightly coupled with the integrity constraint. Okay, that should be again the responsibility of the RDBMS. Okay, it should only be a column level specification. Next is rule is called the distribution independence. There are distributed databases that we can build on SQL Server. Again, that's a completely different subject again. So when we have, so in the distributed database, what we do is we host a certain part of the database in one SQL Server in one physical location, let's say in the UK, for example, and another part of the same database in another SQL Server on the US data center. So our database is distributed now across two different physical locations. Now the user at no point in time should realize that it's a distributed database. Now, how can a user realize if it is distributed? If the user experiences different performance, okay, on different modules of the application, that is when he or she could anticipate that, okay, this database might be distributed. It can be on two different locations because a part of the applications runs perfectly fine, but the other part of the application that connects to the other part of the database is running slow. So basically, they using this concept, they can judge that the database is distributed. Now, what or how is the RDBMS related to the distribution independence? So so how is it related is, given the same network bandwidth, given the same physical server setup, And given the entire same setup, the RDBMS should perform in a uniform manner. Okay, the performance should not be inconsistent across physical locations. That means if I have the same network bandwidth, the same capacity server, the same LAN that is connected, okay, same speed LAN that is connected to both of the systems, then both of them should give the exact same performance. Okay, it should not be like in the US it gives a different performance, and on the UK it is completely performs completely opposite. Okay, so the distribution independence states that the end user must not be able to see that the data is distributed across multiple locations, and at least the RDBMS should not play a role in it. The performance of the RDBMS should be top notch, or at least uniform, if I say in simple terms, uniform across both the locations. The last rule, rule 12, is called as the non-subversion rule, and it states that you cannot grant access to a child object without granting access to the parent. In case you do, the RDBMS should automatically grant access to the parent as well. If I give you an example on this particular rule, so we have a database, right? Inside a database, we can have tables. Talking in simple terms, let's say you want to walk into the kitchen. Okay, you have a house, you want to walk into the kitchen. Obviously, you need to have the key to the main door to be able to open it, get into the house, and then go into the kitchen. You cannot just drop in into the kitchen without having access to the house. As simple as that, right? This is what the non-subversion rule states. You cannot grant access to a child object, which is a table. So a database is the parent. Inside a database, we can have table. You cannot grant access, a user cannot be granted access to the child object without the user having access to the parent. Okay, because if they are not able to get into the database, there is no way they can connect to the table, they can retrieve the data from the table, right? In case, okay, you will never be allowed to do that. In case you do it, the RDBMS itself should automatically grant access to the parent as well, which is the parent database. So if I directly grant a user access to a table, that user should also be granted access to the database. Not complete access, just entry access, and it'll have the access on that particular table. It'll not have access to any other table whatsoever. That is the non-subversion rule. These are all the 12 rules that were proposed by Dr. Edgar F. Codd, and I'm over the period of time, as in when we move forward with our discussions and get to know more and more about SQL, I'll try to bring you guys back into these rules so that I can relate each component, each module to one of the rules in here. Okay, so we discussed about the rule 1, 2, 3, 4, 5, 6, and 7, 8, 9, 10, 11, 12. Okay, let's get into facility of SQL Server now. Okay, so before we start, let me just share you a couple of important things that might be necessary. First of all, from where do you install SQL Server? So first, where do you download SQL Server from? So you should have SQL Server 2019. So 2019 is the latest version of SQL Server that is available, and you can download it from this particular link. Okay, I'm going to share this link. Okay, but in here, which one do you download? Which version do you download? Down, if you scroll down a bit, you will find the developer edition of SQL Server. Right now, the developer edition is a full-featured free edition licensed for use as a development and test database in a non-production environment. So you cannot, I mean, this has certain restrictions, but nothing that should impact you as of now. This is more than sufficient for us to learn SQL development. Okay, and you can download it from this link. Okay, so I'm going to share this particular link. Now, if you guys have any other versions of SQL Server installed, it should be perfectly all right. Okay, so go to this link and download the developer edition. So if you have anything beyond 2012, it should be okay. All right, so you don't have to worry, or you don't have to download this all over again. Now, this is for the SQL Server. Okay, SQL Server. Now we need another application which is called the SQL Server Management Studio. I'll tell you the relevance of this and the usage of this as well. So where do you download and install SQL Server Management Studio? So you will be downloading this developer edition setup file, right? Now, once you're done installing and setting up your SQL Server, you should find a link to download and install Management Studio end of the SQL Server installation. Okay, so right at the end of the SQL Server installation, you should be able to download and install the Management Studio. Okay, now how do you install it? So so once you are done downloading the developer edition, you can use link to install SQL Server. Okay, so first you download it from the above link. Um, Download link for developer edition of SQL Server, and then this one is the link to install. Okay, and then you need to install the Management Studio, which you will get at the end of this installation itself. Okay, so you don't have to install it separately, and obviously this video also shows you how to do that as well. Now let's talk a little bit about SQL Server. So we have been discussing about SQL Server. We had spoken about SQL Server yesterday a bit. SQL Server primarily, okay, is a database engine where we create and maintain databases. Okay, so databases are like storage containers, okay, where we can create tables, right? We create tables inside the databases, and then the actual data that we want to store are stored inside the tables. So we can have tables like product, sales, customer, price, discount, right? All of these are tables, right? Now inside the customer table, we will have the details of the customer, like the customer ID, name, phone number, address, email address, right? And all of those stuff. Now this is SQL Server, right? This is where we create and maintain our database. Now what is the Management Studio that I spoke about? Now all the data related operations will be performed on SQL Server, right? Because that is where the actual data is present. Now, what is the role of the Management Studio? Management Studio is an user interface to connect to different SQL servers. So SQL Server on its own does not have an user interface. It's just meant to be a database engine. Okay, it's like a storage container. Now, in order for us to perform some operations on the database, we need a interface to write the commands, right? To write certain instructions so that we can perform it on the database. That can be done on the Management Studio, on the SQL Server Management Studio. It's a user interface that allows us to connect and operate the different databases inside the SQL servers. Okay, now how do we know if a SQL Server is installed in a machine or not? Okay, so what happens when a software is installed in a computer? When a software is installed, so software is meant to perform certain operations, right? I mean, to make our life easier. Now, in order for it to do that, it needs some supporting services to be installed on the computer. So whenever we install a software, it will have it will have a set of related services that will get installed in the system. Now, where can we find those services? We can find them in services.msc. Right? So if I open services.msc on my computer, you will notice So you can either open it from the run command, or you can go to Windows and type services.msc. Okay, and you can open the services here. So all the softwares that you have on your system that are installed, you'll find all the related services in here. Okay, so when we install SQL Server also, SQL Server will also have its own set of services that are installed. So if you go to the F section, you'll find a set of services that is related to SQL Server. You see, these are the ones that are related to SQL Server. Now, the most important service out of all of those is the SQL Server service. Okay, the SQL Server service is like a universal listener. So the management studio, what we do in the management studio is we will be sending connection requests. So let's say I want to connect to a SQL Server X. Now, if I want to connect to X, I need to I need to tell or provide the server name and the credentials. I'll show you how we do that. Okay. So I need to send the server name and the credentials from the management studio. Now, this SQL Server service that you see is one per instance of SQL Server. Right now, what is an instance of a SQL Server? Uh, we have multiple versions of SQL Server, right? We have 2008, we have 2008 R2, we have 2012, we have 2014, we have 2017, 2019, which is the recent one. So there are multiple releases or versions of SQL Server that are available. We are installing the latest one. Now, in a system, in my laptop, in your laptop, you can install more than one versions of SQL Server. Okay, so when you do that, ideally, so you can have more than one instance of SQL Server, right? Because each version corresponds to an instance. That's a technical term that is given to each version of SQL Server installed on my system. That means if I have 3 versions of SQL Server installed, that means I have 3 instances on my machine. Now, every instance of SQL Server will have its own SQL Server service. Okay, that means let's say I have instance XYZ, then there will be a SQL Server service for X, there will be a SQL Server service for Y, there will be a SQL Server service for Z. So there will be one SQL Server service per instance. Now, if I want to connect to X SQL Server and I provide the credentials for X and say connect from the management studio, that connection request or that authentication request will be sent to the SQL Server service related to X. And this service will determine if the connection request is authentic or not. If it is authentic, it will allow entry to the SQL Server and it will connect. Else, it will throw you a message saying that access is denied, obviously. So this is like a universal listener, right? So it keeps listening or it keeps waiting for any connection request that comes in and tries to validate them. Okay. Now, obviously, as I said, each instance has one SQL Server service. So if you notice, I have only one SQL Server service here, right? The others are not SQL Server services. Okay, this is the main one. These are supporting services. So that means I have only one instance of SQL Server in my laptop. Okay, in case, okay, if you notice one thing here, one important thing is the status of this service. Okay, if you can see, there is a column called status, there is a column called startup type. Now, this is very, very important. SQL's, as far as the service is concerned, its responsibility is to respond to requests, right? Now, in order for it to do that, there can be authentication requests coming at any point in time. So it should always be up and running. So that's the reason the status should always show running. If there is a SQL Server service that is not running, you will never be able to connect to that SQL Server because there will be no one, there will be no service on the other end although you're putting the correct user ID and the password or the correct credentials, but there is no service on the other end to validate your request. So it look as if the SQL Server is offline, but it is not. The SQL Server is up and running. You are providing the correct credentials, but the service that validates these authentication requests is not running anymore. Coming back to this one, so the service should always be up and running, and the startups type should be automatic, because what happens is um, uh, when the system shuts down, okay, due to some reason, or the system is restarted, there are certain services that are stopped as well. Okay, now just in case the SQL Server service is stopped, the moment the system is up again, if the startup type is automatic, this service will be started again automatically by Windows. Okay, now we have other options here. Let me show you how you change that. You go to right click, go to properties, and you will see the startup type here. Okay, there is also something called as manual. There is also something called as disabled. Manual, if you set it to manual, then you yourself, after a restart, will have to manually run this service again, which is ideally not, which is not a good idea. Okay, because we don't know, uh, we don't want to cause any downtime on the server, right? We don't want users or applications to fail connecting to the database. So it needs to be always automatic. Okay, you just need to keep this in mind whenever you install a new SQL Server. The first thing you need to check is if your SQL Server service is up and running and the startup type is automatic. Now you see a name inside the bracket, right, which is called MS SQL Server 2019. What is this name? This name is called as an instance name. I told you the definition of an instance earlier. Every version of SQL Server that we install on our machine is called as an instance of SQL Server. Now, um, with every instance that you install, during the installation, you can choose to give a name to your instance. Okay, and for my own convenience, I make sure that I name it MS SQL Server and the version of SQL Server that I'm installing, so that I can distinguish it. Let's say tomorrow I have another new version of SQL Server. When I install it, I'll give that a name of MS SQL Server 2021. Let's say there is a new version of 2021 coming in later in the year, right? So that way I can distinguish which service belongs to which version of SQL Server. Okay, because there is no other easy way to identify unless you connect to the server itself. Okay, from here you cannot identify which SQL Server service. Let's say you have 2 or 3 instances, it will be difficult for you to identify which service belongs to which SQL Server version. Okay, so I make sure that I name it intentionally to have the version also in it. Right, so I have named it MS SQL Server 2019. Now you can also choose not to name it. Okay, you can have at most one default instance, right? A default instance is when we don't provide a name to the instance. Okay, so those are called as default instances. Okay, so whenever you connect to the laptop with whenever you try to connect with the laptop name from your management studio, it'll connect to the default instance of the SQL Server. Okay, but for named instance, you need to provide the laptop name / the instance name. Don't worry about taking down notes. Okay, I have everything in the notes. I'm going to read it out to you all again and share it end of the session again. This is a named instance. Okay, so as I said, you can have one default instance, okay, at max. Okay, you cannot have more than one default instance, but you can name all your instances. If you wish to, you can name all your instances. Okay, so I always prefer naming my instances. I don't want to create any I don't prefer creating any default instances in my laptop. Okay, now the rest of them are supporting services. Will not go deep into those. Okay, so let's get back to our notes in here. So this is what I was saying. SQL Server service will validate if it is a authentic request. If it is a yes, then it allows access and the SQL Server is connected on the management studio. If no, then obviously it will reject your request. It will not reject your access. It will reject your request to connect to the SQL Server. This is what I just discussed. SQL Server service is the most important service in the context of MS SQL Server. And this, I don't know if this is true, but I think it is quite similar to the functioning of our heart in the body, because once the heart stops beating, there is, I mean, a person is virtually dead, right? So it's the same thing with SQL Server as well. Until and unless the SQL Server service is up and running, all your authentication requests will be validated, and you will be either granted access to the server or rejected, right? But the moment this service is down, although your server SQL Server is functioning, it is up and running, but only because the SQL Server service is not available, there is no service to validate the request, right? So that's the reason I call it as the heart. So the moment the SQL Server service is down, it seems as if the SQL Server itself is down and is not accessible. Each instance of SQL Server has its own SQL Server service, as I mentioned earlier. So if I have 3 instances installed, if I have 3 versions installed, I'll have three SQL Server services. SQL Server service is an universal listener. It keeps listening to the connection requests from the different sources. Okay, like um, you can get a connection requests from the application, you can get from other users, you can get from reporting, you can get from integration services, and a lot of different other things. Okay, and as the the I've also explained you why the SQL Server startup type should always be automatic and the status should always be running. Okay, the service startup type should be automatic and the status should be running so that it can validate. Instance, I've explained this earlier as well. It is one single version of SQL Server. Each instance is independent of each other. That means you can create a database X in the first instance and it will not appear on the second one, because so it is like you're splitting it into 2 different servers. Let's say you have 2 versions, you have 2 SQL servers installed on your laptop. So both of them act like 2 different servers altogether. The databases, the data that you store in one of the instances will not be reflecting on the other one, although they are on the same system. Okay, and I don't know, this was earlier that I know about, that you cannot install the same version of SQL Server twice in a single laptop. That means if I already have a 2017 version of SQL Server installed, it will not allow you to install a new instance for 2017 again. It will ask you to either repair, uninstall, or update it. Okay, but it will not allow you to create one more new instance of 2017. Okay, you can create a new one for 2019 or a new one for 2012, but not for 2017 again. Each instance will be corresponding to different versions of SQL Server. That means if I have 3 instances, it should be 3 different versions of SQL Server installed on my system. And this is on the instance name. We can assign names to our instances of SQL Server. There are 2 types of instances, as I explained. One is a default instance when we do not assign any name. I usually don't prefer having any default instance. I make sure I name all my instances that are there on the installed on my machine. And as I also mentioned, there can be only one default instance allowed on your per system. Okay, that means in my laptop I can have only one instance without giving a name, which will be the default instance for this particular laptop. And then I have a named instance in which I'll provide a name, and a good practice that I follow at least is to name it as MS SQL Server, and then I try to I try to apply the server version as also, so that I can clearly distinguish between the different versions of SQL Server in my services. And all of these, okay, all of the um, all the instances, come on, instances can be named instances. Okay, I mean, you don't have to mandatorily have a default instance. You can choose to keep all your instances named. All right, so that is a brief about SQL Server. So you can validate your SQL Server if it is presently installed on your system or not by looking at the services. Okay. All right. So with that, let's get to open the Management Studio.
Just a quick info, guys. Test your knowledge of SQL by answering this question. Which of the following SQL clause is used to delete tuples from a database table? A. Delete. B. Remove. C. Drop. D. Clear. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Okay, so let's get into the actual SQL Server development. Okay, so after you install, you will find uh, something called as a Microsoft SQL Server Management Studio 18. Okay, so there is, as I said, most of the work, most of the effort that SQL Server puts in, Microsoft puts in, is into SQL Server, because that's the actual database engine, right? This is just an user interface. So I think the recent version that you will find is 18.8 or something, which is a 2020 copyright from Microsoft. So once you install it, you will be able to install it, as I said, from the end of the SQL Server installation. So let's get to open this.
Just a quick info, guys. Intellipaat provides SQL online training in partnership with Microsoft and mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
Okay, so it'll take some time to boot up. Just a moment. And obviously mine is a 8 GB. If yours is a bigger one, yours is a heavy one, it'll run faster. This is the version 18.6, copyright of 2020 Microsoft. All rights reserved, and this is obviously built and marketed by Microsoft. All right, so I'll again repeat the motive or the usage of SQL Server and the Management Studio. SQL Server is the actual database engine, guys. In SQL Server, we are going to manage our databases, create tables, store data in them, perform different operations on it. Management Studio, on the other hand, is just an user interface to which allows us to connect to the different SQL servers and perform those operations. Okay, Management Studio does not store any data on its own. Everything is ultimately stored in the SQL Server. That is the actual database engine. Okay, this is just a user interface. Right, so here if you notice, the first thing that you see is a window. So this is in the background is the Management Studio, and you will get a window pop up right when you open it. The first thing that you will see here is the server type. We are going to work we are going to spend all of our time over the next 8 to 9 classes on the database engine itself. The rest of them are BI components, so I'm not going to go into them. So we are going to use the database engine going forward. And then here, if you are attempted to connect to a default instance on your system, you just have to provide your laptop name. So this is my laptop name. This is the name that I've given to my laptop. Now I can also use a dot, okay, to be able to connect to my default instance. But to connect to a named instance, you need to provide your laptop name, as you can see here, slash, and then the instance name. You remember this name? Let me again take you back to services. So if you see here, this is the instance name, MS SQL Server 2019. So that is the name that I have to provide here to be able to let Management Studio know that, okay, from this laptop, I want to connect to this instance of SQL Server, right? So I'm pinpointing it directly to that server. And then coming to the authentication mode, we have two major authentication modes. One is the Windows and the other is the SQL Server authentication. Okay, I'm not going to talk about the Azure ones right now. So the Windows authentication, when we choose the Windows authentication, it'll automatically use the user that you have used to connect to your Windows. So this is my Windows user that I've used to connect to my Windows, log into my Windows, and it automatically takes this one as the credential to connect to this server. Okay, that is where I was saying, when you install, there will come a window where it'll ask you to add yourself as an admin to the server. So make sure you do that, because if you don't, then you won't have access to your own SQL server. You might have to repair it all over again. All right, because obviously, I mean, if you don't have access, no one else will have it. So you might have to repair it again. So spend your time carefully looking at how to install it. Now, Windows authentication is when it'll use the Windows credentials, and then I can also use SQL Server authentication, wherein you will be asked to key in a combination of user ID and password that is SQL Server specific. That means, you see this user Dinesh Test. So there is a user ID password combination called Dinesh Test that I have configured on this particular version of SQL Server. Okay, it has no relevance outside of SQL Server whatsoever. Okay, the SQL Server authentication helps us connect using a generic account. Okay, not with your own account, but with a user ID and password combination that is configured on the SQL Server itself. Okay, so you can use the Windows authentication or the SQL Server authentication. Now, very recently, I've seen projects and companies preferring more of Windows authentication. Why? Because we can have more monitoring, more control when people use their own Windows user instead of a generic user. Because see, let's say you all had access to this server. Okay, for now you won't have it, but let's say you all had access to this server, the SQL server, and all of you connected using this user ID and password. So if someone is monitoring, they'll see that all the queries are being performed by this user. Okay, but they'll not have the exact username of the user who is performing the operations, because all of them will be connected using this credential. So very recently, I've seen a drift in or a shift in people people in developers or administrators or teams choosing Windows authentication, choosing to use Windows authentication more, because uh, it is, I mean, you can monitor the server well when everyone is connected using the Windows authentication, then the SQL Server authentication. Okay, so I key in all my details here and then I click on connect. Now when I connect, what will happen is the Management Studio will send an authentication request to this particular instance of SQL Server hosted on this machine. This request will go to the SQL Server service of this particular instance. So if I click on connect, it validates it and it lets me into the server here. Okay, my SQL Server is now well connected, as you can see. Correct. Now this is called as the Object Explorer. So once you connect to your SQL Server, these are the different tabs that you would see in the server. These are the content of the server itself. We will be mostly using the databases, okay, because we'll be spending a lot of our time on database development. The rest of them are mostly used by either the DBAs or the developers to some extent, or the MSBI team. Okay, so to start off, here you have the server name and then what user you use to connect and stuff like those. And the second thing that you have here is the databases. Okay, the first tab that you see here is the databases. When you open it, you'll find two types of databases. One is the system databases, other is the user databases. So user databases are the ones that we create, okay, in the SQL Server, and system databases are the databases that come by default when we install SQL Server. Okay, so these are provided by default by SQL Server, and I have been working from the SQL Server 2008 version, and it has been providing these four system databases itself. Okay, till date I have seen only these four system databases, and it has stayed the same till date. Okay, so the master database, as the name suggests, is like a master to the whole server. Okay, to this whole SQL Server, this is the master database, and this will hold the security related details to this server. That means which user has what level of access, and what uh, what are the different users who have access to which all databases. So it's like a master, it's like a database that stores all the security level configurations in it. Next is the model database. Now next is the model database. Now what is the model database used for? The model database, so whenever we create a user database, right, what happens is the model database is copied as is with the name that we have given for the new database. So we don't create, so every time we request for the creation of a new database, SQL Server just copies the model database, because everything that is needed for an empty database is all configured in the model. That's the reason it is called as a model database, because it has, the model database has everything that is needed to practically create a database. So whenever we request for the creation of a database, SQL doesn't have to do much. What it does is it just copies the model database, and let's say I want to create a database called sales, it just names it as sales. That's it. That's the usage of the model database. Next, coming to the MSDB database. The MSDB database is tightly coupled with the SQL Server agent here. Okay, now what is the SQL Server agent used for? Uh, there can be certain SQL operations that you might be expected to do during the weekends also. Okay, let's say there is a requirement that you need to perform a certain query every weekend in the Sunday during the afternoon. Now, it will be practically impossible for you to stay online in front of your laptop every Sunday afternoon. Right? So, all of these, uh, all of such kind of tasks that we want to run on a weekend when we might not be available on a certain schedule can be scheduled on the agent. So we can create jobs on the SQL Server agent which will run automatically at a certain scheduled time. Okay, now it's the responsibility of the agent to pick up those jobs and run it at the scheduled time. And to facilitate this, we have the SQL Server agent service. Okay, again, this is one per instance of SQL Server. So I have only one instance, so there is only one SQL Server agent service. But yes, if I had three instances, I would have seen three instances of SQL Server agent service. And again, this needs to stay running so that it could keep an eye on the schedules of the jobs and run them whenever it is the time to run them. Okay, so again, this also needs to be up and running so that the jobs can run on schedule. Now, the MSDB database, as I said, is tightly coupled with the SQL Server agent, and it stores all the job related details. like what are the number of steps that are there in the job, when was it last executed, when is the next time it is going to execute, what are the status of the last executions, right? So it stores all such kind of information in the MSDB database. Next is the temp database. Okay, the temp database is like is also known as a temporary database. This is where all our temporary objects will get created. So I'm going to talk about all of the temporary objects that we can create and what are the usage of each of them. But all of those will be ultimately created on the temp DB. And the reason why they are called as temporary objects is because they stay in the SQL Server for a certain amount of time, and after that they vanish on their own. They are disposed on their own by SQL Server. Okay, but for the time frame that they are in the server, they are all placed in the temp DB, in the temp database. Okay, so these are the four system databases and the relevance of each of these in the context of SQL Server. Now, all of these databases that you see here are all created by me. Okay, these are all the user databases. So any database that the user creates are called as user databases. The databases that are by default created by SQL Server is called as system databases. All right, now moving to the next thing is the security folder. Okay, again, we are not going to spend any time on the rest of the topics here, but I'll just give you a brief about each of them so that you stay aware of all of these. The security folder here will have the logins, the roles, the credentials, and everything. So this is basically where we create and manage the security privileges for the whole server. We can create logins, we can modify logins, we can delete logins, we can assign roles, remove roles, okay, for the users on a server level. So this is the server level security for the whole SQL server, because see, there is only one security tab for this server, right? You will also find, if I expand one of the databases, you will also find a security folder here. This security folder will have all the details related to the database security, right? So which user has access to this database, what level of access do they have, all of the access will be related to this specific database. This is on the server level security. The other one that I showed you was the database level security. Next is the server objects, and in here I have only used the linked servers. Linked servers is when you want to uh, connect one instance to another, right? As I said, two instances are completely disconnected from each other, right? So just in case you want to connect two instances together, that is when you'll have to create a linked server. Basically, you'll have to link that server in here, okay, using a certain credentials. You'll have to link it here so that while writing queries on this server itself, on this SQL server, you can extract the data from that server too. Okay, again, I'll not be able to demo this because I don't have another version of SQL Server installed, but you must have got the gist of it, right? If you want to extract the data from another SQL Server instance in using your current instance, that is when you need to use the linked server concept. Okay. Uh, then there is a concept of replication. Again, a very interesting concept. You can read about it if you have some free time sometime later. Replication is when you want to replicate data that is modified or created in one table, in one database, or in one server, and move that change to another database, server, or table. Okay, that is when you want to keep two objects in sync. Let's say I have an employee table in one database, and I have another employee table in another instance, uh, in another instance altogether, in another database. So in that case, I can set up replication between both the employee tables across both the instances. One of them will be the publisher, basically the source, okay, where the actual changes are done real time. And then once the change has been done on the source employee table, it will be propagated. The same change will be done on the other table as well, which is called as the subscriber. The replication engine will take care of it. This is another very good feature that was added, I think, in the 2012 edition of SQL Server, I guess. No, I think it was, yeah, 12, I guess. But yeah, it's a very cool feature. You can read about it, but again, I would recommend read about it once you are pretty comfortable with SQL query writing and stuff like those. I haven't used Polybase at all. I've used I have very less details about the always on high availability. Again, this is something that has been introduced in the SQL Server 2012 edition, and it's been there since then. So this is used for disaster recovery. Okay, let's say you have a very critical database, and you want to you want to make sure that the database always stays online. Okay, but there can be certain situations where the database might go offline, right? So what do you do to make sure that the users aren't impacted at that point in time also? Okay, the business keeps running. This is when the always on high availability really helps. So if we put that database on the always on high availability, what will happen is SQL Server will create an exact copy of that database, which will stay as a secondary, or which will stay as a standby. So unless and until the primary database is good, the standby will stay like that. The moment the primary database is goes offline for some reason or the other, the standby database will now take charge and will accept all the queries coming in, and will also give us time to fix the primary database in the meantime. Okay, so this with this setup, the database is always available, right? So once the primary database is fixed again, we can sync all the changes that has been done on the standby database into the primary, and then make the primary go up again. Okay, and the standby again comes and becomes a standby database. Okay, so with this setup, the database always stays available. Next is the management tab here that you see. So you can see all the SQL Server logs, starting from logins, how many logins have failed, how many logins are successful, and then you can create some different maintenance plans, like if you want to if you want to back up your database, restore your database, if you want to perform certain maintenance plans on your database, you can do it from here. Again, purely database administration stuff here. Database email, you can configure and send emails from your database using the SMTP server, the mail transfer protocol server. Again, the MSDB database, if you remember, will keep a track of all the mails that are sent and what time, what is the status, what was the content of the email, if there were any attachment or anything. So it will store all those details in the MSDB database. So every mail that you send will be stored as an entry in a table in the MSDB database as well. Okay. Right, so this is a brief walkthrough of this whole of all the components that are available with any SQL server that you connect in your management studio. All right. So let me open. You're welcome, Sayed. Let me open the module 1 PPT. All right. So as part of module 1, we have spoken about a lot of things in this module, but let's just go through it real quick. All right, yeah. So as part of this module, we should have ideally talked about what a database is about, the types of database architectures. You remember we spoke about the DBMS and the RDBMS, that is the different types of a database architecture, then introduction to SQL, and then what are tables in SQL Server, right? So we have discussed about all of these, but let's just go through the PPT real quick here. What is a database? An organized collection of data stored in an electronic format, obviously, and the main operations involved are storing of the data, retrieving the data, and manipulating the data. So these are the three main operations that are supposed to be performed on a database. Okay. Database management system, as we have discussed already, is a software for creating and managing databases in different forms and formats. We have two types of architecture, as already discussed. One is the file-based, which is the DBMS, a typical DBMS. The other is the client server, which is a RDBMS, wherein we have a SQL Server or a Oracle, and then multiple different tools, applications connect to this in the form of clients. Right? So we have a server, and then there are clients connecting to the server to retrieve or perform operations on the data. In a file server architecture, the data is stored in the files and is hosted on the system. Right? I've shown you an example as well. We have an original file, and let's say we create a copy. Okay. One of the limitations is that if we make changes in the original file, there is no way we can propagate the same change to the copy. Okay, the flat files do not allow us to do that. Okay, whereas in RDBMS, the example that I just gave the replication example, and using some other techniques also, you can replicate your data to the copy as well. As far as the access is concerned, this is also that we have spoken about in a brief. That let's say the data is stored in the files, and one of the user is already updating the file. There is no way another user can also update the file at the same time. Right? So it needs to be all coordinated and in a sequence. That means once the first user is done making the changes and saving the file, only then can the second user open and edit the file after that. In a client server architecture, or as we call it as the RDBMS that we discussed earlier, in this we have a central database server, or which is our SQL server. In that we will have multiple databases, right? So we can create multiple databases in our SQL server, and then other systems or clients, as we call it, will be connecting to the SQL server using the OLEDB components. One of them is the management studio, right? The management studio helps us in connecting to the SQL server itself. There can be an application written in Java or .NET that can connect to the database server again. There can be a tool using which you would have built reports, like using Power BI or Tableau, that also connects to the database server to get the data for reporting purposes. Right? All of them use the OLEDB components. What are OLEDB components? OLEDB components are like drivers, okay, system drivers or Windows drivers that helps us in connecting to the SQL Server. Okay, so these are like the intermediate drivers that you need to connect to SQL Server and open a connection and perform the different data operations. Okay, so we have one database server, and then multiple clients or utilities can directly connect to that particular database. Quick introduction to SQL. SQL stands for Structured Query Language, and it's a standard language for accessing and manipulating databases. So as I said, SQL is just a language. Its full form is Structured Query Language. It's a language, and it can be used across platforms like Oracle, Teradata, PostgreSQL. You can use them across platforms in that helps us in accessing and manipulating databases. Okay, the format and the syntax might be different, slightly different in different cases, but more or less is the same. uh, SQL is a language, right? In a particular language, like Java is a language, .NET is a language. Now inside the language there can be multiple commands that we can use. So SQL also has different categories of SQL commands. One is called as the data query language. This particular, the command inside this, under this bucket, helps us in querying the data from the table, in retrieving the data from the table. Okay, that is the select command. So the select command helps us in retrieving the data that is stored already in the table. Now the other category that we have, another category that we have is called as the data definition language. Data definition language, or as we call it as a DDL, it helps us in defining the structure of the tables, because we are defining the structure, right, where the data will be stored, how the data will be stored, by specifying the structure, how many columns will be there, what are the data types that it can hold, right? So there are different commands that are categorized under this bucket, under this category, are create table, that helps us in creating a table. We'll see in detail how to create a table, okay, but for now, just to understand the different categories, I'm just trying to categorize these commands here. So the create table helps us in creating a table. Alter table helps us to modify an already existing table.
Just a quick info, guys. Test your knowledge of SQL by answering this question. Which SQL keyword is used to retrieve a maximum value? A. Most. B. Top. C. Max. D. Upper. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Okay, the structure obviously, and then the drop table will help us remove the table entirely from the database. Okay, so all these three commands are categorized under the data definition language. Then we have the data manipulation language, and under this this set of commands helps us in manipulating the data. Okay, so the earlier one was helping us design the tables or the structure, whereas this is more on the data, right? So the commands categorized under this are insert, which will help us insert rows into a table. Update will help us update already existing rows in the table, and delete will help us remove records or delete records from a table. Okay, so clearly the drop table removes the entire table and its structure and the data, everything, whereas the delete only helps us deleting certain rows from the table. Okay, that's the data manipulation language, or as we call it as the DML. Then we have the data control language, or as it is called as the DCL, that helps us control the access privileges of certain users on certain objects. So for example, if we want to grant or revoke the permission of a certain user from a certain object, then we use the grant or the revoke command. We are going to talk about all of these commands in detail in the upcoming sessions. Okay, so you don't have to worry about those. What are tables? I've already given you an example in the form of the employee table. So tables are basically objects which comprises of rows and columns, which we use to store the actual data, right? So all the data that we think about or that we want to store are all stored in the tables. Okay. Next, we have fields and records. A record is basically a row in a table, that is clearly understood, and a field is a column in the table, right? So a field usually gives out information related to the entity or the, so in this case, let's assume this is an employee table. A field usually gives out information, gives out specific information about an entity, like what is the department, what is the gender, what is the age. So basically a field is a column, whereas a record is all the details about one entity. That is all the details about Sam, all the details about Bob, all the details about Anne, and so on, right? So a record is a row, whereas a field is a column. A field provides specific information about the data in the table. So as I said, salary, employee ID, name, age, gender, and everything else. So all of these provide specific information about the data in the table. Moving on, we have records. As we just discussed, each individual entry in a table is called as a record. We are here, right? We have connected to our SQL Server. Now, how do we go on from here? We have connected to our SQL Server. Let's say I want to retrieve some data from a table in a database. How do I retrieve it? I need to write a command, right? I need to write the select command somewhere. Where do I write it? I need to open a new query window. Okay, so when I open a new query window, you will notice that it'll open a pan for me to write my code in here. Okay, now if I write my code and execute, where is it going to get executed? So this is a very important aspect of the query window. Okay, this is what you need to keep an eye on. If you look at the right bottom part of your screen, right hand bottom corner, you will see that it has the server name, right? It has the user which I've used to connect to my system. More importantly, it also has the database on which the connection is established right now. So that means if I run a query on this window, it'll get executed against the master database on this particular instance, right? So let's say I have a few queries like this. I have 4 queries like this written here. If I want to execute, let's say only 2 of them, I can highlight these 2 and execute. If I want to execute only 2 and 3, I can highlight these and execute. If I want to execute everything, I don't have to select anything. If I just execute, it'll execute all the 4 queries. Okay, now just a moment. So here, all right. So how do we execute a query? There are 3 options to execute a query after we write it. One is the execute button on the top. You see here, execute button here. So you can use, after you highlight the query, you can execute the query by pressing the execute button. You can also use F5 shortcut key to execute. So first you can highlight your query and then press F5 to execute your query. Okay, now in the new keyboards you also have a function key. So if F5 doesn't work, try function and F5 together. You can also use control plus E. E stands for execute. You can use control key plus the E key together to execute a query on SQL Server. Now, this is my preferred way of executing a query because I find it more convenient because while I'm writing my queries, all my fingers are on the character keys, right? So reaching out to control and E is far more easier than going up to the F5 button on the top. Okay, or as a matter of fact, going to my mouse and using the execute button. So I usually prefer using the control E. I know but it is entirely up to you, whatever you wish to use. All of these 3 options does the exact same thing for us. Now, this is a very good practice that I would encourage each of you to follow now that you are getting into a programming language. If you already have experience in another programming language, well and good. If not, always remember to put comments in your code. Okay, this is a good practice that you can follow in any programming language that you work on. Always try to put comments in your code. Now, what are comments? See, all the code that we write, we might not be there physically available everywhere to explain the code that we have written, right? So let's say I write a code today, I might not be available tomorrow in the same organization, in the same team, to explain everyone what I have done there, or why did I choose to write the query in that particular manner. That is where comments come in very handy. Comments are basically one or multi-liner explanation about your code, which will help convey your motive or your way of understanding to anyone who looks at your query. Okay, so it is basically explaining what you have done to anyone who looks at your code. So before you write any query, make sure you put a comment that explains why and why do you choose to write that particular query there, or why did you write that particular command there? Okay, so that anyone who looks at it gets a clear understanding of what approach you have followed in writing that particular query. This is a sign of a good developer, a good software engineer. Okay, you are not there just to build solutions, okay, just to give solutions to the problems. You are here to build something good, and this plays a very important role. Okay, I'll tell you how. These comments will help save a lot of time in to and fro communication, in removing a lot of confusion, and in also saving a lot of time of analysis. Okay, because let's say there is a very complicated piece of code that would have taken me 4 days to analyze. Okay, but I have spent that 4 days to analyze. What if I give a brief explanation on top of that code saying, okay, this code does these all stuff. So the next time a person who or a developer who looks into that code doesn't have to spend again 4 days to understand everything that is written. Instead, he or she can look at the comment that I provided on the top, and that is going to save time. So it is like a continuous improvement. You are helping the team or the project save a lot of time, right? That is how comments come in really handy at times. Okay, and this is something that I recommend everyone, that wherever you are, whatever you're doing, make sure you put in comments. It comes handy for others, and sometimes it comes handy for you as well. I've seen instances where my comments have helped myself a lot as well. How? Let's say I got to work on a very complicated module today. I figured out everything. It took me a week to figure out everything, put a fix on it. Let's say now it started working again. 3 years, 4 years down the line, by the time I would have already forgotten this whole entire this whole module entirely. I again get an issue on that particular module. Now I open the piece of code to fix it. There you go. I have the comments, so I don't have to again spend the whole week analyzing what did I do the last time on this particular query, right? So it not only helps others, but it sometimes helps you as well. So putting comments is, I would say, one of your responsibilities. Okay, once you do that, I mean, you so it's like gaining blessings at work. Okay, that is how you gain blessings. Someone looks at your code and sees the comments, they are going to definitely bless you. Okay, and I've seen that. I mean, I've seen uh, people gain a lot of respect, people gain a lot of recognition for the work they do, and not only that, for the way they have maintained their code also. Okay, now how do we write comments? As I said, there can be one liner explanation, you can have multiple lines of explanation. Now one liner explanation in SQL or one liner comments can be prefixed with a double dash, right? And then you can put your comment whatever you want. If you have multiple lines of comment, you need to put it inside this structure. You see the slash and the star, end it with the star and a slash, and you put all your lines of comments here, all your explanation in here. Okay, if you want to write multiple lines, stick with this pattern. If you want to write a single line, stick with this pattern. Now these are comments, right? So if you notice, if I execute these, it just says commands completed successfully, but nothing would have happened because the comments are not considered as actual queries in SQL Server and in any programming language. Okay, comments are always ignored by the compiler while executing the code. Okay, now this one that you see here is called as the results window or the results pan. Okay, now this again, one of the things that I always prefer is having a clean query window. That means I need to have enough visibility of my query at all times. So I don't like it when this window is up when I'm working on my queries. So I can hide this. What people do is that I find very irritating is they'll drag it like this, they'll drag it like this, and then, oh, I don't see my messages window, I don't see my results window. Where is it? Where is it? Okay, I don't see it. No, don't do anything. Just let it be here. You can always hide and unhide it using a shortcut key, Control R. See, Control R hides it, Control R shows it up again. Hide, show. Okay, and whenever you execute a query again, it'll automatically come up. See, for example, this one I'm executing, it just comes up again, right? So this is again a shortcut that you can use that comes in very handy for me, because I don't have to drag my results window up and down on my query window. Now, how do I comment a line of code? If you want to use a shortcut, you can use Control KC, or you also have two options here. You can highlight this line and say comment, so it'll comment it. You see, automatically it adds two dashes in the front. Okay, if you want to uncomment, you can just again select the line and say uncomment the selected lines. Okay, so you see all these comments shows up in green color. That means they are not going to get executed. You see here I put a multi-line comment in here, the starting of the multi-line comment, the ending, and all my queries, all my comments goes here, all my explanation goes here. All right, so that being said, let's see how do we create a database. Let's start by creating a very simple database. There are two options using which we can create a database. One is using the transact SQL, which is the T-SQL query itself, in which we can create, we can say create database, and then we give a name to our database. So here I say Intellipaat. I usually prefix it. I usually give a name, give a date on which I create the database for each of the batches. Okay, so we are going to create a new database with this name.
Just a quick info, guys. Intellipaat provides SQL online training in partnership with Microsoft and mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
Okay, now this is one way of creating the database. The other way is by using the graphical user interface, right? So basically you will find a window in SQL Server that you can use to create your database. How can you do that? Right click on the databases here and say new database, right? So this is the window that will come up. This is what I call as the graphical user interface, right? So you can give your database name here again. Let me provide the name here. Okay, so the moment I paste the name, you see a section here that is called as the database files. Okay, so this is what you need to know. Whenever we create a database, SQL Server internally creates two files in the background. Okay, one is called as the MDF or the master data file, and the other is called as the LDF or the log data file. Okay, now this is SQL Server's own way of storing and managing the data internally. By the way, it is all encrypted. You will not be able to see any of these files or read any of these files. I mean, you will be able to see the location of the files. You will be able to see the files physically, but you cannot read any of those because these are encrypted and can only be read by SQL Server, right? So the MDF file, it holds all the data that we store in our database, right? That is the reason it is called as a master data file. And the other one that we have here is the log data file. So the log data file, so any modification that we do on the data, right? SQL Server tries to log each of them. Okay, let's say I updated a record. It tries to keep a log saying that a record was updated. All those logs get stored in the log data file. So it holds the log of all the changes that is performed on the database. You'll understand the relevance of both of these in detail when if you have opted for the DBA course. Okay, you'll get to know how these come in handy when you want to back up and restore your database. Okay, but we're not going to go much in detail. So basically every database that we create will have two files, MDF and LDF. So that's the reason the moment I pasted the name here, you'll see that there are two file rows here. One is for the rows data, one is for the log, right? So it'll create two files for this particular database, and the initial size of both of them will be 8 MB. And does that mean it'll have 8 MB of data and 8 MB of log to start off with? No, it'll only have a buffer space stored in the file for the upcoming data and the log. Okay, so that means there will be 8 MB of free space reserved for these files. That's it. And once the data and logs keep coming in, it'll get accumulated in these 8 MB. And once the 8 MB is exhausted, once the whole 8 MB is exhausted from the data file and the log file, it'll then be incremented, you see the auto growth option here, by 64 MB. That means if the data file is filled up, the whole 8 MB is filled up, then it'll get incremented to 72 MB, which is 64 plus 8 MB. Similarly, if the log file reaches the threshold of 8 MB, it'll get automatically increased to 72 MB. Okay, again from 72 it'll go up to 136, then 208, sorry 198. So it'll keep increasing by 64 MB. You can choose to change the auto growth or the maximum file size of your choice. Now what is the maximum file size? So these files will be stored in a location in the drive, right? So in here, if you notice, I store my files in this location. Let me open this location so you can see it. Control V, and if you notice, let me expand this. So if you see here, so you can notice that every database, for example, this one has two files. One is the primary data file, one is the log file. You see both of these are 8 MB. Then I have a few which are 73 MB, 72 MB, one that is 136 MB, right? So these are auto incremented. The SQL Server takes care of that, okay, auto incrementing the file size. Now these files are stored in a drive, right, which is C drive. So the max size, when I set it to unlimited, that means the data and the logs can grow until the C drive is completely full. Okay, and once it is full, you will get a warning that the log file or the data file cannot grow anymore. So when you try to store more data into your database, it will start failing. So you need to clean it off or increase the size of your disk. Okay, so with that, if you notice here, so once I say okay, so look at the name here, 7th February 2021, right? So I say okay here. So the database will now be created. And if you come back here, look at this one. We now have two files. One is the primary data file, one is the transaction log file for our own database. And if I take you to SQL Server here, what will it go? Oh, okay, yeah. So if I go to SQL Server here and if I open the Object Explorer, see I have a new database now, which is Intellipaat 7th February 2021. Right? So I have my database created here. Now, once the database is created, right, you cannot again create a database with the same name. Okay, it'll ask you to create another one with a different name. Okay, it will not allow you to have two databases with the same name. So that means we have created a database now. Now if you remember, I told you earlier that whenever we execute a query, it'll get executed against the master database, because see now it is connected to the master. How do we change it? There are two ways in which you can do it. One, you can go to the drop down here and select whichever database you want to use further. So we just created this one, right? But I'm not going to select using this one. Okay, instead there is a T-SQL way of doing it again, changing the database connection to say use, and then if you specify the database name, it'll automatically change this drop down here plus this value here at the bottom to now point to our database that we just created. Let me execute, and if you notice here, see in the bottom it now changed to Intellipaat 7 February 2021, and above also you see the same value. So now any query that we execute on this query window will be executed against this particular database, right? So now we have created our own database, and then we have also added it. We are now connected to that database as well. So we've seen how to create a database and then change the connection to the newly created database. But if you want to remove your database, let's say after creation you don't need it anymore, you can drop it. You can so when we say drop, it basically removes the database from this particular instance, okay, and the corresponding files as well, the MDF and the LDF file also. So you just need to say drop database and the database name. Now I'm not going to do that on my system, but feel free to do it on yours and you can recreate the database again. Okay, next, moving on to tables. So how do we create a table in SQL Server? Right? So once we have the database, as I've said multiple times earlier, we are then going to create tables in which we are going to store the data next, right? So how do we create a table? We say create table. Now you need to know three main things before you decide on creating a table. First, the name of the table. Okay, this is necessary because see, the name of the table itself should be corresponding to the purpose of its creation. So if you are creating a table which will hold employee data, make sure you give it the name employee. Let's say you are creating a table that will store the customers data, make sure you name it customer. Okay, give it a name so that you can anyone can look at it and say what kind of a data what kind of data is there in that particular table. So that's the first thing. Second thing is, what are the different properties that you want to create for that particular entity? Like for example, what are the different properties of an employee that you can store in the table? Those will be the columns in your table. So let's say if I want to store employee ID, first name, last name, salary, and address, I go with 5 columns in my table, right? So if you have like 7 or 10 or your own choice, but decide it in advance, okay? And once you're done deciding the table name and the columns, the third thing that you need to decide on is the data type of each of the columns. So when I say data types, I'm talking about the data that each of the column is going to store. Employee ID is going to store numbers, right? So for that, we use the integer data type int. Okay, and then for text values, we are going to use varchar. Okay, and you see the 100 in bracket, that means the maximum number of characters that the first name column can store is 100 characters. Okay, similarly salary is a integer value again, address is a varchar value. Now you see the address is in square brackets. Why? Because if I remove the square brackets from here, you'll see that address shows up in blue color. Why? Because address is a keyword in SQL. That means it has a special meaning. It's like a command that can be used in the context of SQL Server. Okay, so uh, this ideally you should never use a column that's a keyword in SQL. Okay, so either you can go with, if you want to go with this name, make sure you put it in the square brackets. I mean, it's acceptable if you don't put anything also, but then there are other keywords that are restricted. That means you can never use them. For example, order. Okay, order is a restricted keyword. That means you cannot use it as a column name. On the other hand, you see it's already shows an error here if I put order as a column name. But on the other hand, if I put address, it's a keyword in SQL, I agree, but it's not a restricted keyword. That means you can use it as a column name. Okay, so Jennifer asked, in place of 100 we can keep any number. Yes, Jennifer, and it can go up to 8,000 characters. Varchar can have up to 8,000 characters, and Varchar will store alphanumeric characters. Yes, Deepthi. Okay, and for special characters there is another data type called the nvarchar. Okay, for special symbols, I would recommend using the n varchar. But for alphanumeric characters, varchar should be fine. Address can be integer characters, then why only character? Oh, as I said, varchar can store alphanumeric. Okay, so it can store characters and numbers both, whereas integer will only store numbers only.
Just a quick info, guys. Test your knowledge of SQL by answering this question. Which of the following SQL clause is used to delete tuples from a database table? A. Delete. B. Remove. C. Drop. D. Clear. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Aggregate functions. Okay, so what are aggregate functions? As the name suggests, these functions operate on a collection of values and returns a single value. For example, if you want to, so in case you want to get the maximum of salary from the employee table, this is how you write it. You say select max of salary from employee. Let me just quickly change the connection to our own database. Intellipaat 17th, this one I guess. Okay, so if I want to get the maximum of salary from the employee table, I just say max of salary and it gives me 5,000, which means that 5,000 is the maximum salary, that is maximum salary amount present in the employee table. Okay, now if you see here, it shows as no column name. The reason is when you aggregate a column, the column name goes off. So you need to give it an alias name so that you can see the name of it. So here I say max salary, and when I execute it, see, now you get the column name as max salary. Now you can also filter your data. Let's say you want to get only the maximum salary where the address is India. So you say address equal to India. So now it will give you all the maximum salary which belongs to India. Okay, for the employees belonging to India. I think it's IND. Let me see, what do we have in them? So let's start from employee. Yes. Oh, I have a space, my bad. So here India. Let me execute this. You see, so you can also apply your filter conditions before your aggregation. So the where clause works before, or it is executed prior to getting the maximum. So first it filters the data to get all the employees where address is India, and then gets the maximum of salary. Similarly, if I want to get the minimum of salary, I say select min salary from employee, and here I see that the minimum salary is 1,000 for the whole employee table. If I want to see the average salary, I say select average of salary from employee, and it gives me 3071. Okay, which is nothing but, so average is nothing but sum by count, isn't it? So when I say select sum of salary divided by the count of employee ID from employee, it would give me the exact same amount. Let me show you by executing both of these queries so that you can confirm. See, when I execute these two, you see both of these has 3071. Okay, so this is how you can get your average. Now you can either take a count of employee ID or you can do a count star. So there are multiple ways in which you can count it. Like for example, you can say count one, you can say count star, or you can say select count employee ID, for example, okay, from employee. Now all these will return you the exact same output. See, it gives 7, 7, and 7. The problem with this is that when you say count star, it gets, so this one, it gets all the data into memory and then counts the records. In here, it gets all the employee IDs into memory and then counts the records. Now the problem with this approach is the nulls in the employee ID might not be counted as a row. So that is the demerit associated with counting only a specific column. Okay, if it is a primary key, you can go ahead and calculate it. You can go ahead and count it. But when you count it, count any other column which is nullable, let's say, then if it is null, if one of the row is null, then it won't count it. So basically, let's say in the employee table, if one of the employee ID had null, it would have counted only 6 rows instead of all the 7. So that is the demerit associated with this. The demerit associated with this is it takes the whole table into memory, because we are saying count star, right? So star means the whole table. So it takes the whole table into memory and then counts the rows, which is again a bad approach. I mean, why do we want, for a very simple count operation, why do we want SQL Server? It doesn't makes any sense at all, right? But then there is the count one. Now, what does count one mean? One is basically a integer value. It's a plain number. Okay. Now here I can say, let's say this. Let's say select star from employee. Sorry, select star from employee. What do I get? I get the whole employee data, right? So if I say comma one, this is another column, right? One is another column. So here I get all the ones. See here? So it basically, you remember we used to derive column here, right? Like we used to say year of something. It used to give us one more column. So similarly here, I'm just hard coding it to one. So when I run this, it gives me all the ones here. Now, if I remove the star, let's say I remove the star, what will happen? So when I remove the star, it will basically give me ones for every record in the employee table. And then I can do a count of one in here. This is the most efficient way of counting it, because it is now not taking everything into memory, but just taking the hard-coded ones into memory and just counting them. As simple as that. Okay, so we can use any hard-coded value as an acknowledgement to count the number of records in the table instead of counting the star. So these are all the aggregate functions that are available with SQL Server. Okay, so moving on. So next, let's talk about user-defined functions. So what are user-defined functions and why do we create them? So the user-defined functions are, so we have spoken a lot about the system-defined functions, the functions that the system provides to us. Now let's say we want to create a function for our own use, which is not easily achievable with the system-defined functions. In that case, we create our own user-defined functions. Okay, now what are the different types of user-defined functions that we have? The first is called as the scalar value function, which you already know returns only a single value. Okay, and then we have the table valued function, which returns the output in the form of a table. Now, if you have realized, the system-defined functions doesn't have any table valued functions as such. Okay, they are mostly scalar valued functions. User-defined functions, we can create table valued functions, and they are again of two types. One is inline or single line table valued function, and the other is known as multi-line or multi-statement table valued function. Now, what is an inline table valued function? The function in which there is only one single line that returns the table is known as a single line table valued function. Easy definition. Okay, and the second one, which is a multi-line, is a function which has multiple lines that helps us return the output in the form of a table. So clearly the function that returns the output in a single line is called a single line table valued function. The function which returns us the output in the form of a table using multiple SQL statements is called as multi-statement table valued function. So let's start with talking about scalar valued user defined functions. Okay, and these are functions which we write. Earlier system defined functions were functions that are provided by default with SQL Server database. Okay, but scalar valued user defined functions are functions that we write that accepts input parameters and returns a single value. So a single value could be 1, 2, 5, 10, Dinesh, John, anything, today's date, and it can return any data type. That means it can return varchar, it can return integer, it can return date time and whatnot. Also, a single function at a single point in time will return only one data type. That means you cannot use a scalar valued function to return two values with two different data types, because it is a scalar valued function. It can only return a single value at any point in time. Now, let me show you how to create a user defined function. The example that I'm going to give you is how to create a or how to generate a full name from two given input parameters. I know you can do it with other system defined functions, but yes, just giving you an example as to how you can create your own user defined function. So here you say create or alter. Now, why do I say create or alter here? The reason why I say create or alter is because let's say I'm creating this function for the first time in the server. Our motive whenever we are executing any type of SQL query is that our query should never give us any error. Okay, it should not throw any error at any point in time. So we need to prepare our query which is re-executable. That means irrespective of how many ever times you execute, it should not throw any error. Now, when I only say create function, that means every time I run this query, it'll try to create that function. And let's say it created the first time. The second time when you ask it to create, SQL will say that, hey, it's already there. I cannot create it again. So you need to alter the second time. Okay, right. So here, if I say only create, it'll throw me an error if it already exists. But if I say create or alter, SQL will automatically identify if this function is present in the server, in the database or not. If it is present, if it is already existing, then it will alter it. If not, it will create it. Okay, so here I say create or alter function, and then we give a name to the function. Now, giving the name is also an art. It's also an art, okay, to be frank with you. Very few people I've seen give good names to their objects. Okay, you need to build this quality in yourself. Okay, you need to make sure that any object that you're creating, it could be a table, it can be a view, it can be anything, any type of object that you're creating, you need to ensure that you give a proper name to your object so that anyone else looking into that can understand what exactly is it, does it contain, or is it going to do. So here, first of all, I prefix it with fn underscore. Now this is also an important aspect. Why? Because here, from here onwards, any object that we're going to create, I would say, except for tables in the database, any object that you create, make sure that you give them a prefix so that you look at it and know what type of an object it is. So here, when I give a prefix of fn underscore, I know that, okay, this is a function. So I give it a name saying fn underscore so that I know it's a function, and then name that justifies the purpose of that particular function. So here I say get employee full name. That is, this function is going to give us the full name as an output. And then you remember when we were executing functions, we were passing input parameters. You remember? So with this, with our function also, we can design it to design so that the user can pass input parameters. So this is where we define how many input parameters can be passed to the function. So here I say the first parameter is first name, the second parameter is last name, and both of these are of varchar 50 characters in length. Now, if you have observed, these have at the rate as a prefix. That's the reason they are called as input variables or input parameters. Remember when we were talking about variables, I said that you need a at the rate in the front which categorize them as variables. So here I say this function is going to take two input parameters, and then is a very important aspect again of the function, which says here I'm going to specify what is this function going to return as an output. So this function I say is going to return varchar 101 characters long. So the first name is of 50 characters, last name is of 50 characters. Now, if I'm generating a full name, obviously I'll separate these two with a space. So that's the reason I give 101, 50 plus 50 plus 1 for the space. So this function is going to return 101 characters in a string of 101 characters as begin, and then we specify the core of our function. That means what is this function going to return. So here I say return, and if you see here I say select, I trim off the first name basically to trim off the spaces if there are any. So let's say there are some spaces in the front of the name or at the end of the name, I just trim off those spaces, and then I concatenate it. I add a space in between and then the last name. Okay, and now let me create this function. So see how many ever times I execute it, it doesn't throw me an error. because I have the create or alter here. Now, where can you find the functions in the server? Go in here, go to the databases. In this database, go to programmability, and in here you will find functions and then scalar valued function. See, this is the function that we just created, function underscore get employee full name. And if you see the parameters, see it accepts two parameters. One is first name, one is last name. Now, how do we call these? You already know, right? How we call this? So we usually say select and then the function name, right? Select and then the function name and then the input parameters, isn't it? We used to pass John and Smith. Let's pass John and Smith as the first and the last name, and I give it an alias name saying as full name. And this, when I run it, it gives me an error. It says the function is not a recognized function name. Now, this is something odd, isn't it? The reason is you need to specify the DBO before your user defined scalar valued function call, so as to ensure that the optimized what actually happens is when I say select and then I put the function name, SQL automatically anticipates or assumes that it is a system defined function. It doesn't understand that it could be a user defined function as well. So it always looks into the collection of system defined functions. So how can we force SQL Server to look into the user defined functions? By specifying the schema name, because no system function will be created or can be created in the DBO schema. This is basically for the users only. So when I say DBO dot, now it should work. But this is not ideal in case of tables, isn't it? In tables, we don't specify the DBO schema name because by default it is the DBO schema. But the case is a little different with only user defined scalar valued function. So that's the reason we need to put DBO in here. So when I pass John and Smith, see, it gives me the full name as John and a space and then Smith. Similarly, if I pass Dinesh and Kumar, it would give me Dinesh Kumar as output. Now, if I want to probably show you one more example, create or alter function, let me create one more function which will add numbers for us. So the input parameters should be two numbers. Let's say number 1 and number 2, both are integers. And obviously the sum will also be an integer. So I say returns integer as begin, and here I return saying select number 1 plus number 2, because this function is going to add up numbers for us, right? Now this I'm showing you very simple examples, okay, but you can think of any redundant job that you're planning, that you are doing at your job place, and try to put it in a function. But again, you need to remember that no DML operations are allowed. So only redundant select operations can be put in the functions. And now if I run it, I create this function and try to, so this one also is create or alter, and if I try to run it, it gives me 3, the sum of 2. 10 plus 15 gives me 25. Simple. And this is the same notes that I was explaining you earlier. So the next topic that we're going to talk about is on the user defined functions. I told, so till here we spoke about the scalar valued function, basically the function that returns a single value. Now let's see how can we design a function that will return as a table as an output. So the first one that we're going to talk about is the inline or the single line table valued function. Basically, the table is returned as a result of action from the given parameters, but it is derived from a single select statement. That means, as I told you, the body or the definition of the function contains only one SQL statement. So how do we do it? I say create or alter function. Again, I give it a name, fn underscore get employee details. So this is the name that I give to my inline table valued function. The parameter, it accepts only one, which is employee ID, and it returns, you see here, now I say table. So earlier we were specifying either varchar or integer. Now we are specifying as a table. So it returns a table as an output as, and then in the return, you see here I don't specify begin and end. The reason is we know that the function has only one SQL statement inside. And when you have only one SQL statement, you don't need to specify the begin and the end. Okay, basically for single line function you don't need begin and end, but for scalar valued and for a multi-line table valued function you will need the begin and end. So only for this one you can skip the begin and the end. I mean, that's not a part of the syntax. So here I say return, and then if you observe, I'm saying select. So this is one select command. You realize, right? So here I say select, and then I can call my scalar valued function inside the table valued function. This is the function that we just created above, didn't we? So here I say select dbo dot this function name, and then I pass two columns that I have, the employee first name and the employee last name as full name. So I first select the function and then salary and then address. So this is something that you can only do with scalar valued function, not with table valued. Okay, and I say from employee, where employee is equal to @employee ID. Now what is @employee ID? Is the input parameter. So whatever parameter the user sends for that particular employee, it would display the full name, the salary, and the address. Audrey asks, what is the purpose of putting the sign in front of the employee ID? As I told, these are input parameters or the variables, right? So for SQL to identify that these are parameters, we need to specify, we need to put in front of it. So this is basically a naming convention. For parameters, you need to put in the beginning. So now let me create this function. It says commands completed successfully. And now how do we call a table valued function? So it's going to return as a table, right? So we are going to call it exactly how we call tables. So I say select star from function name in bracket the input parameter. You remember the scalar valued function, we used to just say select and then the function name, dbo and then the function name. But here, as it returns a table, we say select star from and then the function name. And if I execute, it gives me full name, salary, and address. Okay, because in the function we have specified a full name by using the function, salary, and the address, only 3 columns. So this is how you can execute or call your table valued functions. No dbo is necessary here, because for table valued functions it can easily look it up on the table valued user defined functions. Only for scalar valued functions you need to specify dbo.
Just a quick info, guys. Intellipaat provides SQL online training in partnership with Microsoft and mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
Let's move on. Okay, next up we have multi-line or the multi-statement table valued function. Now, as I told you, this will have more number of SQL statements in the definition. So how do we create it? The same syntax, create or alter function. We give the name. So here I give fn underscore, which basically represents that this is a function. And then I have get employee details, and you see ml. ml means multi-line. So I give it a name so that I can distinguish. Earlier I gave get employee details, now I give get employee details ml. And then the input parameter is the same, which is employee ID. And then here, if you remember earlier we used to say returns table, returns varchar, returns integer. But now here, in case of multi-line table valued function, we need to say returns, and then we have to specify a table variable. When we were speaking about the temporary tables, so here I'm specifying a table variable with the name @emp, and I specify the columns here, which is employee ID, full name, and salary, and the data types obviously. And then I say as begin, and then at the end I specify end, and inside this I specify my whole SQL statements, I mean all of my SQL statements. Now what do I do here? I say insert into the table variable the columns, and then here I select the employee ID goes into the employee ID column, the full name goes into the full name column, and the salary goes into the salary column from the employee, where emp.employee ID is not equal to the input parameter. You see here? So here what I say is, if I pass, let's say 5 as my input parameter, then except for 5, insert all the other employees into the table variable. So first it would do that into the table variable. Next, it would update the employee IDs which are 2 and 5. The salary will be updated to 5,000. So I write a quick update statement here. And then I delete the records which are 6 and 3, all I'm doing it from the table variable. If you remember, if you see here, because if you remember, I told you one important aspect of functions, that is it does not allow us to perform any DML operations on the physical tables, right? So in that case, I mean, the only exception in that is that we can do it on the table variables. Okay, so here I say insert into EMP. First I insert all the employees except for that, and then I run an update to update the salary to 5,000 for 2 employee IDs. I delete 2 employee IDs from my EMP table variable, and then I insert one hard-coded record. Okay, I try to insert one record into the table variable, and then I say return. Now what does the return keyword do? The return keyword would basically return this EMP table as an output. Okay, so here I already specified the returns keyword, isn't it? I mean, I specified what should be returned. So when I say return, SQL automatically understands that, okay, that EMP table variable should be returned to the user. So now let me execute this. So we now have multiple lines of SQL statements inside the function, isn't it? And now when I execute it, see, I say select star from function and I pass the ID as 4. And here when I run it, see, this is the output that I get. I get the employee ID, full name and salary, basically the structure of the table variable. And the if you see, first what we did was we inserted everything except for the input employee ID, right? So what did we provide as an input? We provided 4. So it does not have a 4 clearly, as you can see. And next what we have is I updated for 2 and 5, I updated the salary to 5,000. So here if you see, for 2 and 5 the salary is 5,000. Now this is all being done on the table variable, mind it. Okay, the table, employee table, isn't touched at all. Here I said delete from EMP where employee ID in 6 and 3. So you should not be seeing 6 and 3 here. And also end of it, I just inserted a record with ID 100, which is here. Okay, so this is how a multi-line table valued function works.
Just a quick info, guys. Test your knowledge of SQL by answering this question. Which SQL keyword is used to retrieve a maximum value? A. Most. B. Top. C. Max. D. Upper. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So what are the other operations that we can perform on functions using in where clause? So I've already shown you how to use the function in the select. Here I can select after star, I can add one more column like you already know, and pass 2 columns in this, first name and last name. And when I execute this, it would give me a whole of employee data and then one column at the end that would say full name. Okay, and next you can also use, so this is only for scalar functions, okay, scalar valued functions. Now you can use scalar valued function in select as well as in the where clause also. You see, in where I specify the function name and then I pass the 2 values as input, basically the columns, and say equal to John Smith. So now it'll return me only that employee which has the full name as John Smith. See, it returns me employee ID 2 which has the name as John Smith. So this is only on the scalar valued functions. You see here, only on scalar valued function you can use them in the select and in the where clause as well. Okay, now for the table valued functions that we have, you can use them to join with other tables. Okay, so to join table with the table valued functions with other tables, there are 2 options. Like we have joins to join tables, we have cross apply and outer apply to join functions to the tables. Now, as I told, these are only the table valued functions. So we cannot join the scalar valued functions because those only return a single value, right? But the table valued functions returns a table. So we can join that with other tables. So first, let's talk about the cross apply. The cross apply is similar to an inner join. So how do we write it? You need to remember this syntax. Okay, it's a little different from how we write joins. Here I say select star from the employee table and then cross apply. Here I say select star from the function and then I need to pass the input parameter. I give it an alias name, say as fn, And this is like your join clause. Okay, this where clause it acts like a join clause here. So I say where e.employee id is equal to function.employee id. So this is like your on clause in the join as x. Okay, so this whole thing I name it as x, and when I run this, you would see that it gives me the data which is an inner join between the employee table and this multi-line function. And obviously without the where clause it becomes a cross join. See, I commented the where clause, and now if I run it, it will act like a cross join. So it will basically multiply, the Cartesian product will be retrieved. With the where, it is an inner join. See, so this is the employee data, this is the function data. Now the outer reply is similar to a left outer join. The syntax is exactly the same. I say from uh, let's say this is the function, and then outer reply select star from employee as e, where employee id is equal to employee id as y. And when I run this, it basically gives me all the data from the function, and then only the matching records from the right table, which is the employee. And if you remember clearly, the record 100 isn't existing in the employee table, so it shows up as null. If you want to do a right join, you might ask, what do you do in that case? To do a right join, you just flip your tables. There is no right join in case of functions. So you just flip your tables like this. Bring your function in here and get your table in there. And here, if I run it, see, it now gets all the data from the employee table. And if you see here, this one is missing in the function because it's 3. You remember 6 and 3, I deleted it knowingly. And then 5 is also missing because, so this is how you can join your system table valued functions with tables in the database. Okay, so in case you want to see the text inside the function, you have a function called sp help text, which you can use to see the content of the function. So I can say sp help text, and I can specify the name of the function to get to see what is there inside of it. See, I can see the whole structure of the function, is it? But this is not easy to read. So what can you make? How can you make it easier to read? You see here on the top, there are 2 methods in which you can get your output. One is results to grid. The other one is results to text. So here I can choose the results to text, and when I execute it, it'll give me the output in text. See?
Just a quick info, guys. Intellipaat provides SQL online training in partnership with Microsoft and mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
But by default, it is the grid because we are always, most of the times, we are retrieving data from tables. But this is one such scenario where text format really makes sense. So once you're done with here, you can see the whole text of the function. But let me switch back to grid. But in case you want to go back and see, and you don't want people to see your function definition, you can hide it by using the with encryption that I showed you here. So this will help us in not allowing the function to be scripted out using the sp help text. So let's say I alter it using the with encryption, and it says commands completed successfully. And now if I run the help text again, you will see that it throws me a message saying the text is already encrypted. Okay, that means it doesn't allow us to see the um, text of the function again. So I was talking about the sp help text. Now before you encrypt it, I use the with encryption, right? And now when I execute it, it gives me a message saying it is already encrypted and you cannot see it. So one thing that you need to remember is when you encrypt something, before you encrypt it, make sure you take a copy of your function, that is the text, store it somewhere safely in a text file or in a SQL file, store it in a repository somewhere, because once you encrypt it, decrypting is a long process again. Okay, I'm not going to go in detail into that, but you need to be a sysadmin on the server. You need to do a lot of things in order to get back your function again. So make sure you store it somewhere safely before you encrypt it on the server, so that I mean, you don't want everyone else to see, so no one else will be able to see it. That's fair enough. But tomorrow, when you want to update your function to something else, let's say you want to make a change, you have to get the function that you have stored in the repository and then change it and deploy it back again, because you will not be able to get the function code from the server anymore. Okay, so make sure you save it safely in a repository somewhere before you encrypt it. So that's about functions. Next up, we're going to talk about the case statement. So what is the case statement? The case statement allows us to write conditional statements during the retrieval of the data. Okay, so for example, if you want to while you're retrieving the data, you want to derive a column based on certain condition. That is when you can use the case statement. So how do you write it? Here you can say, let me just remove this complicated stuff from here. So you can say select star from employee will basically give you all the employee records, isn't it? This gives the whole of the employee data. Now here, if I say to derive a conditional statement, so what I'm going to do here is I'm going to display a message based on the ID. So if the employee ID is less than 5, so I say case when employee ID is less than 5, then display a message saying employee ID is less than 5. If when employee ID is greater than 5, so this is a single statement. Okay, so when the employee ID is greater than 5, then employee ID is greater than 5 in text. Else, obviously, if it is not less, if it is not greater, then it is equal to, right? So I say else employee ID is equal to 5 end. So this is where you actually say SQL Server that, okay, this is where my case statement ends. This is mandatory again. Okay, as the conditional column, this is just a name that I give to my column, and if I run this, it shows me the output in this form. So this is the employee table content, and here the conditional column, you see here I have the values like this, which is less than 5, equal to is equal to 5, and greater than is here, right? So when you want to generate a conditional output like this in your select, you use the case statement. Now for example, let's say if you want to print if a text is palindrome or not. Now what is a palindrome text? A palindrome text is the same when it is reversed. So mom is a palindrome text, which is basically the same when it is reversed. Wow is a palindrome text, okay, which is wow when reversed. Okay, so these are palindrome texts. Let's say I update the first name to wow. Okay, just for an example, so I say set the first name to wow, and here let's update this one. And now what I do here is I say select star case when employee first name equal to the reverse of employee first name, then print it as palindrome, else display as not palindrome. Okay, and as this is my column name. So when I execute this, you will find that, see, this one is a palindrome name now. So it says palindrome, the rest of them are not palindrome. So it shows as not palindrome. Okay, let me update it back to Dinesh. Okay, let me remove this one and let's update this. Okay, so now there is an alternative for case which you can use only when you have two conditions. With case, as you can see, you can write up to as many conditions as you want. You just have to specify when after for each of the conditions. But when you have only two conditions, that is either a true or a false, you can use the if. So with the if, you can say if employee is less than equal to 5, then print this message, else print this message. So if is basically a function that accepts three input parameters. First one is the condition, next is the truth value, that means if the condition is true, the last one is the false value, that means if the condition is false, what should be done. And when I run it, you will see that it gives me the output as this. So for all the ones which are less than equal to, it says less than equal to. For the ones which are greater, it says greater than. And this one is the if condition. Okay, so you can use if. It's a function that accepts only three input parameters. One is the condition, second is the true value, third is the false value. right? Now, coming to the if statement, okay? The if is a conditional flow, okay? This if and case that you see is usually in the select. Inside the select, when you want to specify your conditional statements, you use if or case. But when you want to execute your queries based on certain conditions, you use the if command. So let's say if I say if 1 equal to 2, then select nice. So if I run this, it doesn't display me anything because 1 is not equal to 2, right? And if I say if 2 equal to 2, select nicer, let's say. And when I run this, it prints nicer because the second condition is true. So let me show you. The second condition is true. Now let's say I make the first condition true as well. So if I run this, you will see that it selects both nice and nicer because both of the conditions are true. Fair enough. But these two are two separate conditions. How do I make this into one condition? I say else if. That means if this is true, then it should select nice. Only when the first one is false, then it will check for this condition. See, the else condition here converts these two conditions into a single condition now, the else part. Because now it says check for this else, that means if this one is false. So the else part connects these two statements. Else, if 2 equals to 2, then select nicer. And here, if I execute this, you'll see that it only prints nice. Although the second one is true, it doesn't print it because it only selects the first true value. Now, let's say if I make this one false and the second one is true, it prints the second one. Now, let's say the second one is also false. What will it do? It will not print anything at all. This is where the else statement comes in. So the else statement would execute when all the if statements are false. See, it prints nicest. Only when all the statements are false, then the else statement would get executed. So let me remove this. I think I did this one as well for you. Now, the begin and end is necessary in if. If you have two conditions inside your condition, I mean two statements inside your conditions, then you need to use a begin and end. If you don't use begin and end, let me show you. So let's say you just say if 1 equal to 2, then select first and select second. Let's say there are two statements. When you execute these, it prints the second although the condition is false. See, 1 is not equal to 2, but still it prints second because when you don't have a begin and end, only the first statement qualifies to be in the condition. The other one does not qualify to be in the condition. So let's say I remove the begin and the end and now execute it, you will see that it would print nothing at all. The reason is now both these statements are inside the condition. Okay, so when you want to execute two or more statements in your conditions, then you use the begin and end. Okay, I'm going to start this off by copying two tables, okay, from one of the earlier databases with the name ranking and the population. Just a moment, do we have here? Let's say 10th May, 10th, let's say ranking maybe. So this one and then the population table as well. Okay, so I have both these tables with me. Okay, so in case you have already, you must be already knowing about this select star from employee. When you specify the table name as a single name, it is called as a single name qualifier. If you specify it with the schema, we call it as a double name qualifier, which means you are specifying two things to be able to for SQL to identify the table. In a three name qualifier, you specify the database name, okay, which is this name, dot the DBO, which is a schema name, dot table name to locate the table. So if I execute, it gives us the same table itself, but in case you want to get it. See, I was able to copy it from another database, right? So I specified the database name, schema name, and the table name. You can also have a four name qualifier, which is basically Let me just get the server name. So I can specify the server name dot the database name, which is this, dot schema name dot the table name, and this would give me the same exact data. Okay, so this is how you can use or fetch data using a single name, double name, three name, and a four name qualifier, right? And as part of this module, what we're going to talk about is the order by clause, the group by and the having, except and intersect, union, and union all. Okay, so let's start by the order by. The order by is pretty simple operation wherein we which we use to sort the data that we retrieve from the table. So in case I want to sort the data that I am retrieving from my table, then I use the order by. Okay, so how do we specify it here? Let's say I say select star from employee, it would give me all the employee data as is. Now let's say I want to sort it by salary, so I say order by salary. Now when I only say order by salary, it sorts the data. As you can see the data is sorted based on the salary, but in an ascending order. That means the default sorting mechanism in SQL is ascending. So if you don't specify in what order it should sort, it will sort it in ascending order. See here, I just said order by salary, right? I did not specify the sorting method. So here when I said salary, only order by salary, it sorted all the data based on the salary in ascending order. If I want to sort it in descending, I need to explicitly specify the DESC keyword, and it would sort the data in the descending order, you can see. So it also flips the rows as well. Okay, it does not only sort this column but the whole table itself. Now if I want, I can apply two column sorting as well. That means I can sort my data based on two columns, but the second column sorting is only used, okay, is only used when the first column has duplicate values. That means, let's say for these two employees which has the same salary, for these two the employee ID sorting would be used. Okay, whatever second column you specify. So the second column sorting is only applicable when this first column has duplicate values or the same values. So here it shows 3000 and 3000. That means here it will apply the employee ID sorting in descending order for only these two. For the rest of them, it will still be on the salary because they are distinct values. I mean, they are one value each. So if I run this, you would see that everything is still the same, but only for 3000. If you see internally, the employee ID is first 5 and then 3. 5 is basically higher than 3, right? So it's in descending order. Let's say I make this ascending. Let's say make it ascending. So when I make it ascending, you'll find that for these two, the employee ID is now 3 and 5. So you see the difference? So the second column is only applicable when the first column has the same value. Now let's read what I have mentioned here. So I mentioned in the notes, I've said when there is a request from the business to deliver reports or metrics of some analysis, they might need the data to be arranged in a particular order. Okay, sometimes they might need it. So in that case, we use the order by clause, which helps us in ordering the data in either ascending or descending order. And as I showed you, the default ordering mechanism in SQL is ascending order. And if we want to force the sorting to be in descending order, we need to specify it explicitly with the keyword DESC. And we can have the sorting applied on more than one column in the table, as I showed you. But the second column is only used when the first column sorting returns the same value. And you have to specify the sorting mechanism for each column individually. That means, let's say you apply descending, it is only applicable for the salary column. For employee ID, you need to specify it separately. Now if you don't specify either of these, that means SQL will sort the data in salary in ascending order, employee ID in ascending order. Only if you provide the keyword here, then it'll use these. So let's say I have a third column here. Let's say I have a column X here. This column would be used for sorting only when these two have the same data for two or more rows. Only then the X column would be used for sorting. We can also order data or sort data using the column position or the index of the column. Like for example, here if I say, let's say select star from employee. So what do I get here? I get all the data from the employee table, isn't it? Now, if you see here, the salary is the fourth column, employee ID is the first column. So I can say here order by 4 descending. 4 is basically salary in descending order, and 1 also in descending, like I had in the above query. So you can also use the column position and it should work well. But the problem starts when someone messes with the column list here. You see the star here? If someone replaces it with the columns, now the position goes for a toss. See, the fourth position is address now, and the first position is first name now. This is where it goes for a toss. So we don't prefer using. So now, although I still have the order by same, but only because the selected columns changed, now it is based on the address and on the first name, which is not something that we want. So that's the reason we always keep it with the same column names. We sort it based on the column names and not on the index or the position of the column. This is not the ideal way. As I said, cases when the select statement is altered might be bad for this kind of sorting method. Right. Now, the sorting is different for integer values and for the string values. So for integer values, it can store only numbers, correct? So when we sort it, it will sort it as a whole number. That means it'll be in, if I put this in ascending order, it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then so on. And it'll keep increasing like this: 1, 1, 1, sorry, 1, 1, 1, 2, 2, 2, 3, 3, 3, and so on. So it'll keep increasing like this. But for a string data type, what it does is it does not consider for string sorting. Let's say for this one, DINESH and DIANESH. So how does SQL know which one should be put first, which one should be put next? It cannot compare the string as a whole. So how SQL compares it is, it will compare character by character. So D is the same, I is the same, and then it has N when compared to A. So if I sort this in ascending order, this will go on the top and then Dinesh will be stored, only because the third character is A here and N below. Okay, so string characters are not compared as a whole. It is compared one after the other. So the integer values in the string columns are also compared that same way. So it first compares the first value in each of the rows and then moves on to the next one. So that is the reason 2 is considered greater than 1111, because it only compares the first value while sorting it. And if the first value is the same, then it compares the second value. Okay, let me show you with an example so that you're clear about it. So here I'm going to create a table. Let's say the table name is integer sort, and I create two columns. I create one column here, ID, which is of type integer. Okay, and here what I do is, okay, so here let's create a table which is int sort, and it has one column which is ID of type integer. And when I execute it, let me create this table first of all, and then let me try to, now that the table is created, let me insert these values into the table. It's basically 1, 2, 3, and there are a few numbers here. Okay, I'm inserting into the integer sort table. So let me execute. It says 9 rows affected. And now if I try to select from int sort, let me show you. It has the values in it. Let me try to sort them in ID ascending. And if I run it, you will see that it gives the highest value first, and then 111, 44, 22, 12, 11, which is perfect. Let me sort in ascending and you will see that it is perfectly sorted. See, 1, 2, 3, 11, 12, 22, 44, 111, 222, which is fairly good enough because these are numbers and it should be sorted in this way. Now, let me show you a different thing. Let me create another table called the text sort. And in here, I put the column as ID. The column name is ID. And this time, the data type, I'm putting it as varchar 10 characters. Okay. And let me create this table, created. And I insert the same set of values into the text sort ID column. The ID column is a varchar column, mind it. and let me insert these values. Okay, perfect. 9 rows. Let's see the text sort table. Select, and you have all the values, right? Now let me try to order it based on ascending and see what happens. So let's try to do it ascending and run it. See this, we get 1, 11, 111, then we get 12, 2, 22, 222, and so on. Then we get 3 and 44. So it basically compares character after character instead of the whole number. Okay, so similarly, if I do a descending, you will notice that it has 44 first, then 3, then 222, then 22, and so on. Okay, so the top clause helps us in fetching the top n records during the select statement. So if I just say select star from employee, it would get me only, I mean, the whole employee table. Now if I want to see only the 2 records from the top, I just do this. Now if you, let's say you want to see the top 1 salary, highest salary, you can say top 1 star order by salary descending. So it'll give you the employee who is earning the highest salary, because see, I'm sorting it and then I'm picking the top 1. So the order by executes first and then the top. Okay,
Just a quick info, guys. Test your knowledge of SQL by answering this question. Which of the following SQL clause is used to delete tuples from a database table? A. Delete. B. Remove. C. Drop. D. Clear. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
so next is the distinct clause. The distinct helps us in fetching the distinct records from a table. So let's say I select only the salary column. Let's say I select only the salary column from the employee table. So I get only the salaries, right? But as you can see, there are 3,000. Okay, let's say I want to get the distinct salary, or let's say the address maybe. Okay, this is more meaningful. Let's say I want to select the address. So I get 4 India and 1 Australia and 2 US. Now let's say someone says me, hey, can you get me all the addresses from where our employees belong to? I cannot give them this list, right? Because it has duplicate values. So in that case, I can use the distinct to be able to get only the distinct addresses. Here now I only get 3 values, right? But now let's say I added with the employee first name and execute it. See, I again get 4 India and 1 US and 1 Australia. Now why did I get 4 India again? Because now the distinct works on all the columns that you have put on select. So here I have put 2 columns on select, right? So it fetches me all the records from the distinct of all these, both these columns now. So India and Dinesh is only 1 record. So it just shows it is not duplicated, as you can see. So the distinct gets us the distinct across both these columns now. Now let me remove the distinct here and you will notice something different. See, for the US record, we have both the employees as US and John. I mean, the address is US, then the first name is John. So when I put the distinct, you will see that I get only 1 US and John, because the other one is also the same. So it got duplicated. Now let me put the employee last name here as well. And if I execute, now I get two records for US as well, because the last name combination is not unique anymore. So the distinct helps us in fetching the unique records from a table, or in fact of the selected columns. And when the distinct is applied on more than one column, then it removes the record if it is duplicated across all the columns. You see here, it gets removed only it is duplicated across all the columns. So if you want to get the top 2 highest salary from the employee, you can say select distinct top 2 salary from employee order by salary descending, and here if I run this, I get 5,000 and 4,000. Okay, so next up, let's talk about group by clause. Okay, so how does the group by help us? The group by, so you've known about aggregations, right? So if you want to get the maximum salary, you get it by saying max of salary from the table. If you want the minimum of salary, you say select minimum of salary from the table. Now if you want to let's say get the maximum of salary per address, minimum of salary per address, or minimum of salary per department, that is when we use the group by. So the group by helps us in grouping the data based on certain values like the address, the departments, or anything. Okay, so let me show you with an example. So I have the population table here, which is a very simple table with 4 columns: country, city, town, and population. So each country, as you can see, there are 2 countries here. Each country has 2 cities, city 1 and city 2. And then city 1 has 2 townships, T1 and T2. City 2 has 2 townships, T3 and T4. And then city 3 has 2 townships, T5 and T6. City 4 has 2 townships, T7 and T8. Clear enough? So it's a very simple table. And at the end, we have the population for each of the townships. So T1 has 100 population, T2 has 23, T3 has 87, T4 is 98, and so on. Now, if I want to get the sum of population from the population, so there is a column called population, the table name is also population. Okay, so if I say select sum of population as sum of population, this is just a alias name, and if I run this, this gives me the total population in the whole table. If I want to get the population country wise, I use the group by. I say select country, comma, the sum of population from population. This is where I say group by the country. And now it gives me per country what is the sum of the population, right? Similarly, if I want to get the population based on a city, I say select city, comma, the sum of population group by the city. So now I get per city how much is the population. If I want to get it based on the country and the city, I say country, city, sum of population from population group by country and city. Perfect. Grouping the data based on the aggregated, based on the columns that you have chosen for aggregation. I say select city, sum of population as sum of population from population. And here before the group by, I say where city in city 1 or city 2. Okay, so when I run this, it'll only group the data. It'll first filter it and then group it. So if I run it, it'll filter the data for me saying, okay, get only for city 1 and city 2, and then group the city to get the sum of population. So see, I get only city 1 and city 2 because I specify I need the data only for city 1 and city 2. This is normal filtering. Now, what if I want to filter my aggregated data? If I want to filter my aggregated data, we need to use the having clause. And the having is usually accompanied by the group by. You cannot use the having without a group by. So here, let's say I want to get only those cities. Let me comment this one. I want to get the first, I want to group it based on the city, and I only want to see the cities which have population less than 150, the total population. So I can execute this query and I get these 3 cities. The other one I didn't get it because let me show you. I didn't get city 2, correct? So if I execute this, I get only 185. I mean, I don't get city 2 because it is 185. The population is 1, which is greater than 150. Okay, so the having clause helps us in filtering aggregated data, which cannot be done by the where clause. If I put this where sum of population is less than 50, it won't work because the where clause, let me run this and show it to you. See, an aggregate may not appear in the where clause. So you can only use it in the having here. Me execute and I get only city 1 because I've said in city 1 and city 2 and then I'm using the having. But if I remove this where clause and execute it, so the where clause is applicable before the grouping, the having is applicable after the grouping. Okay, now I remember someone had a question as to in what sequence does the query executes, and this is what it is. So we start from a from, right? From where the table has been, what table has been specified. Then we go on to the join, which is the inner, outer, or cross, whichever it is. And then the on clause, that means on what columns it needs to be joined. Then obviously the filtering happens. Then if you have a group by, that gets executed. Then the having executes. Then the distinct executes. And then the order by the top. And then the select at the end. The select and the column list, it executes at the end. Okay, so obviously the select is on the top, but it executes at the end of it. So this is the sequence in which your queries execute. Okay, so we have already discussed about union and union all, so I'm not going to talk about it much. But one thing that I want to add is, if you see here, I showed you this example, correct? I mean, I showed you how the hard-coded data sets only retrieve or get us the unique records. The union gets us the unique, whereas the union all gets us everything without checking for duplicates. But with union and union all, you can also select from the tables. Like, see, you can here I'm selecting employee ID first name from employee, and here I get what, 1 Dinesh, 2 John, and 3 Santosh, and a lot of other employees, right? I can use a union and select from primary key test. So let's see what the primary key test has. The primary key test has 1 Dinesh and 2 John, which is the exact same as the first two records in the employee. Let me just show you. See, the employee has 1 Dinesh and 2 John, and then the rest of the employees. But in the primary key test, we have 1 Dinesh and 2 John. So I can put a union here in between both the selects to combine them and get one result set wherein 1 Dinesh and 2 John is retrieved only once. If it was union all, okay, which is right below, you should have ideally got 2 Dinesh and 2 John. See here. So this is how the union and union all works with multiple tables. Okay, earlier I showed you only on one record, only on hard-coded values, but now I just showed you with tables as well. Okay, so you can add more tables as well if you want to do it. I mean, let's say I execute this. See, I get two more records. Sorry, three more. Okay, so the union all, but one thing that you need to remember is the columns that you're selecting here should be the same. Now let's say from the employee table I get what, 5 columns. Now I cannot say start from employee union all start from primary key test, because the primary key test has 2 columns and the employee table has 5 columns. I cannot do this. See, it throws me an error saying all queries combined using union, intersect, and except must have equal number of expressions in their target list. That means whatever number of columns you have in here, it should be the same number of columns in here as well. But it's not the case. So that's the reason we need to make sure that the columns are exactly the same. Okay, now it works. There is a except operator which we can use to retrieve. Let's say there are two tables, default test and primary key test. Okay, let's say there are two tables like this. So if I say this except this, what output do you expect? This except this, what output do you think will be coming out? Except is basically these two records except these two records. So that means get me all the records which are in this table which are not there here in the other table. So it's like this, ID and name from defaulted except start from primary key. I mean, I can do the same here as well. I mean, it makes no difference because a primary key test has only 2 columns. So if I run this, you will find 2 no name provided, because this is the only record that is present in this table but missing in this table. But one thing that you need to remember, the except works like a union or a union all, wherein the columns should be the exact same. I mean, not the name of the column, but the number of columns that you have selected. Here we have 2 columns, here we should have 2 columns. The first one is integer, second one is varchar. Here also the first one should be integer, second one should be varchar. So when I run this, it gives me the records in this except the records in this, which is 2 and no name provided. Now the other way around, if I say primary key test except default test, I should get 2 and John, isn't it? Because 2 and John is present in this, but not in this. So let's say if I flip my tables, I say primary key test except default test. So it'll now give me 2 and John. 2 and John is present in the primary key test, but missing in the default test. Okay. Next is the intersect operator. The intersect operator fetches the common records across both of them. Now, this is different than the joins. Okay, the join helps us in joining the data one next to the other, but this is more of a vertical combination of the records. Okay, this takes into account the whole row instead of taking columns to be joined. Okay, so here I say id name from default test intersect the primary key test, so it should give us the common record, and the common record is 1 and Dinesh. So if I flip the tables also, it should be the same, right? Because the common record isn't going to change. The except, yes, I agree, it should be different. But when I say intersect, both of the queries should return the same output.
Just a quick info, guys. Intellipaat provides SQL online training in partnership with Microsoft and mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
Now coming to another interesting aspect, which is the ranking functions in SQL. So what are ranking functions? Ranking functions helps us rank the data. Now, a very common question could be the third highest salary, the fourth highest salary, the sixth highest salary. How do we find them? We use the ranking function. So what are the different type of ranking functions that are available? First is the row number, rank, and the dense rank. These are the only 3 ranking functions that are available with SQL Server. Now, how does each of them work? The easiest thing, the good thing about these is that you have the exact same syntax for all of them. Okay, so how do we write them? Let's say select star from I have a ranking table. If you remember in the beginning of I created 2 tables. One was the population, which I've already shown you. The other is the ranking. The ranking basically has 2 countries, as you can see, A and B, and then it has cities inside each of the countries. Okay, and then the population against it. Very simple table, 3 columns: country, corresponding cities, and the population. Now what I'm trying to do here is, if I want to get let me show you how you can apply the ranking functions on top of this data. So here I say, instead of select star from ranking, I just add one more column here saying row number. Okay, this is the syntax: row number, bracket open, bracket close, over, and then order by the population. So if you're ranking it, you need to basically provide a column on which the ranking should be done. Sounds good? Because so the questions that you get, the queries that you might have is get me the ranks in order of salary, get me the third salary, get me the fourth highest salary. So you need to sort it based on the salary, and then you can get the ranks, right? So here I want to sort it based on the population and get the rank for each of the country, each of the city. So what do? I say star comma row number each of the rows over order by the population in descending order. That means the highest population should be given the first rank, and then the subsequent ones will follow. And if I run this, it will give, see, as you can see, it sorts this whole table in the based on the population, and then assigns a rank value each. The rank value is just the alias name that I've given here, as you can see, rn key value. So it sorts them and gives a row number to each of them. But observe this has the same. So the country A has 2 cities, M and G, which has the exact same population, and it gives them 2 different rank values. And that's the property of the row number. That is how the row number works. It basically sorts the data based on whatever sorting mechanism, sorting column you have specified, and then assigns a row number to each of the records. Okay. The next is the rank function. The syntax is exactly the same as I told you. I mean, the good thing about these is that the syntax is exactly the same. So I just replace the row number with the rank. Now the rank, let's see what is the difference between the two. The rank function again sorts based on the population, but now if you see, for the same value, it gets the same rank. But there's one catch. You see, the next one skips a value. So if there was another city with the same population, it would have got another 3 here, and the next one would have been directly 6. So as many ranks that are used up by the same value, that many row numbers are skipped. So here we had 2 with 3s, so the next one skipped only 1, so it is 5. If we had 3 with the rank 3, 3 records with the rank 3, then it would have been a 6. Okay, now the dense rank works exactly like a rank, but the only difference is that the skipping of the rows is not available here. The ranks are not skipped anymore. You see here, after 3 we get 4 directly. Okay, there is no skipping of the ranks. Similarly, these two values are the same, but this one does not skip any rank. Okay, now you might say, hey Dinesh, so how do I get the highest? So this one I can easily get the third highest or the fourth highest population from the whole table. But what if I want to get the second highest salary per country? How do I get it? So that is where you can use another property of the ranking functions, which is the partition by. So the partition by acts like a group by. Okay, the here what we specify is, I say exact same syntax, but here you can say over partition by country. That means the country A will have its own set of ranks, country B will have its own set of ranks. Let me run this and show it to you. So we have the partition by country and then exactly the same however it was. So if I run this, you will notice that for all the records of A, you get one set of values. Then from B, it is reset again. See, it starts from 1 again. Make sense? But the property of the row number still stands valid. For the same, you get 2 ranks. Coming to the rank, again, let me show you by adding the partition by here. And if I run this, you will see that the same population value gets the same rank, but the next one skips a value. This is the property of the rank function itself. Okay, the reason it skips one row is because there are 2 ones here. Let's say there were 3 ones, the next one would have had 4 directly. Okay, so as many number of rows that have duplicate values, that many number of ranks are skipped in case of rank. Okay, the dense rank exactly works exactly same as the rank, but the only thing is there is no skipping of ranks that happens here. You see here, so we get a set of ranks for A, we get a set of ranks for B. So now if I want to get the second highest salary or second highest populated city from A and B, I can say so let's say here, let's say third highest populated state from each country. I say partition by country. Sorry, partition by country, and let me run this. So what you will see, you already know how it works. The dense rank, it gives us the same rank, and then the next one doesn't skip anything. So as I partitioned it, A has its own set of ranks, B has its own set of ranks, and I put this inside like a subquery. As you can see, this acts like a table. So I say select star from this one as X, where the rank value is the alias name for this one is equal to 3. So if I run this, it gives me 2 records. So for A, city Z has the third highest population. B, for city P, this is the third highest population. For country B, this is the third highest population for country A. Now, if you want the third highest population for the whole table, you don't use the partition by, because then it will not rank it based on the country, but based on the whole table. And if I run this, see, I now see that, okay, country A has 2 cities which has the third highest population across the whole table. Let's move on to another interesting topic, which is about indexes. Okay, indexes are pretty much fun to work with. Why do we need indexes in the first place? The importance of indexes has picked up drastically over the last few years, owing to the fact that we are now using SQL Server to store huge amount of data. Okay, earlier it used to manage like small relational databases, but now that Microsoft has been standing up to its expectations, companies are trusting SQL Server for their go-to RDBMS. So they are pumping in a lot of data, and Microsoft is on top of all these expectations, ensuring that whatever data being pumped in, like irrespective of the volume of data that's been pumped in into any SQL Server, the SQL Server performance should not take a hit. Okay, if not be like awesome. I mean, they don't want the performance to be like great, but it should not at least deteriorate over a period of time. That is what Microsoft's whole motive is behind building indexes. Now, what exactly happens when we write a query? Let's say I write an update, let's say I write a select, let's say I write a delete. Okay, now when I'm trying to fetch data, it could be a plain select. Now, what do you think takes the maximum amount of time? Let's say I say select start from employee where employee name equal to Dinesh. Now, what do you think takes time in the query? Let's say the query takes 5 seconds. 80 to 90% of the time, or I would say to generalize it, maximum amount of the time is taken by SQL Server to locate the employee with the name Dinesh. Displaying it doesn't take time. Okay, but locating the row itself takes the maximum amount of time for any query, maybe. Okay, and with indexes, SQL Server is, or SQL Server tries to give us a mechanism which we can use to locate the rows faster. And if SQL Server can locate the rows faster for us, obviously our query will start executing faster. You get the link? The whole motive, okay, this is what the base target of an index is. The base target of an index is to be able to locate the rows faster. And if you can look, if it the earlier the records can be located, either selecting it, updating it, or deleting it isn't going to take any time at all. Okay, so let me walk you through in detail about indexes and see how they are helpful. So indexes are routes to high performances in SQL Server. And as I explained you, indexes help in faster access by providing swift access to rows in the data tables. Now, how does it do that? I'm going to explain you in a phased manner. This is very similar to an index page in a book. Now, let's say you are given the exact same book to you and your friend. Okay, you guys have the same exact book. Now, you know what an index page is, right? The table of contents that we have in the beginning of the book, wherein it says this topic is located at this page number. This topic can be found in this page number. This topic can be found in this page number, right? So what we do is, now let's say I ask to both of them to locate the topic on joins. Let's say, obviously, I mean, it's a book on SQL, so there will be a chapter on joins. So I just wanted to check where exactly is the, I want both of them to locate the page where the chapter about joins is there. Now, in which case do you think the individual will be able to locate the page faster? Obviously, the individual with the book which has the index page in it, because he can directly read through the index page and see which topic, which exact topic has the topic on joins, and can directly seek to that part of the book instead of checking one each page. But the other guy, he has to scan through the whole book from the beginning till he locates the topic or the chapter on joins, right? And that is exactly how SQL Server indexes work. If you have an index, it is like a book, it's like a table of contents for the whole table. Whereas if you do not have an index, SQL Server will have to search through all of your records to be able to locate that record for you. Now, you take a call which one is a faster approach. I'm going to show you, okay? I'm going to explain you in detail. Don't worry about it. And as I told, Microsoft is on top of this, okay? It's like every release of SQL Server that you get, the maximum amount of changes, you will see a lot of changes, in fact, on indexes that's been done by, or that's been released by Microsoft. Okay, with the growing expectations, with the growing base of customers for SQL Server, Microsoft has to stay at the top of its game in order for it to stay long in the market. Now, the one worst thing that could be associated with the RDBMS is its performance aspect. If there is one organization who starts complaining about RDBMS on its performance aspect, that's the that's the worst that can happen with the RDBMS. Okay, when we store data in RDBMS, I mean, data is very important in today's context. And if you are able to store the data efficiently, but when you're extracting it, you have performance issues, you have data issues, I mean, that's the worst that can happen to any RDBMS. So Microsoft has to ensure that the performance or the experience of the users are always top notch, right? So it does a lot of changes to the way the indexes are structured and organized at in every release that is done for SQL Server. Now let's talk about the structure of the index, basically how the indexes are structured internally. Okay, so indexes are created on tables or views. We are going to talk about views, okay, at a later point in time. They provide, as I told, faster access to the data using the column on which the index is created. Now let's say we create, so as I said, we create indexes on columns in the tables, right? So indexes are created on tables, but internally they are created on the column. So we specify on which column should the index be created. Now let's say I'm trying to fetch the name or the address and my index is on the ID. So it's not always that you need the index to be on the name or on the department to be able to locate them faster.
Just a quick info, guys. Test your knowledge of SQL by answering this question. Which SQL keyword is used to retrieve a maximum value? A. Most. B. Top. C. Max. D. Upper. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
It could be on the employee ID as well. And the moment the employee ID is located, the rest of the data for that particular employee will be very easy to locate. Okay, so they provide faster access to the data. And when I say data, I'm referring to the whole data row using the column on which the index is created, or as we call it as the indexed column. Indexes internally are B tree structures, or as we call it as binary tree. I don't know how many of you are aware about data structures, but we have something called as a binary tree, which has parent and child structure. So basically, each parent will have two child nodes. Similarly, that the two childs that we have will have two child respectively, and it keeps going on. So that's the reason it is called a binary tree, because each parent has binary or two children. Okay, so these are binary structures which helps us in flattening our tables and hence providing easy access to the data rows. Okay, now I'm again going to explain this in detail at a later point in time, but imagine this example. Okay, let's say you have a set of 10 t-shirts. Okay, 10 t-shirts which are placed one after the other in a queue, and you are looking for one t-shirt. So what do you do? In order for you to search for it, what you do is you search one by one, starting from the first until you reach your t-shirt. But imagine all of them are in a circular pattern and it's been just shown in one line to you. Searching it becomes a little easier, isn't it? So that is a part of how indexes work. Okay, but there are more technicalities to it that I'll be explaining you. So that is what flattening means. So you don't have to like run through the whole queue to search something, but instead you have a more flattened version so that you don't have to recursively loop through all the levels. Okay, without an index, a table is called as a heap. So any table without an index, we call it a heap. And we can create indexes on most data columns in a tabular view, except for a few, which are the blob data types, image data, text data, and varchar max. Okay, I'm going to explain you, once I explain you how indexes work, you will clearly understand why SQL doesn't allow us, or why it is inefficient, or why it should have been inefficient if SQL would have allowed us to create this, would have allowed us to create indexes on these data types. But indexes are very, very effective and efficient when created on unique integer column. Okay, so again, you're going to understand both these points once I explain you in detail about indexes. Now let's say there is a table. Let me give you an example. Let's say there is a table with let's consider this as an employee table itself. It has ID, name, designation, salary, department. So 5 columns, and here I've just displayed the ID column. Okay, let's say there are 20 employees in the whole table. Now let's say I write a query saying select star from employee where employee ID equal to 10. Okay, this is a very normal table that you see. Okay, imagine this has no indexes at all. Forget about indexes. This is a very normal table, and on top of this, this has 20 records, and on top of this I fire this query wherein I want to fetch the employees where employee ID equal to 10. Now what will be the expected output? It'll give me all the employees which has ID 10 in it. Am I right? So if there are 5 employees with ID 10, it should give me all the 5 employees. So what does it do to figure out all the employees which has ID 10? It first checks the first row to see if the ID is equal to 10 here. So 1 is not equal to 10, so it skips this row. Next, it moves to ID 2. It checks if 2 is equal to 10. No, it is not. So it moves on to the third row. It this way it continues this way to make sure, or to it makes sure that it compares all the IDs with 10 and fetches those records which are equal to 10. Like for example, this record would be fetched. Let's say there is another 10 right before 20, that 10 will also be fetched. So whatever number of employees has employee equal to 10, all of them will be fetched and displayed. So in a way, SQL will have to, the optimizer will have to check through or compare all the 20 rows in the table to be able to figure out all the employees which has ID 10, right? So in this case, without an index, the SQL optimizer will have to perform 20 reads. Let's assume that this table has 20 records. It has to perform 20 reads to locate all the IDs, all the employees with ID 10. And this approach is referred to as a table scan. That means the whole table is scanned for it to return the result that I'm looking for. Now let's see what happens when we create an index on it. So let's say I create an index. The index, as I told you, it creates a binary tree structure. So let's say I create an index on the ID column. So what happens is when I create the index on the ID column, it tries to create a binary structure internally. So how does it do it? The parent will be 1 to 20, so there are 20 records, right? So there will be 2 nodes for this. So 1 to 10 can be found on the left hand side. So every node will have an upper range, will have a lower range. So here the lower range is 1, upper range is 10. On the right hand side, I mean on the other node, the upper range is 20, lower range is 11. And then 1 to 20 might have another 2 child nodes. Okay, very similar to how the first level went, and the same thing can be for 11 to 20 as well. And then these are basically the bottommost leaf nodes where you will find the data for those particular rows, right? So let's say here after 1 to 5 it has 2 children, 1 to 2 and 3 to 5. That means you will find all the details for employee ID 1 and 2 in this leaf node. You'll find all data for employee ID 3, 4 and 5 in this leaf node. Now let's try to run the same query using this approach. So what does SQL do now? In case there is an index present, what it will do is it will know that, okay, I'm looking for ID 10. So all the 10s, I'll find it here because the left hand, the first node, child node, has a lower range of 1 and higher range of 10. So all the IDs will be, all the 10s, I can find it in this part of the node. And from here, I traverse here and then ultimately it'll locate here where all the 10s can be found. So with an index, it takes up to what, 1, 2 and 3 reads to locate the whole data or the whole record for ID 10. So maximum, I would say it would take up to 3 reads, and this approach is called as the index seek, wherein the data is directly seeked. Okay, SQL directly seeks the value that it is looking for. Instead of scanning everything, it just directly seeks through the nodes to be able to locate those particular IDs that you're looking for. Okay, and this is what flattening of a table means. Now this has up to 20 levels, so it has to scan all the 20 levels, but here it has to scan maximum of 4 levels. Now this the current when I'm talking about the real SQL Server, I mean, this is just an hypothetical example, okay, of 20 rows that I'm giving. But SQL Server has a more sophisticated, I mean, a hugely sophisticated mechanism to handle this. And I don't think for 20 records, it'll have at least these 4 levels. It'll be way less than, for let's say, thousands of records, you might have only 1 level. It doesn't even go to more than 1 or 2 levels. Okay, so that is how SQL does it internally. But again, this is just an hypothetical example so that you understand this clearly. And this is what the B tree structure looks like. And as you must have noticed, the whole onus of this particular structure being created by SQL Server lies in the fact as to how easy it is to sort your data, how easy it is for SQL Server to arrange your data, right? And integer sorting is very easy and comprehensive. But when it comes to varchar sorting, the limitations that are there. Plus, varchar sorting is lot more memory extensive, lot more time taking than integer sorting. Okay, so greater the varchar value, greater the string value, bad is going to be the index performance. I mean, the impact of the index is going to be negligible, because creating the index and then sorting it like this and arranging it like this is going to be a huge task for SQL Server. So I'm not a big fan of creating indexes on varchar values at all. Okay, SQL forbids creating it on varchar max, which is when you have a column of 8,000 characters long. It only forbids that. So you can create it on columns which has varchar 100, 200, 300, up to 7,999. But I'm not a big fan of creating it on varchar values at all, varchar columns at all. So this is the reason SQL forbids creation of indexes on a few column types. Now the second thing is, I told you why integer is preferred, why integer data type is preferred. But the best thing could be if you can create an index on a unique integer column. Now, why do I focus on unique keyword? Because the uniqueness of your column determines how your index structure is balanced. Now, let's say you have 10 records with ID 10. That means you have duplicate values in there. So now what will happen is, when you have 10 records with ID 10, this particular node will be heavier when compared to this particular node. Am I correct or wrong? Because here, as I said, the upper range is 10, sorry, the lower range is 10, upper range is 10, lower range is 1, upper range is 10. So that means we'll have 1 till 10, all the records in this part on the left hand side of the node. So that means if, let's say, there are 10 records with ID 10, I'll have 19 records on the left hand side and 10 records on the right hand side. So obviously this part of the node will perform slower. The left hand side of the node, the left node will perform slower when compared to the right node, because on the right node there are only 10 records, on the left node there are 19 records. Okay, so this node becomes heavier, ultimately this node becomes heavier, this node becomes heavier. So when the query hits this node, okay, or any of these nodes, it works faster, the data is retrieved faster comparatively when compared to this part of the node, the left hand side of the node. So that's the reason, if you want to keep the index performance consistent, make sure you create your index on a unique integer column. That's the best. Okay, it's not like SQL doesn't allow you to create it on non-unique columns, but it's just that the index might not be efficient enough. Okay, now that you understand the indexes, let's just understand what are the, let's just go read about what are the different types of indexes that are involved. Okay, and then I'll show you the demo on how indexes enhance the performance of queries. So let's talk about the types of indexes that are available. The two important types of indexes that you have are called as clustered indexes and non-clustered indexes. Now the clustered indexes, in the clustered index, the complete data row is actually stored in the leaf node of the index. Now when I say that, what I mean is, You see, this is the leaf node, the bottommost leaf node. So here what you will find is, let's suppose this node. So this node will have the whole of all the data or information for employee ID 8, all the information for employee ID 9, all the information for employee ID 10. That means all the 5 columns that I was talking about: employee ID, name, designation, salary, and address, let's say. So you'll find all the data in here itself, and that is what I have mentioned here. The complete data row is actually stored on the leaf node of the index in case of a clustered index. Okay? The index column is either arranged in ascending or descending order. As I told, it requires sorting, and that is where it is more efficient. The better the sorting is available, the better the sorting, the better is the performance. And this sorting is done physically in the data drive itself or in the table itself. That means, let's say you have inserted records in the order 15497. Okay, when you create an index, let's say on this column, you will now get the data. I mean, whenever you select the data from the table, you will get it in this format: 14579. So that means the data will be sorted like this. So when you create a clustered index, whenever you create a clustered index, the indexed column is physically sorted in the table itself. I would say in the table. Okay, that means when you select the table, you will see that the data will automatically come sorted. You don't have to put the order by, and that is done by the clustered index. Okay, when you create a clustered index, it automatically sorts the data. So whenever you select the data, it will come by default sorted, and that is the reason you can have only one clustered index per table. Remember, because the second column ordering has negligible impact, right? So that's the reason you can have only one clustered index per table. Now you can include multiple columns in the clustered index, right? As I told, you can have only one cluster index, but you can include two columns. Like, let's say the combination of name and ID is unique. You can include two columns in your or name and address is unique. You can create name and address as a clustered index on name and address both together. Okay, there'll be one index, but internally it'll have two columns. Now you can do that, but I don't usually recommend it. Again, imagine this structure being built for two columns. Obviously it will not be efficient when compared to a single column, right? So I usually say create it on one column which you think is a primary key, and that's the reason I always say that whenever you create a table, create a primary key in it, so that you can create a clustered index. In case that table grows to a lot many records, you have the liberty to create the clustered index on the primary key, because the primary key is both unique and not null. So it's easier that way. Table with a clustered index is usually referred to as a clustered table. That means any table with a clustered index is usually referred to as a clustered table. Now coming to the non-clustered index, there's a slight change. There are a few things that are different from the clustered index. Unlike the clustered index, here the leaf nodes does not store the actual data row. Now here what happens is, so as I was saying, in case of a clustered index, the whole row is stored in this leaf node, right, for 8, 9, and 10. But in a non-clustered index, what we'll have is, we'll have the indexed column, which is 8, and then there will be an address pointer that will point to the actual row of the table, okay, where exactly in memory that row is present. Similarly, 9 will also have a pointer that points to the memory location of that row. The same applies for 10 as well. This is how the non-cluster index works. So SQL has to perform one extra operation after locating the row, wherein it has to take the pointer, go to that particular address, and fetch the whole row. And that is what makes non-clustered indexes a little slower than clustered indexes, because in clustered index, the optimizer can locate the row in the leaf node itself, so it doesn't have to go anywhere else. But in a non-clustered index, it has to take this pointer, go to the memory, and then fetch the record from there. So locating the row is still fast in case of a non-clustered index, but taking the pointer, finding it in memory, and locating the row takes that extra little bit of time, which makes non-clustered indexes a little slower than the clustered indexes. As I said, instead it stores a pointer or memory address to the row in the memory so that SQL optimizer can extract that whole row. Now the non-clustered index column, the data is sorted but on the fly. So you will not find the data sorted as I showed you in the non-cluster index. You will not, that is not how the data would be sorted in the disk. It would be sorted but on the fly. Okay, so the structure will be created on the fly only for that particular fragment. It won't do it for the whole thing. It won't sort it on the table itself. And that is the reason, as it does not physically sort the data, you can have more than one non-clustered index on a table. To be specific, till SQL Server 2005 used to Microsoft used to provide 249 non-clustered indexes, but 2008 onwards you can create up to 999 non-clustered indexes. Not that I would recommend you to create that many, but yes, you have the liberty to create up to 999 non-clustered indexes per table. Okay, this is per table I'm talking about. So let's get into an example. Let me explain you with an example as to how this actually how the indexes actually speed up the performance or make the performance better for the queries. Okay, so what I'm going to do is I'm going to use the same table which is on a different database. I'm going to extract it or copy it into two tables in our database, one with the name index test, one with the name index test underscore CI. That means the table names will be different, but the content will be exactly the same because I'm copying from the same table from a different database. So let me execute this. So I get 10,000 records each. Let me comment this back again. And if I show you this table, it has only two columns, ID and name. Okay, ID is 1, 2, 3, 4, 5. It's an auto increment value, and then the name is nothing but Dinesh appended with the ID itself. Okay, and we have this for 10,000 records. Let me show you. See, it is there till 10,000 records. Okay, and the same is for the other table as well. As I told, both of these have the exact same structure and the exact same data. As you can see, this is the one. Now the reason why I gave this a different name is because I'm going to create a clustered index on this table. This is underscore CI. Now none of these have indexes in it because these are normal tables, right? I just created them. So how do I create a clustered index? So I say create clustered index. Okay, and then you give a name to your index. So here I say ix underscore, and then to make it, as I always say, name your objects so that you can look at it and know or tell a lot about it. Like here I say ix underscore, which from which I can know that okay, this is an index. Then I have the table name here, and then on which column am I going to create the index. So I have ix underscore table name underscore id, and then I say on, that means create the clustered index on index test underscore ci. This is the table on which I'm going to create the index, and the column name is id. So I'm going to create the clustered index on the id column in index test underscore ca. And let's create this. So it says commands completed successfully. Now how do you know if there is an index or not? You can double click on the name, use alt F1 again, and if you scroll to the bottom, you will see that there is a clustered index. You see there is an index name, clustered index on the id column. But for the other table, now we have it for the index test underscore ca, but for the index test, you will see that there are no indexes. See, there are no indexes. So this table has no indexes. This table has an index, which is a clustered index on the id column. Now let me open another query window here and get this parallel to this. And what I do is I run two exact same queries on two different parts on the two different windows. Okay, so in one of the window I say select star from index test where id equal to 7748. On another part of the window I say select star from index test underscore ci. Okay, so this is the table with the index, this is the table without the index, right? And I'm trying to run the same query on the same table with the same amount of data, but the only difference is one of them has an index, one of them doesn't have an index. Okay, now before I execute these queries, let me enable the execution plan. Now, what is an execution plan? I'm going to explain this to you in detail when we talk about stored procedures, but just to give you a brief about it, execution plan. So every time we execute a query in SQL Server, the optimizer generates an execution plan before executing the query, or before in fact returning the data to us. Now, what does the execution plan do? The execution plan would, so the optimizer, based on what tables are being joined, what columns are being used to join, what filter conditions are used, so using all of those, it generates a plan as to how that query should be executed efficiently, or what route can SQL Server use to execute that query, okay, and give us the result. So that is known as an execution plan. I'm going to explain that in detail. Okay, now there is a way in which we can see what is the execution plan underlying the query that we are executing. So that can be seen here. You see here there is a include actual execution plan. You can include the execution plan. Click on here, and whenever I run this query now, it'll show me the results along with the execution plan as well. And let me do it on this query window as well, because this query window does not have the option turned on. You see, it's not highlighted. So let me do it for here as well. Now let's run both these queries. Uh, so this one is done, and let's execute this one as well. So I have both these query executed on two sides of my window. Now, if you see here, the output that we get is exactly the same, isn't it? 7748, Dinesh 7748 on both sides of the window. It's a very simple select command. Okay. Now, if you observe, there is one more tab. So earlier we used to see only results and messages. Now you see one more tab here, which is called the execution plan. Now, this is what I was talking about a little while earlier. Okay, now what is the first thing that you see as a difference? The first thing that you clearly see is, if you hover on top of this, you see on the top, you see the operation is a table scan. That means this query would have scanned the whole table to locate the records with IDs 7748. And on the other side of the window, you can see that the operation is trusted index seek. That means it has fetched it from the binary tree structure. It has seeked the value instead of scanning the whole table to locate it. So without the index, I have created two blocks here. One is without index, one is with the index. So without the index, the operation is table scan, whereas with the index, the operation is an index seek. Let me just reduce the font a bit, maybe. So this is the first visible difference that you can see. Now let's see some more statistics here. Okay, let's just hover on top of this, and if you see the 1, 2, 3, 4, 5, sixth number metric from the top, look at the sixth metric from the top. It says number of rows read. You see, the number of rows read is 10,000 here in the table scan, because it scanned through the whole table. So it would have basically gone through or checked it would have read all the 10,000 rows to retrieve only this record. Okay, so the number of rows read are 10,000. Now let's check on the table with the index. Here, if you see the same metric, the sixth metric from the top, you will see that the number of rows that are read is only one, right? So it did not even bother to check the other records, because by using the binary tree, it was able to pinpoint or seek directly to that value or that row instead of scanning the whole table. So you see clearly there's a difference here, and it is on the number of rows read. On the number of rows read for without an index, in a table scan, it looks through all the records, but here it only fetches one. Now this is only on 10,000 records. Imagine a table with millions of records in it. Is going to be huge, right? It's going to be saving you a huge amount of time and resources. Now obviously, when we are reading more number of rows, when we are performing an operation, these are basically on SQL. Okay, but do you know that whenever we execute a query in SQL Server, it also takes a part of your system resources? That means, let's say MySQL Server is installed, the SQL Server that I'm working on is installed on my laptop. So every time I execute a query, it consumes a small bit of my computer resources as well, of my laptop resources as well, like the input output. Okay, if I again over on top of this, you will see the estimated input output cost, which is
Just a quick info, guys. Intellipaat provides SQL online training in partnership with Microsoft and mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
the 7th, 8th, ninth metric. You see the ninth and the 11th metric, estimated input output cost and estimated CPU cost. It's at 0.027, the IO cost, and the CPU cost is at 0.0110. So the input output and CPU in case of in a table without an index with 10,000 rows is this. Okay, which is a very small number, to be honest. But let me show you the numbers when it is running on an indexed table. When the query is run on an index table, you can see that the estimated IO cost is at 0.003125 and the estimated CPU cost is at 0.000158. Now here I have put all the numbers for you. You see this on the top is are the numbers for the non-indexed table, and this is for the indexed table. Now these are system resources I'm talking about. Okay, this one it took 0.027, this is 0.0031, so it's almost 50, I would say what, 1/10 of what it took here.
Just a quick info, guys. Test your knowledge of SQL by answering this question. Which of the following SQL clause is used to delete tuples from a database table? A. Delete. B. Remove. C. Drop. D. Clear. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Again on the CPU, if you see it is 0.011, it is here it is 0.00015. So this is also 100th time of the resources of the CPU that the earlier query took. Imagine this is the improvement that I can get on a table with only 10,000 records and with a very simple select, with complicated selects, with complicated updates, with complicated deletes, and on a much higher or in a much bigger table, the improvement is going to be huge. Okay, and this is how you read it. Basically, whenever I look for optimization, I see my query, the operations I see. So if I see that there is a table scan somewhere, I know that there is a problem. I know that I have to fix it, because table scans are never good in the SQL Server context. I mean, there are a few scenarios, but that is too complicated for you to understand now, so I'm going to skip that part. But yes, most of the times table scan are bad compared to index seek. Okay, so let me close this one, say no. Again, as I say, indexes I always say are a necessary evil. Okay, that's the reason I say, although you have the privilege to create a lot of indexes, a lot of non-clustered indexes, don't blindly go ahead and create them. Okay, indexes are a necessary evil. The fact that the reason behind it is the whole performance of your table now completely depends on this structure. And when you add more rows, when you remove rows, when you update rows, this structure goes for a toss. Let's say you add 10 more records on this table. Those 10 records is not a part of the index unless you refresh the index, right? So until you refresh your index for the new records, it will still run slow. So try to limit your indexes to as less number of columns as possible. Do it only on the columns that you really need, because DML operations are going to get slower with the more number of indexes. Because as I told, sometimes, I mean, when you, let's say, consider inserting, updating, or deleting small number of records, SQL Optimizer tries to rearrange your index to fit in those small number of records. For huge number of records, I mean, it cannot do it. But for small number of records, it tries to update your index structure. It tries to adjust your index structure here and there. So that's the reason more the number of indexes, more time SQL takes to perform your updates and deletes, because internally, although your operation is finished, it is trying to rearrange your index, do minor adjustments on your index structure. Okay, so these 2 points are something that you need to keep in mind when you are creating indexes. Okay, create indexes on columns which are very rarely updated. So here, that's the reason I say, for heavily updated table, keep the index columns to as few as possible. Okay, when there are not much updation happening, you can create as many indexes as required, because there is no DML operations happening, there is no insert, update, delete happening, so you can happily create as many indexes as you want. But is it practically possible? There cannot be a scenario wherein you don't insert, update, delete into a table and the data keeps growing. I mean, it's practically not possible, right? So there will be DML operations done on the table. So make sure you limit and create only the required columns as indexes. And as I said, for clustered index, create it on the unique integer column, preferably the primary key, because the primary key has, as you know, only unique values and not null values. So the primary key is an ideal candidate for the clustered index. Okay, and just for your information, whenever you create a primary key on a column in a table, by default SQL Server creates a unique clustered index on that column. As I've been saying, SQL also knows that the ideal column for a clustered index is the primary key. So if you create a primary key, automatically SQL Server creates a unique clustered index on that column. And when you create a unique column, I mean a unique constraint on a column, SQL by default creates a unique it creates a non-clustered index on that column. Okay, so these are the default indexes that are created, but you can obviously choose to override them if you want. Right, so let's start by talking about stored procedures. What are stored procedures and how are these important in the SQL Server context? Stored procedures, let's start with an example maybe. Okay, let's say you are asked to design queries to calculate the salaries of the employees. Okay, that means let's say you are given an assignment or a task saying that, hey, we want you to build queries that would calculate the salaries of our employees in the database. So you need to follow certain number of steps or perform multiple operations to successfully calculate the salary, right? I have tried to list out a few of the steps and let me guide you through each of them. First, you might need the list of active employees from the employee table. This is very, very important. Now, why do I say this? It is important because let's say there are 10,000 employees in your database, and out of that, let's say there are only 1,000 active employees. So there is no point or there is no need for you to calculate the salaries for the rest of the 9,000 employees. Is it? It's not needed, right? So you first need to take the active list of employees from the employee table to start off your calculation. I mean, you can consider each of these as a or put them into a temp table maybe. Okay, you can do it any way that you wish to do it. Next, you would fetch the leaves from the leaves table. Let's say there is a employee leave table, and in there you might want to fetch the leaves of each of the employees, the active employees, obviously. Now, once you have the leave balance summary for each of the employees, you might have to calculate the LOPs or the loss of pay. Now, loss of pay is something wherein, let's say you are eligible for 5 leaves in a month. Okay, let's say you take 7 leaves in that particular month. So you are qualified to, or the company can deduct, the organization can deduct 2 days worth of leaves from your salary. Okay, 2 days worth of salary from your whole monthly salary, because you have taken 2 extra leaves, which is something that you are not eligible for, which is beyond your allotted leaves. Okay, so those are called as loss of pays, okay, or LOPs. Now there can be the other way around also, right? The other way around is also possible, wherein there can be 5 leaves allotted to each employee, and some of them might have taken less than 5 leaves. Let's say there is an employee who has taken only 3 leaves. So you might want to credit the rest of the 2 days worth of leaves in the form of 2 days salary to the employee. So either you do a loss of pay or you can encash their leaves into their salary. So this is something that you need to add to the salary of that particular employee. Next, you would want to get the salary components, the different components of salary from the salary table. Like there can be multiple components like the house rent allowance, there can be the dearness allowance, there can be the basic amount. So all these multiple different components can be used or can be extracted from the salary table so that we can calculate them together. We can sum them together so that we can derive the salary. So first we take the leaves so that we can either choose to either add the extra leaves or deduct add the remaining leaves or deduct the extra leaves that has been taken. Then we take the whole salary components, and also we can add the bonuses or the incentives to the calculated amount. Let's say an employee is eligible for some bonus or for some incentive, that can also be added to the final amount. And end of it, the funny part is you'll also have to deduct the taxes that has been that particular employee is eligible for. So now that you have everything calculated till here, the final step would be to calculate the tax on top of the salary that they are going to be paid. So this is also a deductible amount. So you see, this is a very constructive and a thought through approach to calculate the salary. Now you cannot bring this active list of employees step to the end of the calculation, can you? Because you would then end up calculating the salaries for all the employees, which is not a good idea. So it should be performed in a sequential approach or in a constructive approach so that you save on system resources, plus you also make or calculate the data efficiently. Okay, now this is just an example. Okay, this is just an example that I'm trying to give you. Now when you have situations like these wherein there are multiple steps involved in sequence, okay, you might end up having, let's say, 50 or 30 SQL queries to perform all these steps. Now let's say that query, or let's say there are multiple departments who wants to reuse it. Okay, let's say there is another department which wants to reuse this calculation. So what do? Do you give them the query for them to execute on their department? Let's say there is a third department tomorrow who wants to use this same salary calculation procedure. So let's say end of the day or end of the month, you have 10 departments where the salary calculation should be implemented. So do you pass on this query to all the 10 departments? I agree. I mean, you can still do that. Okay, you can pass the 30 SQL queries that you have written to perform all these operations and they could plug it on their department. But is it efficient enough? Is it maintainable enough? The answer is a strict no. Tomorrow, let's assume that the company says, okay, when we want to change the policy of the encashment of the leaves. Okay, earlier we were paying 1 day salary per leave, but now we want to only pay like half a day salary of the for each leave. Let's say, I mean, any such change. So in that case, what do you have to do? You have no choice left but to change in all the 10 departments the calculation logic. Am I right? Because you have used the same query across all the departments. So it's very bad on the maintainability aspect. This is where stored procedures comes into picture. So you put all your queries, all the 30 or 40 queries that you have inside a stored procedure, and wherever you need them, whenever you need them, just call that procedure and it would do or perform the internal operations on that particular object. Okay, and also when it comes to the maintainability aspect, let's say tomorrow there is a logic that has been changed, there's a new bonus or a new incentive that has been added to the new bonus or incentive that has been added to the salary component. You just have to change it in the procedure where you're calculating the salary. Automatically everywhere else that the table is being used, or the procedure is being used, will now calculate the salary using the new logic. So what are stored procedures? Stored procedures are blocks or batches of SQL statements. Batches in the sense there can be multiple queries together that are executed together in a specific sequence to serve a definite business purpose. And it can be reused as and when required, and it is accessible to everyone who has access to the database, provided they have execute permission on the stored procedures. I mean, as I've told you earlier, the security privileges is very beautifully defined in SQL Server. So you can control who can execute your stored procedures and who cannot. Okay, you can also restrict people or users. You can give them access to view the data in the tables, but can restrict their access to execute stored procedures. Okay, but yes, I mean, it can be reused at multiple different places and is accessible to everyone who has permissions to view and execute them. Now, what can a stored procedure do? This is where I'm going to give you a few examples, a few differences between the stored procedures and the function. Now, what can a stored procedure do? A stored procedure, unlike a function, can perform all kinds of operations. It can be creating a table, dropping a table, it can be also updating data, deleting data, inserting data, taking backup of the database, restoring the database, any kind of operation that can be written in SQL, okay, can be put in a stored procedure. Whereas a function, it can only perform selects. It cannot even perform DML operations as well. Now, where are the stored procedures created? The stored procedure is created and becomes a part of the database. So wherever we create the procedure, it is created on that particular database and it is stored in the schema where it is created. Obviously, the default schema like other database objects is DBO unless we specify another schema where it should be created. So let's say it's created, if you want to create it on the food schema, you can create it there. If you want to create it on the clothing schema, you can create it there. Any type of schema, but the default is DBO, obviously. Now, why do we have to prefer? The big question is, why do we go with stored procedures instead of the normal queries? Is it just because of the reusability and the maintainability factor? No, there is in fact more to stored procedures than what it looks like. The first main reason as to why we use stored procedures is because of the encapsulation property. Now, what is encapsulation? Okay, encapsulation is a OOPS concept. It's an object-oriented programming concept. Okay, let me give you an example so that you're clear about it. Let's say you go to let's say you're sick. Okay, I mean, you have food poisoning or something. Okay, we'll not go with flu or fever or anything given the circumstances, but yes, let's go with stomach upset. And you go to a doctor and you tell what your problems are, and he gives you a couple of tablets, maybe a couple of capsules to take. Are you really worried about the chemical formula or the combination or the content of that particular capsule, or are you really bothered about how to consume it, when to consume it? I would obviously worry about when do I eat it and how do I eat it, rather than asking what are the contents of the capsule or does this capsule what is this capsule made of. This is a classic example of encapsulation, wherein we are just bothered about how to consume something, how to utilize something, instead of understanding the internal complexities that are involved in it. And that is what a stored procedure exactly does. We write all of our business logic inside the stored procedure, and when we share it with someone, we just share the name. So they just execute the name, and automatically the logic that is placed inside of it is calculated or is performed. Okay, uh, that's what encapsulation means. It binds complicated business logic into a single unit without exposing the internal content. So no one even knows what is there inside the stored procedure. They just execute it, and let's say the calculation of salary itself. So I just share the stored procedure name, and every department just executes it so that it calculates the salary for their specific department. Coming to the reusability aspect, I've already shared this with you. The SPs are reusable and can be called multiple number of times based on our need by users having execute permissions on them. As I mentioned earlier, you need to have execute permission on the database to be able, sorry, on the stored procedure to be able to execute them. Maintainability aspect is also something that I've already explained to you about. wherein any change that's been made on the data, on the calculation, or on the way the data has been transformed, you can always change it only in the stored procedure once, and automatically when the procedure is called the next time from any of the departments, it would automatically use the new calculation to calculate the salary. As simple as that. Okay, now coming to the most important factor that clearly differentiates or clearly puts stored procedures way ahead of SQL queries. This is called as the execution plan caching. Now, to understand this, let's understand what the optimizer actually does when we try to write and execute a query. So let's say you write a query and execute it. There are three main functions, or there are three main steps that the optimizer follows. First, it parses the query. So what does it parse? It basically checks the query for any syntax errors. If there are any syntax errors, obviously it'll throw you a error message that you are missing something here or here. That's the first step. Second, it compiles that query to generate the execution plan. Okay, that means if everything looks okay, if the syntax is okay, if you have written the query properly, it compiles that query to generate the execution plan. And third step, it uses the execution plan that is generated to fetch the data, perform the actual operation. Okay, now what is an execution plan? Let me give you an example so that you understand this clearly. Let's say that you have let's say that you have got a new job in your city. Okay, you have got a new job, and the distance, there are three main routes. There are three main, yeah, let's say it routes. Okay, there are three routes that you can take to reach your office on a day-to-day basis. So for commute, for daily commute. Now, what do you do in the first week? Let's say you have never gone to that part of the city earlier, so you don't know clearly about the routes that are available. So let's say you found out from Google Maps that you have three routes that you can take. The first route, when you take it, you see that you can reach office faster. It is 10 miles from your home, where you're staying currently, where you're put up, to your office. It is 10 miles, but you reach office a lot faster. Okay, because there is very less traffic in this route. Or let's say it is 12 miles. Okay, let's say the distance between your place of stay and your office is 12 miles, and you reach office faster because there is very less traffic. So what do you compromise on in this route? You burn more fuel because of the extra distance, but what do you save on is your time. Okay, so one pro and one con with the first route. Let's talk about the second route. Let's say the second route, when you take the second route, the distance between your place of stay and your office is 8 miles, but there's a lot of traffic in that route. So you might end up saving a bit on your fuel on the to and fro commute, but you are compromising on the time that you are spending to reach office. Okay, so again, one pro and one con in the second route as well. Let's talk about the third route. Okay, let's say that the distance from here, when you use the third route, the distance from your office, from your place of stay to office, is still 8 miles. There is hardly any traffic, win-win situation, but the condition of the road is not that great. You have a lot of potholes, there are construction work going on, they have let's say there's some patchwork that is going on here and there. And what happens is, end of the day, you save money on fuel, good enough. You save on time because it is closer, so it takes hardly much time, but you're compromising on the condition of your vehicle, right? You know that if you go in that route for, let's say, a month or so, you might get a hefty amount of service charge on your vehicle. Okay, so here also you have a con associated. Now, based on your priority, you choose which route do you want to take. If you are comfortable to shell out more money but don't care about the time, then you take obviously the second route because you want to save money on the fuel, right? But let's say you want to you don't care about the money, but you want to save on time, you take obviously the first route. Now let's say you don't care about your car. Okay, you want to sell it anyways after a month or two, so you take the third route. It's all depending on your priority that you choose which route you have to take. Now how do you decide? only when you take each of the routes for, let's say, 2 days in a week. So in 1 or 2 weeks, you get used to the routes, and then you decide, you take an educated decision as to which route do you take for the commute. This is exactly what execution plan means in SQL Server. To execute a particular query, there can be multiple routes that SQL Server can take. Okay, so this is where the compiling factor comes in. So when the optimizer tries to compile the query, it identifies an ideal route that the query is going to take to be able to fetch the data or perform whatever operation has been asked to perform. Okay, now this is with normal queries. Okay, now what happens with stored procedures? With stored procedures, the advantage that we have is the first time when we create the stored procedure, it is parsed once and for all. Okay, so it is parsed, and we know that there are no syntax errors, so it does not parse or check for the syntax every time it is run. So we are saving on parsing the query. Second step is the compiling, right, where the execution plan is generated. Now what happens in case of a stored procedure is that after 3 or 4 runs, SQL optimizer tries to identify the best plan out of the all and caches it in the memory, in the SQL Server memory. Okay, so for the next times, let's say from the 4th or the 5th time, it doesn't have to compile it anymore, which doesn't happen in case of queries. Every time you execute a query, let's say you execute the same query over and over again, it will every time get parsed, it will every time get compiled to generate the execution plan. But in case of stored procedures, parsing only happens the time when we create the procedure, and the compiling where the execution plan is generated is cached in the first few runs, and this saves a lot of time on the query processing. Okay, so the same query when executed normally versus when executed inside a stored procedure makes a lot of difference on the time and the performance. Okay, so that is what execution plan caching really means. The SP when created is parsed and compiled, so it does not compile every time it is run. It also caches the best execution plan in the first few initial runs, which makes it stand out from normal queries. Now, what is an execution plan? An execution plan is the path used by SQL optimizer to execute your query and return the result. Now, SQL Server creates the execution plan during the query execution, and obviously the SQL query takes that extra bit of time to compile and create the execution plan, which is avoided or which is not necessary in case of a stored procedure after the few initial runs. Okay, and this is what makes stored procedures stand out from normal queries. Okay, now let me show you how to create a stored procedure. Okay, it's very simple. I say create or alter procedure, and then give it a name, like so that you understand or you look at it and know that it's a stored procedure. So I give it a name saying CSP underscore. So CSP stands for custom stored procedure. Okay, so custom stored procedure is basically when we create one for our own need. CSP underscore, and then obviously a name that justifies the purpose of the procedure. So I say CSP underscore get data as begin, and then here let's say I'm creating a procedure that would just select me the data from the employee table. Okay, as I told, you can do anything that you want, but I'm just keeping it very simple so that you understand it. Okay, here I'm trying to say select me the data from the employee table. Very simple one, right? So let's execute this. It says commands completed successfully. Now how do you know if the stored procedure is created? Obviously you can do alt F1 on this, alt F1, and you will see that this is the name, this is the type is stored procedure, and it's created on 4th of October at 9:52 in the evening. Now that the procedure is created, let's see how to execute it. Again, executing it is also very easy. You say exec and the procedure name, and when I run this, see, it gives me the whole data from the employee table. I'm not executing the query, right? I'm just executing the stored procedure, but internally the stored procedure has that query. So it runs and selects me the data. Okay, now let's say you don't want to see the salary column maybe. Okay, so you can alter the same procedure CSP underscore get data as begin, and instead of star you put the ID, first name, last name and address from the employee table. And if I run this, it says commands completed successfully. And now when I execute the same procedure, it would give me everything except for the salary column. You see, I get the ID, first name, last name and address. So except for the salary, I get everything else. Now, this is more of a static stored procedure, which means every time you run it, it will give the exact same output, okay, or the result set. Now, can we make it dynamic for the user to input a value and based on that, it returns the output? Yes, we can do that by adding parameters. You remember how we used to add parameters inside functions? We can do the same in procedures as well. So here I say create or alter procedure, CSP underscore get data. I'm using the same procedure, okay? And in here, I put the parameter inside the bracket. So I say employee ID parameter of type integer as begin. And here, as you can see, I'm selecting only those columns from employee where employee ID equal to employee ID. Okay, so this would so the user will be asked to input a value here, and that value will be used to filter the employee ID from the employee table. So whatever ID we give here, that ID will be filtered and the details will be returned for that particular employee. So let me create this procedure, and now if I just say execute procedure name, is going to throw me an error saying that procedure or function expects parameter employee ID which was not supplied. Okay, so here I need to pass the value of the parameter which is employee ID. Now if I run this, you see it gives me only the details for John.
Just a quick info, guys. Test your knowledge of SQL by answering this question. Which SQL keyword is used to retrieve a maximum value? A. Most. B. Top. C. Max. D. Upper. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
I mean the ID 7. So similarly, if I give let's say 5 here, it would give me the details for 5. Now let's say you are said, okay, if I don't pass any value for employee ID, give me all the employees. If I pass any value, send me the specific employee details. That means if I pass a 5, get me the details for 5. If I don't pass any value, just give me all the data. Okay, so in that case what you can do is you can you can pass a default value, okay, like this. So when you give a default value, let's say I give a default value of 4. Okay, so what will happen is let's alter this, and now if I just execute this much, okay, just execute the procedure, it would give me the default employee details which is 4. Remember I gave 4 here as the default employee ID. Okay, but if I pass the value from here, let's say I pass 5, it will now give me the 5 details. So if I pass a value from here, it will take this, else if I only execute this, it will use the default value. Now let's say when I execute this, I should not get 4 but should get all the employees, and when I pass 5, I should get only the details for 5. How do we achieve that? For that, what I do is I set the default value to 0. Okay, and here I put or employee ID variable is 0. That means fetch me all the employees where employee ID equal to whatever value comes in, which is it could be 1 2 3 4 5 6 7, or fetch me the record if at the rate employee ID the variable is 0. And you know that the or condition would return the records if at least one of these condition is true. Okay, so let's say employee ID I pass it as 5. That means it will only evaluate this condition to true for ID 5, so it will return only 5. Now let's say I pass employee ID as 0, then this condition will be evaluated to true for all the records, isn't it? So let me alter this, and if I run this with 5, see I get this particular employee. If I run with 6, I get with 6. If I run with 0, I get everything. Or I can also choose to not run it with the parameter and I should get everything. This is all being handled by this condition. If I pass the variable value to 0, that means it'll return me everything. Okay, so you can make your parameter optional by adding a default value here. So the default value to the parameter makes it optional. I know the OR condition is a little complicated for you guys for now, but I mean, when you practice it more, you will get to know it. Okay, you will understand this better. Okay. Next, let's see how to add multiple parameters. So till now we have been only playing around with what one parameter only. So how do we add multiple parameters to our procedure? So here I say create or alter procedure, the same one. Here I pass the employee ID integer. I give an optional value which is 4, and I also add the address here. This is a mandatory parameter because this does not have a default value. Okay, if it had a default value, this also would have been an optional parameter, but this does not have a default value, so it's a mandatory parameter. That means the user has to provide a value for the address. And then here what I do is I say as begin. Here if you see, I'm selecting employee ID. Instead of selecting first and last name, I'm selecting the full name by using the function. This is one other difference between the procedure and the function. In a procedure, you can call a function, but inside a function you cannot call a stored procedure. Okay, and then obviously I select the address from employee. Let me just give it an alias name because it does not have an alias name. From employee table where employee ID is equal to ID and address equal to address. Okay, so I'm using both the parameters to filter my data now. If I execute, it says commands completed successfully. Now I can execute only this and you not see any data because, let me show you, because when I don't pass any value to the employee ID, it uses the default value which is 4, and for 4 the address is Australia. So if I pass Australia here, then it will return me the data because I'm not passing any value to the employee ID, so it uses the default value which is 4. And there is an AND condition here. That means it'll only return me the employee which has ID is 4 and address as Australia. Okay, and if I say, if I pass this as India and I pass employee ID as 1, this will give me only that particular record. So this is how you can control your optional parameters and mandatory parameters. So we can also create a procedure with output parameters. Till now what we have seen is we pass input parameters. That means we pass inputs, we pass parameter values as input to the procedure, and then we can also create stored procedures with output parameters. I'm not a big fan of using the output parameters because this is mostly what a function is supposed to do. Okay, but yes, I just wanted to share with you that this feature is also available. Okay, so here I say create or alter procedure, the same procedure name, and I pass two parameters as input. One is the employee count, which is of type integer, and the output keyword. So that means this is a output parameter. And then I have the employee address, which is varchar 100. So basically what I'm going to do as part of this procedure is I'm going to count the employees that reside in the input address and return this count as an output. So this will basically be returned to the users, okay, the end users. And what I do is I say as begin, and here I say select employee count is the output, okay, the output variable equal to count 1 from employee where address equal to employee address. So the count for all the employees residing in this address will be stored in the employee count variable. Okay, and let me create this. Now executing this is slightly different. What we do here is we need to catch the output value, right? So first let's create a variable of the same data type, which is integer. Now this is where I'm going to store my output value, the value that I get as an output. So here I say execute the procedure name, and then I put the variable name here, the new variable that I've created, saying output. That means whatever value this output parameter returns from here will be stored in this variable. So the output keyword helps us map this variable to this. So that means whatever value comes as an output will be stored in this variable, and obviously the employee address I'm passing the parameter here. So I'm executing it, right? So I'm saying, okay, store the output in this and take this as input. And ultimately what I do here is I select the value as an alias name. So let me run this and show you what the output looks like. So it gives me 2. That means there are 2 number of employees who reside in the US. Similarly, if I change it to, let's say, India, and let's see this now, it gives me 4. That means there are 4 employees from India. So this is how you can use input parameters as you can use output parameters with procedures. But again, as I said, this can be easily used with a function. Okay, so you don't need procedures for that. I'm to be honest, I have never used a parameter, output parameter with a procedure. But yes, we use input parameters a lot. I've spoken to you about the SP help text when we were discussing about functions, right? The same thing is applicable here as well. So if you want to see the content of a procedure, you can always use SP help text, and then you can write the procedure name, and it would give you the whole structure of the procedure, the whole definition of the procedure. And obviously if you want to hide it, if you don't want people to see it, what you can do is you can say with encryption, and when I execute this, it's altered, and now when I run the SP help text, it would not return me anything. It says the text is encrypted, right? Obviously you can call your procedures conditionally. That means if the condition is true, then you can execute a procedure. See, 1 is not equal to 2, right? So it won't return us anything, right? It just says commands completed successfully because there's nothing to execute because the condition is false. But let's say I make it 1, which means it's true. Now the procedure will get executed and it returns me the output. Okay, so this is how you can execute your procedures conditionally, right? Views. Okay, all right. So what are views, and how are these important in the context of SQL Server? So let's say with the growing amount of data, okay, when the data grows exponentially in our database, obviously we store a lot of, in fact all of the relevant data, which can be game changers at time. The importance of data can be realized when you hear the terms like when they say the data is the new oil. That means data is so important in the context of the business, the domain, and the application. There's nothing matching that level. I mean, if your UI goes for a toss, you can always fix it, but your data is something that is always dear and close to any company. Now when you have data which is like quite important, you can do a lot of things with it. You can do some analysis, you can do some probably you can use it to predict something. You can do, I don't know, maybe derive metrics out of it, like how did the past go, and how is the current year going. So you can derive comparisons out of it. You can derive what do you call standard numbers or standard metrics for your company. I mean, there are a lot of things that you can do on data, and I guess with what we are doing these days, I mean, a lot of them revolve around data. I mean, you talk about machine learning, artificial intelligence, a lot of things can be done with data. So coming back, I mean, when I talk about data, there are a lot of important data that we store that might also be relevant for a few other applications or a few other projects in our organization. Okay, but end of the day, they might be internal consumers, they might be external consumers. Okay, so you can also I mean, if companies are tied up, they could also share data between themselves, right? If they are a parent or a child company or a sister company or any related companies which have an agreement. Okay, I mean, there cannot be direct sharing of the data without any agreement or such. That would be clearly a theft. But again, if there is an agreement, is a pre-decided agreement, then yes, data can be shared between between companies, between organizations, between projects, and between teams as well. Now, whenever you get such requests, okay, I always say this to people that I train. Whenever you are given a database, make sure you need to work as if you own it, because any change that you make on it, any additional objects that you create in it, you are responsible to manage it. So the more objects you have, the more effort it is going to take from your end to maintain and manage it. So that's the reason I say, whenever you are given a database or whenever you own a database, make sure you act like a miser. Okay, that is, I mean, whatever I am outside of office, but inside, when I am on my database, I need to, talking about myself, I'm a big time miser.
Just a quick info, guys. Intellipaat provides SQL online training in partnership with Microsoft and mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
Anyone comes back to me saying, hey Dinesh, we wanted to create a table, we wanted to add 2 columns, we wanted to modify this on the database, we wanted to modify that on the database. Ask them questions until that is the only option left. Okay, ask them if there is an alternate, ask them what if we don't do it, what happens if we don't do it. If you do not have any other option then doing that, find out an efficient way to do it, because if you just keep making changes as per the suggestion that you get from your team members, you will end up with a very bad database. It could be on the design, it could be on the storage, it could be on the maintainability aspect. Okay, so always make sure that whenever you do something, okay, make sure that you know what you're doing. Okay, take your own time, analyze it, and then implement it. But before implementing, see if there is any other better way that you can do it. Only if it is the last option, update your database. It could be your table, it could be your column, it could be adding new tables or anything of that sort. Okay, I mean, this is a fact. Okay, trust me, I mean, if you go that line, if you walk that lane, you will understand how hard it is. If you have like 10 developers working on the UI, and let's say you are the one taking care of the database, imagine 10 people telling you how to design a database, or 10 people asking you to modify the database. It's going to be really bad. Okay, so that is one aspect to it. The same thing applies when someone asks you access to the data. Okay, you will, when you have, and this happens mostly when you are in high visible project, okay, or project which has the core data of the organization. When you have the core data of the organization, okay, you are very frequently contacted by teams and projects. It could be inside your company, outside your company, that comes back saying they might need access to your data. Could be because of any reason, could be to run some analysis, could be to take something and use it in their system, could be to integrate into could be they could be building an integration tool between the two applications. You never know. So there could be multiple reasons why they might be asking you for the access to your data. Now again, the being a miser still continues. Okay, when they ask you for access to the data, make sure you get all the details or understand why they would need access to your database. Why would they need access to your data? Is it clearly justified? Now again, only grant them access when you are completely satisfied with their response, or if you have your management's approval. Okay, I would say both of them are necessary. That is what I do, because tomorrow you never know. I mean, you could feel that the answer that they've given is justified, but the management might not agree to it. Okay, so it's always better to make sure that you understand their point of view as to why they need the data, and also at the same time have proper approvals before you actually expose your data to the outside users. Okay, now they need data. I mean, okay, everything is decided, they need data from your database, but then you know that there are some very critical information, let's say user information, that at no cost you can share with them. It can be phone numbers, it could be social security numbers, it could be Aadhaar numbers in case of Indian users, it could be salaries of the employees. Okay, there are a lot many things that are quite sensitive and quite critical that can that you might not want them to have access to. Okay, you need to grant them access, they need to view the data. At the same time, you want to have control on your data so that you can hide or show whatever columns you want to expose. Okay, this is where views comes into picture. Okay, views we looked at, in fact they are an additional layer on top of a table which helps us protect sensitive information based on our need. Now they need data, I mean we completely understand it, but sensitive information is something that is very, as they say, I mean sensitive, right? So you cannot just go ahead and share them. You need permissions from the users, you need a lot of things before you could actually share those details. Okay, and to do that, to accomplish both these things, there's a concept that we use the views. Okay, view is nothing but an additional layer on top of a table which enables us to protect sensitive information based on our need and only expose the columns that we want to expose for the outside users. Now a view is just a query on the top of a table. So like as we write a select, right? So we can name that query, as simple as that. A view is basically we write a select statement and name it. So whenever you call that view, the query that is written inside, the select statement that is written inside is executed and it gives you the data back. Okay, and the view, as I said, is just a query on top of the table. That is all that it has. It does not store any data of its own. Okay, and that is the reason they are very lightweight on the server. It is just a physical object created on the database, but internally it just has a query plugged on top of one table or multiple tables. As this is just a layer on top of a table, views do not store any data physically in the server. That means it does not have to store. It in fact is very lightweight on the server and does not store the data. Again, the one good thing that I like very much about the views is this. Okay, it is so lightweight on the server that it doesn't take any physical memory on the disk. Okay, and it makes absolute sense as well, because as I said, views are connected to tables and the data is already there in the tables. We don't have to maintain the same data in the table as well as in the view. The query is always there inside the view. Every time you call the view, the query is executed and it gets the data directly from the table itself. So it's a win-win situation. I mean, you don't have to store duplicate data, plus you get whatever data you want to get. But again, you can control what data goes from the table to the view. Okay. Instead, so the data is not stored in the view. Instead, the data when requested. So let's say I want to view the data from the view. I want to see the data that is inside the view or consume the data that is inside the view. I just when I execute it, the data when requested, that means when someone requests from the data from inside the view, the query that is running and that is defined in the background is executed and the data is returned. Okay, so let's say someone executes the view 5 times, the query that is written inside will be executed all the 5 times. Okay, there is no concept of caching or anything like it happens in procedures. Okay, this is a completely different object altogether, which is just a replacement or an alternate to a table. Okay, so moving on, let's see how to create a view. Okay, so I've already explained you what views are basically. Okay, let's see how to create a view. Let's start by talking about how we create a view. And to begin with, I'm going to create a very simple view which replicates exactly the table. Okay, like how the like all the data that the table has is just going to be exactly the same. Okay, so here I say create or alter view. Okay, this is syntax that we usually use for procedures, functions, indexes, and everything. And then here I say vw underscore. Vw is the prefix that I give to all of my views. Okay, so that I see it and know that okay, it's a view. Vw underscore get employee data. Okay, so I just name my view as get employee data, and then I say as, and as you can see here, I have just put a select star from employee. So no manipulations, no filtering, no column exclusion. Okay, just a very simple select, and I'm selecting all rows and all columns from the employee table. Okay, so if I execute this now, oh sorry, I'm in the master database. Just connect to until September, and let's execute this. And now this view is created. So where are the views created? Let me show you. You expand the databases, go to the database that you use, and then if you see here, there is a option called views. When there's a subfolder called views, expanding that, you will find the view that has been created. Now, how do we consume a view? Like, how do we extract the data from a view? It's exactly how tables work, because as I told you earlier, it is just a replacement of the table, and also helps you in filtering what data do you want to push to the view. But in this case, there is no filtering, no exclusion of the columns, no exclusion of the rows. It is a very simple select from the employee table. So the view basically should show all the data that the employee table has. Now, so for me to fetch the data from a view, I just use it like I consume data from tables. I say select star from, and then the name of the view here. So when I run this, you will see that it gives me the all the columns and rows from the employee table. Okay. Now, as I told you earlier, the view does not store any data. So all the data that you're seeing here right now is a result of the query that was executed that is inside the view. So when I say select star from view name, it executes the query that is there inside, which is the select star from employee. And obviously the select star from employee gives us all these rows and columns back. Okay, so if I execute this, let's say 4 or 5 times, 1 2 3 4 5 6, all the 6 times this query is only executed because the view does not have any data of its own. Now the advantage of this concept is that every time you execute this view, you will always get the latest data in the employee table. So if someone executes this now, it'll that particular user would get all the employee data till this current time. And that's a good thing, right? I mean, with the view, you're always getting the latest data that is there in the table. There is no lag at all. Okay. Now, looking at this, what you see is, I mean, the only thing that I'm concerned about, hey, I don't want to expose my salary column. Okay. So let's say I don't want them to see my table. So what I do now is I give them this view. Okay. The outside users, I give them this view. I'm going to talk about a little bit more. I mean, when I give examples, you will understand how these views are helpful. Okay, so here, let's say I show you this column, and I see that okay, the salary column is not something that I want to share with people from outside of my team or outside of my project or outside of my company. Now, how do we restrict those data, or how do I create a view to exclude a few columns? So in order to do that, okay, what I did is, you see here it had a star, but in this condition, I mean in the same view, I'm going to alter it, the same view name. Here, instead of specifying star, I specify all the columns that I need or that I want to expose to the outside users. So I'm fine exposing the employee ID, first name, last name, and address, but not the salary column. So I can say select employee ID, first name, last name, address from salary. And let me just not filter it yet. And let's say run it. So it says commands completed successfully. And now when I try to view the data from the see the data from the view, you will notice that it still gives me all the records. But now it only gives me the employee ID, first name, last name, and address. It doesn't give the salary column anymore. So anyone who is executing this view, whom I have shared this view, will only be able to see these 4 columns of the employees and not the salary column. Okay. Now, let's say you want to show, or someone has a request saying, hey, can you give me the records of the employees only from India? Okay, so in that case, what you do is you can say where address. So you can create a view as address equals to, sorry, in single quotes, address equals to India. Okay, and let me alter this view, and let's say Let me run the select again. And now whoever is using this view, whoever is consuming the data from this view, will only see the employees, or it will see the list of employees who are from India only. Okay, so this is how you can filter rows and columns so that you only expose the required amount of data. Now if you think about it now, I mean, this is the most feasible solution, isn't it? Let's say you have a sales table. Okay, you have a sales table, and there are 5 or 6 users in different regions requesting for data. Okay, so how do you accomplish it? I mean, you cannot give them the same table name, because everyone should be can will be able to see. If you give them access to the table, everyone will be able to see all the data from all the regions, and that is something that we would not want to happen. So in that case, you can create 4 views for 4 different stakeholders and use a filter for that specific region. So let's say you're creating one for Europe. Maybe you can say where location is Europe, or any other column that you can check to filter out only the European data. Similarly, if you are exposed, if you are requested for the UK data, you can create a view which will only expose the UK data. So there are multiple advantages associated with the view. The one more advantage that I mean, I love about views is that in views you can also join 2 or more tables. Let's say someone requests saying, hey, can you share me the employee data and the employee date of birth data as well? So instead of sharing both the tables, what you can do is you can create a view. Okay, I'm using the same view itself, wherein you can join the employee and the employee date of birth together, obviously on the employee ID like I showed you earlier. And here I can select the employee ID, first name, last name, address, and date of birth as well. So instead of sharing 2 tables with them, or in fact all the data from employee and all the data from employee date of birth with them, I can easily expose only the columns that I wish for them to see. Plus I can also filter this query. Let's say I only want to show India's data. I can always put a where clause after this saying where address equals to India, and it should work absolutely fine. They will just have to call this view to see the employee data and the date of birth corresponding to each of the employees. So let me just run this, and if I try to run a select from the view, you will notice that it shows the employee ID. I mean, the users can see employee ID, first name, last name, address, and date of birth as well. Although these 2 are not, I mean, this column and these columns are not in the same table, but inside the view, I have managed to join it. So this is like another layer that we apply on top of the existing tables to I don't know, facilitate sharing of data from tables.
Just a quick info, guys. Test your knowledge of SQL by answering this question. Which of the following SQL clause is used to delete tuples from a database table? A. Delete. B. Remove. C. Drop. D. Clear. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So let's move ahead then. Now, by now you must have realized that views are very tightly coupled with the column names and the table names. Okay, now let's suppose that I change one of these column names. Let's say I change it to employee ID of employee. Let's say in the employee table, I change this column name to ID of employee. Now, do you think this view would still work? As I told you, the view, every time we call it, it just executes this query to get the data. Now let's say you modify the column name to ID of employee, right? Do you think this view would still work? It wouldn't, because it's going to throw an error saying that the employee ID column doesn't exist. And why it doesn't exist? Because it has been renamed. It has been renamed to ID of employee. So this situation wherein the underlying columns or tables of a view has been modified, okay, and I'm only talking about renaming, okay, so renaming of any of these columns or renaming of any of these tables is going to cause the view to become orphan, okay. Those will be called as orphan views because the parent table or the columns are no more to be found. So views for which the base table or column has changed or has been altered is known as a orphan view. Now, can we do something in order for us to preserve a view, in order to ensure that the view works at all times? Yes, to prevent such scenarios, we can choose to schema bind our view. Okay. Now, what happens when we schema bind our view? When we schema bind, SQL ensures that none of these columns, okay, only the dependent columns, that is employee ID, first name, last name, okay, address, employee date of birth are not modified. SQL ensures that. Also, the employee and the employee date of birth table are neither allowed to be dropped nor renamed. Okay, so that will ensure that the view will work at all time. Okay, so schema binding binds our views to the dependent physical columns in the table, columns and table as well, columns, column and table, columns, sorry, columns and tables. Okay, now for example, here if you see the salary column isn't used, correct? So the columns that aren't used in the view, they can be altered, they can be modified. Okay, so schema binding is only applicable to the columns which are binded in the view. For the columns which are not binded in the view, although they are in the same base table, you can still alter them, you can still remove them, you can rename them, whatever you want to do you can do with them. But only the columns that are intact or that are referenced inside the view, that are there inside the query, those cannot be touched. Okay, so let me show you with an example how it actually works. Okay, so I'm going to create a view, create or alter view. Okay, I'm going to use the employee backup table. You remember this employee backup table that we created some time back? Let me just show you what it has. It has all the data from the employee table. Okay, now what I'm going to do is I'm going to create my view on top of this now, because I'm using the backup table for my demonstration now, because I'm going to do a lot of changes on this table, like removing columns, altering columns and stuff like those, which I don't want to do with the employee table. Okay, so I'm just demonstrating it with the backup table. So let me create a very simple function view which says create or alter view, and here I name the view as vw underscore get employee backup data. And let's say I don't enable the schema binding. Okay, I just say as and then select all the columns from the employee backup table. Okay, let's just go ahead and create this without the schema binding, mind it. Okay, it's a very normal view like we have been creating till now. Forget about the schema binding for now. So right, this view is created. Now if I want to select from this view, let me run a select from this view, and you see that it works perfectly all right. Now let me try to drop the first name column. The first name column is used right in the view. Let me say alter table employee backup, drop the column employee first name. Now remember one thing, the first name column has been referenced inside the view. Let's see what happens when I run this. So I say alter table this, drop the column first name. It works, and it allows us to drop the column although that column is referenced in the view, which is this one. So now this view has become orphan. Let me show you what happens. If I try to execute this view now, see, it throws me an error saying invalid column name employee first name, because that column has been removed by us just now, a little while earlier. Okay, and this is an ideal example of an orphan view. Orphan view is a view for which the base table or base column is missing. Okay, now let's try to do the same thing. Okay, let me try to drop the employee backup table. Okay, I'm trying to drop the employee backup. Now this is the parent table, mind it, of the view. Okay, and if you see now, let me execute this. It works. It allows us to drop the table as well. And if I run this again, obviously the backup table is not there, so it says invalid object name dbo_employee backup. So the view was orphan earlier, now also it is orphan, but the base table is also missing. Now how does schema binding help in this case? So let me recreate the backup table again. Control KU, recreate the backup table because I just dropped it, right? Now if I execute the view, it should work because the backup table is back again with all the columns. So the view works fine now. Now let me alter the view to include the schema binding. Okay, so you use the schema binding option here. Okay, right after you define the name, you say with schema binding and execute. It says commands completed successfully. So now our view has the schema binding option turned on. And now let's try to drop the column employee first name. Let's try to repeat whatever we did earlier. So let me try to alter the table to drop the first name column. Wonderful. See, what does it say? It says the object is dependent on the column employee first name. So the drop column does not work. This is SQL checking for us, okay? Only because we have enabled the with schema binding option, SQL is checking if this column is used in any of the views, and it finds that okay, it is used in the view_get employee backup data. Now, perfect. It doesn't allow us to drop the column. Does it allow us to make some other modification? Let's say you want to change the size maybe. Okay. So let's say from 100, I want to make it 120 on the first name column itself. This also is not allowed. The object is dependent on column employee first name. So you're not allowed to make any alteration on this column. Now I'm only talking about the design changes, guys. Okay, the data is allowed. I mean, it absolutely makes no sense for SQL to stop or prevent the data from getting updated, inserted, or deleted. I'm only talking about the alteration on the column itself, which is not allowed. So it doesn't allow us to drop it. It neither allows us to modify it or alter it to add or increase or reduce the column length also. Okay, now let's try dropping the salary column. Okay, you know we had a salary column in the backup table. Let's try to drop the salary column and see what happens. It works. It allows us to drop the salary column because the salary column is not being referenced in the view itself. So it is free to be dropped off, and it allowed it to be dropped. So the with schema binding is only applicable for the columns that has been specified in the select, and also on the base tables, obviously. Okay, and now if I also try to drop the main table, the base table, it doesn't work. It says it is being referenced by the object view get employee backup data. As simple as that, right? Now, if you want to view the definition, if you want to see the definition of a view, you can use the SP help text. This is something that I've explained to you while working with functions and stored procedures. So I'm not going to spend much time on this here. If you run this, obviously you will get, sorry, get employee backup data. Copy this one and paste it here. And this one, if I want to see the content, I can easily use the SP help text in front of the name of the view to see the definition of the view. That means what query has been specified inside the view. But as I said, this is for outside users, so it's always good that you encrypt it. But again, we don't usually encrypt it because the SP help text can be run by people who have higher privilege than a read permission. Okay, and for people who are going to use the views, we usually give them read permissions only. And for SP help text, you need a higher privilege than the read permission. So there's no harm or there's no fear of the query getting exposed as well. So here, if you want to, if you don't want your views to be scripted out, obviously you can use the with encryption option. And if let's say I create a function with a view with the with encryption, and let me just copy this and paste it here, and you will notice that it says the object is encrypted. Okay, so it doesn't allow this to get inserted. I mean, it doesn't allow us to see the content of the view. Okay, all right. So let's continue. Now, you already are aware of the null and the not null concept, don't you? So let's say I have an employee table and I have three columns in it, A, B, and C. Let's say the column A is nullable, B is nullable, C is not nullable. Okay, this is nullable, this is nullable, this is not nullable. That means A can hold nulls, B can hold nulls, C cannot hold null values. Now let's say I say insert into employee A and B and then select the values here. Do you think this is going to work? This won't work. The reason is, if you remember, I explained you how the nullable columns are optional during insert. That means if you don't provide a value for them explicitly, it will store null in them. Okay, it will store nulls in them. Whereas if you don't provide a value for the not nullable columns, SQL Server wouldn't know as to what value should be inserted into that column, right? So that's the reason you need to specify, or that's the reason the columns which are not nullable are mandatory. So at any point in time during the insert into the employee table, you need to provide for sure the column C. Without C, you cannot insert a row in the table. If I exclude A and B, that's perfectly okay. SQL can store nulls in them because these are nullable columns. But for C, I cannot exclude it during the insert, right? Now, I'll tell you why I was trying to explain this to you, okay? Talking about the DML operations on a view. Just increase the font. I think it's a bit too small for your liking. Yeah, okay. So let's talk about the DML operations on a view. Do you think we can perform DML operations, that is insert, update, and delete using a view? Yes, we can. Okay, views are not only meant to read data, okay, but we can also perform DML operations on them. That means we can also write into them. Okay, now here, as you already know, views do not have any physical data stored explicitly. So any DML operation that we perform on it is directly executed on the base table. So any insert, update, or delete that we do on the view, it directly impacts the base table. Okay, so here we can perform insert, update, delete on the table using the views, but there are two main assumptions that we need to go with. Okay, we can perform DML operations only if these two conditions are satisfied. First is the view should always have a single select. That means it should have only one table from where it is selecting the data from. It cannot have multiple tables joined together. In such cases, we cannot perform DML operations. Next up, all the not null columns are to be selected in the view. The reason is what I just explained you earlier. If the column C, let's say I create a view on the employee table, I don't select the column C in the view, there is no way I can insert a value into the column C. So all the not null columns should be selected in the view. If you don't, then it will not work. The DML operations won't work, especially the insert. Okay, so these two are the criteria for which only then we will be able to insert, update, or delete on the table using the views. Now, if you remember, we had a view called view get employee backup data. Sorry, you remember this view? I just created it above. And then the base table for this is this one, the the employee backup table. Okay, and if you see, both of them are exactly the same. The only difference is that I have not selected the last name column in the view. As you can see, in the view, I only have ID, first name, and address. The last name column is in the table, but I haven't selected it in the view. Very, it's fairly understood. Now, let me try to insert something into the view. So the two conditions that I was talking about, first one, the view should only have a single table. That is true because my view, the get employee backup data, if I show it to you, let me just show it to you so that you remember. This is the view, okay? And it has only one table. it has only one base table, right? So the first condition is true, and the next condition, talking about the next condition, there are no not nullable columns here. All of these columns, if you see, are nullable columns. So there is no problem with the second one as well. Okay, the second criteria said only all, so sorry, all the not null columns are to be selected in the view. Okay, I mean, you can have the rest of them, but all the not null columns should be mandatorily there in the view. But here, as the base table has no not null columns, so we are good on that aspect as well. Okay, so that angle is covered too. Now let's try to perform a insert on the view. Okay, so carefully observe, okay, what I'm trying to do here. I'm trying to insert into the view. If you can notice, I'm trying to insert into the view, get employee backup data, and I can only insert into ID, first name, and address. I cannot insert into the last name column because the last name column, although is there in the base table, but it is not there in the view. Okay, and that is the reason why we said that all the not null columns should be selected in the view, because if it is not, then you cannot insert into that column. And obviously, if you cannot insert it from here, SQL will try to insert null into that column and it would fail. So here I say insert into the view, and I specify all my columns. I select or I specify three values: 9, Tom, and US. So 9 is the ID, name is Tom, and address is US. And let's execute this. So it says one row affected. And if I show you the view, obviously the view gets the data from the table, right? So let's check the table first. Okay, so if you see here, this record has been newly inserted. I mean, only because of our insert that we did. So I did the insert on the view, but I selected the data from the backup table. That means the base table of the view. And as you can see, the record is already here. Okay, and here, if you see, the last name is stored as null because the last name is not a column in the view. So I can no ways insert value into this column using the view, because this column does not exist on the view at all, right? So the inserted directly into the table. And also, as you know, the view gets the data from the table, right? So you will see the data also shown up in the view. Now let me update the view. So I say update the view, set address equals to India, where the employee ID is 9. So for the new record that I just inserted, I want to update the address to India. And again, as you can see, I'm updating the view, okay, not the table, the base table. Okay, I'm not updating the base table, but this update will subsequently update the table itself. See, it shows one row affected. And let me show you the base table. See, for this one, the address has been updated to India. Earlier it was US when I inserted it, but now it has been updated to India. Right? So any insert or update that we do, it directly impacts the base table. And obviously now when I run the view, as the view fetches the data from the um, table itself, so you will find the address of this record as India. Now let's see the delete as well, the last of the DML statements. And let's say I delete this and I delete from the view again, where employee ID is equal to 9. So the new employee that I created, I'm trying to delete it. So let's delete. It shows one row affected. And now if I select from the backup table, you will notice that there is no record for ID 9 because I just deleted it. But I deleted it for your information from the view, but it automatically deleted it from the table because, as I said, the view does not have any data of its own. All that it has is the data from the base table. And if I run this view also, you will not find the ID 9 anymore. Now you might ask, the views are meant to be shared with outside users. Can they update the data on our tables? No, because whenever you create a view, we mostly grant read access to the outside users. Okay, so they cannot make any modifications through the view, because if they have read permission on the view, they can never be they will never be allowed to run insert, update, or delete on the view. So they can only run selects on this view. That is all about views. Okay, all right.
All right, so let's talk about transactions now. So, what is the first thing that comes to your mind when we talk about a transaction? The first thing that at least comes to my mind is a bank transaction. Okay, that's the very common term in the banking domain and in the masses as well, right? So, an ideal transaction would look like, let's take an example of transferring an amount worth $100, okay, between two parties. So obviously the first step that is involved is the initiation, wherein the request is placed. It could be a check deposit, it could be an online transfer request or anything. And then what happens is $100 is deducted from the payer's account, okay? And it is end of the day or end of the transaction is when the $100 is credited to the receiver's account. Only when all these steps are completed, that is when it is said that the transaction is complete, okay, and in fact completed successfully. Okay, now let's suppose that the initiation went well. I mean, the request was well placed, $100 was deducted from the payer's account, but then the $100 never got credited to the receiver's account. Okay, so let's say it was not credited due to an internet issue or a link failure or anything. As a matter of fact, I mean, there was some downtime on the bank data, on bank application, bank website, or anything, as a matter of fact. Now what happens in that case? So the $100 is already deducted from the payer's account and it did not get credit, it did not get credited to the receiver's account. So what happens in this case is the bank would revert back the $100 that was deducted from the payer's account. All right. Now the transaction began, but it failed at a certain point. So it was reverted back to the previous state it was in. Now, one very important property of a transaction is that the transaction should leave the database or the application in a consistent state as it was before the transaction started. Okay, so now if it would have left the $100 deducted from the payer's account, but it would have, but the it never got credited to the receiver's account, and the bank never bothered to return back the $100 to the payer's account, obviously there is inconsistencies in the data. There is $100 worth of amount that is nowhere to be found. It got deducted from the payer's account but never got credited to the receiver's account, and it never got reverted back into the payer's account at all. So clearly the transaction that happened or that got initiated left the database in an inconsistent state, and which is never the case, right? Ideally. So a transaction is either all or none. Okay, so in a transaction, either everything goes through fine, or if there is a problem with any of the steps, the rest of the steps are reverted back. And this is exactly what transactions mean in SQL Server as well. Transaction so are a set of operations when performed in a sequence such that all operations are guaranteed to succeed or fail as a single unit. So either everything goes well without any issues, or if one of them fails, everything else, all the other changes that has been done are reverted back or are rolled back. Okay, so that's the reason it is said that the transactions is either all or none. That means either it works for all the steps or everything goes well, else nothing is executed. Okay, now you might be curious as to, okay, where do we exactly use these transactions? So a transaction, so in here, now when I talk about SQL, in here in a bank transaction, we have different banking activities, right? But in a SQL transaction, we have multiple SQL queries that needs to be executed. Okay, so a transaction might have 50 queries, might have 100 queries, might have 3 queries, but end of the day they are all told to be in a single transaction. So either all the 50 queries go through fine, or let's say if the 49 queries work fine but the last one fails, every other change that was made before the 50th query needs to be rolled back, because as I said, a transaction will never leave a database in an inconsistent state. Now you might be curious as to when exactly do we use a transaction. The first These are a few examples that I'm sharing from my own experience. So when multiple number of rows are inserted, updated, or deleted in a sequence. Okay, so let's say that there are a set of 5 employees that are joining the organization today. So in the first place, what you would not need to do is add those employees to each of the departments, like the transportation, the food department, the IT department, the admin department. So all the employees should be added to each of the departments. Now, only when they are successfully added or onboarded to all the departments in the database, then we can see that, okay, the employee is onboarded now. So let's say he gets a identification number from each of the departments. I think that is where we say, okay, the employee is onboarded now. Now let's say the employees were added to 3 departments, and the fourth department, while adding them to the fourth department, there was some technical issues, okay, or SQL issues. Now in that case, we cannot leave the onboarding midway, right? We cannot say, okay, let's start all over again. That might not be a feasible option. Or let's leave it as it is, cannot also be a feasible option, because you don't want the employees to be onboarded to only 3 departments and the rest of the departments are not onboarded. I mean, the employee is not onboarded to the rest of the department. It makes no sense at all. There is no partial thing in the transaction. Okay, this is where a transaction is used. So when we want to insert something which is pretty much related into a set of relational tables, that is when we use a transaction.
Just a quick info, guys. Intellipaat provides SQL online training in partnership with Microsoft and mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
So either that related data gets inserted into all the tables or nothing at all. Everything else is rolled back if there is any issues. If there are any issues, the changes that has been done are rolled back. The other instance where we use transaction is when the changes to one table require the other table data to be kept consistent. Okay, now let's say for some reason, okay, for some given reason, your employee ID needs to be changed. Okay, let's say I mean, due to some reason the company decides, no, this employee's ID needs to be changed. So in that case, your employee ID column is a very critical column, right? It could be used as a foreign key in multiple different tables. So in that case, what you do is you need to modify all of the tables in a sequence so that you can remove off the old employee ID and update with the new one. Okay, and how, when can you do it? When all the child tables are updated with the new ID. Because if you don't do that, then there are high chances that some related data might get missed. Let's say for my employee, let's say my employee ID is 10 and the new employee ID that is given to me is 15, and there is a date of birth table where for ID 10 it has my date of birth now, and tomorrow my ID is changed to 15 but that table is still pointing to ID 10. First of all, that record is orphaned. Okay, if it is a foreign key reference, I mean, SQL wouldn't allow you to do that, but I'm just saying, okay, let's say there is no foreign key, so that record is left orphan. Plus Dinesh now doesn't have a date of birth because Dinesh's ID is 15 and that employee date of birth record has ID as 10. So there is no relationship left now between the tables. So in such cases where you are needed to change the data in a sequence of tables, okay, but this time,
Just a quick info, guys. Test your knowledge of SQL by answering this question. Which SQL keyword is used to retrieve a maximum value? A. Most. B. Top. C. Max. D. Upper. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
the major changes on one, but you're changing only the related tables, that is when you also use a transaction. So either you update all the related tables with the new ID, or you just don't update anything. The next instance, the next example is when we are working on modifying data across 2 or more concurrent databases. So let's say there are 2 databases which are pretty similar to each other and we want to keep them in sync. So what we do, any change, any update, any delete, any insert that we perform on the first database, we also perform the exact same operation on the second database as well. Now imagine that one of the database got updated. I mean, I ran an update query. One of the database got updated, but the second one did not get updated, and the query failed due to some reason. Now the data is no more in sync between both the databases, right? So that's a big problem. So in such cases where we have concurrent databases which should be kept in sync, so for those kind of operations, we put them in a transaction. So either the update works in both the databases and it is perfectly all right in that case. But if say the update was done on the first database but is failed on the second, then we revert back the update that was done on the first as well. Okay. Now, talking about a very important aspect, which is about transactions, I've already given a hint about this to you earlier. So it is categorized by four properties. Each transaction in SQL Server is categorized by four properties, often referred to as the ACID property. Okay, ACID is an abbreviation of atomicity, consistency, isolation, and durability. So the transactions are identified by these four properties, each transaction in SQL Server. Now, what does atomicity mean? Atomicity property states that the transactions should be regarded as a single unit irrespective of the number of steps that are involved. So the transaction might have two queries, two SQL queries, or 50 SQL queries. But end of the day, all of them should be considered as a single unit which would either succeed together or fail together. The next one is consistency. The example I've already given regarding the amount that was not credited into the receiver's account, but it was never reverted back to the payer's account. So in that case, the data was left in the bank database was left in an inconsistent state where there is no account for the $10, so the $100, right? So the consistency property in a transaction states that the transaction should always leave the database or the table in a consistent state after commit or rollback of the changes. So right after the transaction is committed or rolled back, then the database should be in a consistent state. There should not be any loss of data, or there should not be any data discrepancy whatsoever. The next property is called as the isolation, which says that each transaction has its own boundary and do not interfere with each other with other transactions. Okay, like let's suppose that there are two transactions, bank transactions, that are supposed to add $100 and $100 to my account on the same day. So let's say the transaction one finished first and the $100 was credited to my account, and then the second transaction, which is also running parallelly, comes to my account and checks that okay, the $100 is already added, so it could be because of me, and it doesn't credit the other $100. So ideally, end of the day, I should have had $200 credited for the day, but I ended up having only $100 credited, which is a bad thing. And that is what the isolation property states, that each transaction has its own boundary and it should not interfere with other transactions. If it does that, it's going to be a big problem. Okay, durability, this states that any data modifications that are done after the transaction is finished should be kept permanently in the database or in the system. It should stay permanently on the system. It should not vanish after a few minutes or a few hours or a few days. Okay, the data is there to stay and it should stay. Okay, so these are all called as the ACID property, which is ACID. So let's move on to the different types of transactions that we have. So the first one is called as the auto commit transaction, which is a pretty normal query window where I write my insert, update, and delete, and it automatically gets saved in the tables, right? I mean, I just write a insert or a select or a insert or a update or a delete, and the moment I run it in front of you, it directly gets written to the table permanently, right? So these statements are written as part of this are automatically treated as a transaction and is committed or rolled back once the statement is executed. Okay, so it's a very normal form of query writing. Okay, next type is called as explicit transaction, where we specify the boundary of the transaction. Okay, saying these is where the transaction is going to start in the SQL query, and these are the queries that needs to be inside, and this is where the transaction should end. So I specify the begin of the transaction, I specify all the queries inside of it, So if I place, let's say 500 queries after the begin transaction, and then I say end the transaction, so all these 500 queries will be a part of this particular transaction, as simple as that. And this is known as an explicit transaction, where we define the boundary of the transaction. Okay, so we manually specify the begin and the end of the transaction. And the third type is called as the implicit transaction, which I have never used. Okay, but there's a setting where you can enable it for all the statements that you have in your query window. So this is a query window, right? So all the statements that are there in this query window are treated as a single transaction, and I don't see a reason why would someone use that. Okay, but yeah, I mean, it's just there. All right, so now let's talk about, let me show you how a transaction actually works. So here, in an example of an explicit transaction, here I say begin transaction, and then I put all my queries below this. Okay, so what do I do here? I'm trying to update the employee table, where for employee ID1 I'm trying to update the last name to Yadav. Okay, so if I run this select, you will notice that the last name is set to Kumar, right? Now let's say I want to set it to Yadav. Okay, and I want to do it inside a transaction. Now this is only one SQL statement, but ideally we have more than one SQL statements, but let's try to just do this. Okay, let's say employee, I want to update the last name to Yadav, where employee ID equals to 1. And if I execute this, now I need to execute with the begin transaction, so that SQL knows that this query is inside a transaction. Okay, so let me execute this. It shows one row affected, right? And if I run the select, now I haven't ended my transaction, mind it. Okay, I just begun the transaction and run my update. Now if I run my select from the employee table, you will notice that the first record has the last name as Yadav. Okay, so the earlier it was Kumar, but now it is Yadav. But we haven't finished the execution yet. How come is it visible? This is called as dirty read. Okay, dirty read is when, oops, sorry, why does OneDrive want to sync? Okay, anyways, so this is called as a dirty read, and dirty read is when we read data that is not yet committed to the database. This one is not yet committed, neither rollback, but we are still reading the new data. This is dirty data because this is still inside a transaction and SQL is allowing me to read it, right? So now, what exactly happens when a transaction begins? So when a transaction begins, right, all the changes that you make here stays on the log file. Okay, you remember when we created a database, I told you that there are two types of files that gets created. One is MDF, one is LDF. The data is stored in the MDF, master data file. But in the LDF, we only have the logs, okay, the transaction logs. So when I put the queries, all the queries that are there under the begin transaction, all these changes reside in the log file. Okay, only when I commit it, okay, then this data is permanently written to the MDF, the master data file. If I roll it back, it is wiped off from the log file as well. So there is no trace of it anymore, because I mean, we didn't do anything. We just began the transaction, made some modifications, rolled it back. So that's all right. I mean, it gets wiped off from the log file altogether. But let's say I put this in a transaction, all the changes are there in the log file right now. And if I say commit, it'll move those changes permanently to the MDF file and ultimately to the table. So that data is proper committed data. But when I try to read something which is in a transaction, it is called as dirty data. Now let's say I roll it back. So as I told, if I roll it back, it would get wiped off from the log file altogether. So let me run this. It says commands completed successfully. And now if I see the employee table, you will notice that the last name is set to Kumar back again, because I choose to roll back my change. The query, the data that I updated, or the operation that I performed as part of the update has been rolled back now. Okay, if I would have said committed, then I would have seen Yadav here. Okay, but that time Yadav must not have been a dirty data. Right, now is there a way in which I can choose or set saying that I don't want to read dirty data? Yes, those can be controlled by using isolation levels in the transaction. Okay, or as we call it as the transaction isolation levels. Okay, and this we can use to control if we want to see dirty data from the tables or not when we are running the selects. Okay, so what are the different transaction isolation levels? Now there are multiple types, but I'm going to talk about the two important ones, and I'll leave it up to you to explore the rest once you feel confident on these. Okay, don't just go in and read about the rest of them because those are a little too complicated. I'm just going to talk to you about the two very basic regularly used isolation levels, and the rest of them you can explore once you have a good hands-on experience on these. The first one is called as the read committed isolation level. Now the read committed isolation level will only read committed data in the table. That means all the data that is committed in the table will be read as part of the read committed. Now, how does it ensure that it reads only committed data? So, in order for SQL to obey the read committed isolation level, if there is a transaction running on the table, the query will wait till the transaction is complete. So automatically, if there are no dangling transactions, if there are no transactions active on that table, obviously it will not, I mean, we can be sure enough that all the data that is there on the table are proper data, are actual data. There is no dirty data in it because there are no transactions. So obviously all the data that we have are permanently written data on the table. There are very less chances that they might be rolled back because there are no transactions to be rolled back. That is how it ensures and works at the read committed isolation level. Okay, now coming to the read uncommitted isolation level, in this case, in this level, the uncommitted data from the table is also read, so it brings dirty data as well. Now we did not specify, right? We did not specify the read uncommitted isolation level, but the select still gave us the read uncommitted data, that is the dirty data. So this is because the default isolation level in SQL Server is read uncommitted if you are running the select on the same query window where the transaction has been run. So let's say, so I ran the transaction on this query window and I ran the select also on this same query window, right? So in that case, the transaction isolation level at default one is read uncommitted. But how can I specify it explicitly? Let me show you with an example. Okay, so here let's see what does the employee table have for employee ID 4. So for employee ID 4, the first name is Steve. Let me try to update it to David, but this I want to put it in the transaction. Now for your information, I'm going to paste the original name here, which is Steve. Okay, this is the original name. I'm going to say original. Okay, so this is Steve is the original name. I'm trying to update it to David. Okay, now let's run this inside a transaction minded. It says one row is affected, and if I say select star from employee, look what it gives me. For 4 it gives me David. David is the one that I just updated, but this table already has a transaction, right? I just begun the transaction and run the update. I've neither committed it nor rolled it back. That means there is a dangling transaction, that is an active transaction on this table right now, but I'm reading dirty data. That's the reason I said when it is in the same query window, then the default transaction isolation level is read uncommitted. Now let's see how to explicitly specify the isolation levels. So let me copy these two queries. The transaction is still active minded. Okay, I've not committed or rolled it back yet. So let me put a vertical diagonal and paste it. So this is how I specify it. I say set transaction isolation level read uncommitted and then select query. So this one will read dirty data, right? Because this is uncommitted isolation level. So it'll read the data, ignoring the fact that there is a transaction running on the table. Let me run this and show it to you. See, it reads the data and it reads David. And David is the one that David is the one that I updated just now. Make sense? So it updated it to David, although I mean, it reads me as David, although this is not permanently written to the table yet. So this is how the uncommitted works. But let me show you the read committed one. Okay, and I just run this. See, it keeps executing it. It does not return the result, which proves the point that I told earlier. I said that it will wait. The only way it can ensure that it is reading committed data to ensure that there are no dangling transaction or active transaction on the table. Now, when I ran this query, it found out that there is an active transaction on the table. So it is waiting for that transaction to be ended so that it can read the data. Now, let's say I roll it back. So ideally, what should it read? It should read Steve, right? Because this was the original value. I updated it to David inside the transaction, but then I'm rolling it back. So it should ideally read Steve. So let me try to roll it back, but let me do it with a countdown so that you see the moment this transaction is rolled back, you will see the data right at that moment itself on this part of the query window. So keep an eye on this part of the query window, okay, on the right hand side of your query window. And I'm going to roll back this transaction. So in 3, 2, 1, and here we go. See, the moment this was successful, this returned me the data, and now it returns me Steve, which is the original name prior to the transaction. So this is how SQL reads the committed data. But this has a lag because every time there is a transaction, it will keep executing the query. Okay, which might not be a good thing. But again, if you are very concerned about your data that you are reading, you can use the read committed isolation level. Okay, in banking industry, it is very relevant. Okay, you don't want to use any uncommitted data in a banking database, okay, because it involves a lot of money. Again, I mean, that's a big factor. Let's talk about error or exception handling. So what happens when we get an error in SQL Server? We get a red color message and the query ends there itself, right? But is there a way in which we could handle the errors, like store it in a variable or store it back into a table or something of that sort? Can we efficiently manage our queries to not fail when there is an error, but at the same time catch that error? So the try catch block helps us do that. It helps us in handling the errors. Now, the try block is where all the SQL statements are placed, okay, that we want to execute. We place all of them in the try block. And if there is any error from any of the SQL queries in the try block, the catch block is automatically hit. Okay, let me show you a quick example so you can relate to it. Okay, so you can understand it better. So here, what I'm going to do is I'm going to say begin try, and then all our SQL statements goes in here. If you want to write updates, deletes, inserts, anything that you want to write, you can write everything inside the try. And then once all your statements are done, you just end the try block. Okay, so all your SQL statements that you want to run goes here. Now let's say the first one runs fine, second one runs fine, third one runs fine, the fourth one has an error. That very moment the catch block is hit. You see the begin catch? The cursor moves to the catch block and it executes whatever is there in this catch block, right? So let me show you an example. Okay, let me comment these. And what I'm going to do here is I'm going to say, let's say select Dinesh. Very simple one as name. That's it. So I begin my try, I select something and then end my try. And then in the catch, I just print catch block is hit and then end the catch. Very simple stuff. Okay, let me run this. So what should be executed? So you need to remember one thing, that only when there is an error here, then the catch block is executed. If there is no error here, then only the SQL queries are executed. Okay, so let me run this and show it to you. Let me run this, and you see it just selects my name as it selects Dinesh as the name. Okay, so there is no error whatsoever. But let me try to divide 1 by 0. Now 1 by 0 is a fatal exception in any programming language. You talk about SQL, Java, .NET. Okay, you cannot divide a number by 0. Okay, it's a fatal exception. So let me run this independently and show you. See, it throws an error saying divide by 0 error encountered. So now let me run this whole thing and let me show you what happens. So if I run this whole thing, see, now it doesn't throw me any error. It doesn't give me any error because it went into the catch block and printed this message. So it proves the theory, right? That if there is any error here, the catch block is hit. And see, I've printed the message saying catch block is hit. So the catch block is now hit because of this query, because it has a error in it. Now, let's say that I want to do and I want to catch the error that was thrown from here. So there was an error, right? Obviously it was throwing divide by 0. Now can I store it in a variable somewhere? Yes, I definitely can. So in here what I'm going to do is I'm going to create a variable. I told you what variables are earlier, right? Variables are just memory, are just containers which reserves a space in memory to hold a value. So I'm creating a variable. The variables are usually prefixed by @ symbol and we declare them. Okay, so the variables we declare. So I create a variable with the name error message of type varchar, and it can hold up to 1000 characters. Okay, and here I say set error message. You see this variable, I say set the error message equal to the error message function. Now what does the error message function gives me? It will give me the error that's been thrown from the try block. Okay, that is how this function works. So it'll give you the error message that's been thrown from the try block. So we store that message in the error message variable, and then end of it I just select the message, the error. Okay, so let's run it now and see what happens. See, it now shows me the message saying divide by 0 error encountered, and it is coming from where exactly? It is coming from this part of the catch block. So when the when SQL started executing the query, it started from the begin try perfectly okay. It came here. Now that it is, now this throws an error only because it is inside a try block. It directly goes to the catch block, prints this statement. Let me show you where it is printed. If you go to messages, see it says catch block is hit, and then it runs these queries as well. And in this, I declare a variable, I store the error message in here, and then display the error message. Okay, simple. And now, although the query has an error, but it does not throw an error. You see, it says query executed successfully. So now if you want, you can either use this message to send it to the UI, because the application will not know, right, if there is an error. So you can either store it in a table for logging purposes. It's up to you. You can store this with the date and time saying, so you know that at this date and time this error was encountered. Okay, so you can do a lot of things with this, but the main purpose of the try catch is to handle the errors well, handle our queries to run in a better way. Okay, because when it throws an error, there is no control on what SQL does. It just throws the error and then it gets lost. I mean, there's nothing that we can do. We have no trace of it. We cannot store the value of the error or anything at all. But this gives you a more controlled approach to it. Now let's say you have more than one queries. Okay, let's say I have another query and this one also throws an error. Let's suppose this one also throws an error. You already know it will not be able to add a string and an integer. We need to use the cast, right? So it throws an error saying conversion failed when converting varchar value Dinesh to int. Okay, so now if I execute this, what will happen? Okay, so now I have two statements with two different errors. So if I execute this, it still throws me the same error, and the catch block is hit only once. Why? Because you need to understand this thing. So it goes query after query. So the moment the first query fails, it has an error, it goes to the catch block already. So it doesn't execute any other queries after the error is encountered. So if the error is encountered here, it will not execute any other queries below it, because it already goes to the catch statement or the catch block in the first query itself. Okay, so obviously it would only display me the error message from this query. Okay, so this is how a try catch block helps us have more control and more authority on the errors that are being encountered on our queries. Perfect. Now, let's try to see how this can help us with the transactions. So, as I told you, the transaction, so we begin the transaction and we commit or roll back based on what. So, let's say if the transaction has 10 queries, okay, and if 5 of them ran fine and one of them throws an error, then we roll it back. If all the queries run fine, we commit it. Now this is all manual, right? I mean, we run this query and then if there is no errors, we commit it. If there are some errors, we roll it back. Okay, but how can we automate the commit if everything is well and roll back if there is an error? This is where the try catch block is going to come in handy. So with the try catch block, okay, I can combine this with the transactions to make it even more effective. How? You know about the begin try and the end try, right? And inside this we specify all our queries. Now what I do is I also begin my transaction inside the try block and then place all the queries in here. Let's say there are 3 queries that I want to run, and then end of it I say commit transaction. This is all happening in the try block, mind. So I begin my transaction here, I commit it right after all the queries are done, and then in the catch I roll it back. I roll back the transaction and then end catch. Now let's see what happens. Okay, there can be 2 situations. One, everything runs fine. So the try begins, transaction begins, everything runs fine. The transaction is committed because everything ran fine. So there's no harm in committing it. And then the try is ended. The catch isn't executed because there was no error at all. Now let's say the other situation wherein we begin the try, transaction is begin, the first 2 queries ran perfectly okay, but by the time the third query was running, there was some error. So what happens? Right when the error is encountered, the control goes to the catch block now. Okay, it does not execute the commit anymore. It goes to the catch block and it rolls back the transaction. That means it rolls back whatever changes was done for queries 1 and 2, although they did not have any errors. But if you remember, transaction is either all or none. So either all of these 3 queries get executed successfully or none of them execute. There is no partial execution in a transaction.
Just a quick info, guys. Test your knowledge of SQL by answering this question. Which of the following SQL clause is used to delete tuples from a database table? A. Delete. B. Remove. C. Drop. D. Clear. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So this is how we can leverage the error handling with the transactions to make it automatic now. So when I execute this query, it will automatically check if there are no errors, it will commit it. If there is an error, it will roll it back. You see, it looks very complicated, but when you understand the concepts, this is the beauty of SQL Server. Okay, this is the beauty of the language SQL. It is, I mean, there are no complex statements at all. It is just that the placing of the queries makes it look a little bulkier. Okay, but if you understand the concept, it is as easy as learning, I don't know what is the easiest thing to learn, but yeah, I mean, I just wanted to compare it with that. Right? Any ABCD? I mean, if you ask, ABCD is difficult for a kid. So there's nothing that is easy in this world, but I'm just trying to say. All right, so let's see how do we leverage this in a procedure. Okay, so here, I mean, it might look a bit long, but bear with me. Okay, I don't want to use these. Okay, so here what I do, you already know, create or alter procedure. Let me just reduce the font a little bit. So here I begin my procedure as begin, right? So this you already know. You know what this one does, right? The set transaction isolation level read committed. Okay, this helps us in reading only the committed data from the tables. Now here, if you see, this is where the try block starts. I begin my transaction, and if you see, observe carefully here, I have all my statements here, all the update statements that I want to run together as part of the transaction,
right? So begin transaction, all the queries in here. Then I commit my transaction and print a message saying transaction is committed. And then here, sorry. So I commit my transaction, print a message and try. And then in the catch, I just have a rollback as I showed you earlier, and then just print a message saying that the transaction was rolled back. And I end the catch, and this end is for the procedure that I begin here. This is for the procedure. Okay, I had a procedure begin, right? Now, what do we have in the update statements? Let's check it here. So what does the first update do? It sets the last name to Yadav for employee ID 1. Good enough. It inserts a new record into the employee table with ID 10. Perfectly all right. Now the third query is I'm trying to update again the employee table, setting the employee ID to 1 by 0. You know this is going to throw an error, right? Because it's you already know it throws a divide by 0 exception where employee ID equals to 1. So this query is going to throw an error now. Okay, that means obviously none of these changes should happen when I run this procedure, because all of these are in a transaction. So the first query will run fine, the second query will run fine, the third query will throw an error, and hence the the cursor will go to the catch block and it will roll back the transaction. If everything would have run fine, then the commit would have run. Simple. Now let's create this procedure. Okay, let's create this procedure. Okay, fantastic. Let's execute this procedure now. Okay, see, it says transaction is rolled back. Why? Because as I told you earlier, the queries had a problem, right? The third query had a problem. Now, if I show you the employee table, you will notice that the last name will not be Yadav for employee ID 1, and this record will not be there in the table. Let me just show you by selecting. So you see, for ID 1, the last name is Kumar and there is no ID 10 here. That means none of the changes are performed on the table. Although the first two queries are okay, but only because all of these are in a transaction, that's the reason it rolled back the first two as well. Okay, now let me comment this for you. Okay, let's comment this. And now let's alter this procedure. So now the procedure should run fine, right? So it should commit the data this time. So let me run this, and it says transaction committed. And now when I run from the employee table, see here, the last name has got updated to Yadav, and there is a new record with ID 10.
Okay, so what are CTs? CTs are commonly called are known as common table expressions. So you remember when we spoke about global temp tables, local temp tables, table variables? CTs are also like that, exactly like that. They are temporary storage that helps us store data in them. Okay, so the scope of a CT is different when compared to temp tables, table variables, and stuff. Okay, so let me show you first how to create a CT, and then I'll explain you the scope of it. That means till when can we access a CT. So to create it, we start with a semicolon and then say with the name of the CT. And then here I specify the columns only, not the data types, only the columns. So this CT is going to have 4 columns: first name, last name, address, and date of birth. And then as I inside my bracket, I specify what data should be stored in the CT. So here I select the first name, last name, address, date of birth from the employee, inner joined with the date of birth, and I'm only storing the Indian employees in the CT. You see, I use a where clause here. Now let me create this CT. Whoops, it throws an error. The reason is with the CT, you will have to select from the CT right after it is created. Okay, you cannot just create a CT without selecting from it. The first query should be select from the CT, and now if I run this, it should work. See, it now gives me these details. Now, one thing that you need to understand here is that the scope of a CT. Okay, the scope of a CT is only till the first select inside the same batch. Now, see, let's say I create and select the CT. Okay, I see the data. I run the select also with it, right? Now, if I run the city separately, I cannot find it. So it's same as that of the table variable. But the table variable, we can use it multiple times, whereas a city can be only used once. Let me show you. See, I have a select from the city here. I have another select from the city here. Okay. Now, if I run this, you will notice that only the first select will give me data, but the second select that I have, it says invalid object name city employee. Okay. So this one throws an error, but this one works. Is because the CTE, the scope of a CTE is only till the first select inside the same batch. So you cannot use a CTE more than once after you create it. I mean, in more than one statements. You can join them like this. See, you can let's say cross join. Okay, if you want, you can use the CTE multiple times in the same query, but only in the first query. You cannot use it again in the second query. So it is only available in the first select right after it is created. Okay. Now, where exactly is this CTE created? The CTE is created in the memory, like the table variables. Okay, these are not created on the temp database. So these are faster, but as it is stored in the memory, we usually store only a very small amount of data like table variables. But these, we just can use them once. So for any type of data that we want to use only once, we create them as CTEs. Okay, so it's like a temp storage itself, but it is meant for very small amount of data that we want to use only once. That's it. Okay, that's about city.
So the meaning is pretty simple, guys. As I told you, SQL stands for Structured Query Language, and it is one of the most amazing language which is basically used to manage a relational database system. And what is MySQL? MySQL is the relational database system which is basically used alongside SQL to perform operations, guys. So any operations such as storing data, retrieval of data, or modification of data in the database. And this brings us to the second point, which is basically complexity. When we have to talk about complexity, SQL as a language, it has to be learnt on, it has to be worked on and practiced to ensure that you can make the most efficient use of your queries to work with your database. Then coming to MySQL, MySQL is basically a readily available software, which is, you can download it, install it, and begin working with it without much of a prerequisite. And then coming to point number 3, it is the type of usage that we have to talk about, because SQL is a very fine language. It is a very well tuned language which is put together to work with a database. But MySQL is an entire database software, an entire platform which is basically making use of SQL to query the database, guys. Again, when you have to think about what to learn with, again, if you're using MySQL, then obviously learning SQL is a prerequisite. But then if you're just learning SQL, then you might not have to work with a MySQL database, because there are many other forms of relational database management systems where you can go on to use SQL as well. Coming to point number 4. Point number 4 is the purpose. When you have to talk about purpose, again, SQL is the language which is used to operate on the database, while MySQL is the tool which allows SQL to perform operations such as data handling, data storage, data modification, deletion operations, and much more. So I hope you guys are getting the general picture here. SQL is the language, while MySQL is the database on which SQL works with, guys. Coming to point number 5. Point number 5 is the usage. When we have to talk about usage, again, there are various techniques which SQL uses. There are multiple code segments, code snippets, multiple commands, and pretty much everything else which is used to talk to various RDBMS systems. And in fact, MySQL is one of them. But then we have to talk about MySQL. MySQL is the RDBMS database pretty much, which ensures languages such as SQL can run on top of it. But then if you're thinking how well does SQL run on MySQL, guys, it is extremely efficient. And even today, SQL is a very old language, and MySQL is a pretty old open source software too. From its day of the release, pretty much all those years ago, it's still there. And I would not consider calling SQL or any of the MySQL RDBMSs as legacy, because as I told you, there are companies around the world, Fortune 500 companies, who make use of these every single day, guys. And then coming to point number 6, it's updates, because SQL is a fixed language, right? So no matter what, there are multiple flavors of SQL. Of course, there's Oracle SQL, there's some Microsoft SQL, there's multiple types of SQL, which is basically like a flavor of it. You can run pretty much, if you learn SQL, right? So SQL is a fixed language. If you learn it, then pretty much you can all the code, all the commands, 99% of the code segments of the syntax pretty much remains the same. But then when you have to talk about MySQL, the updates are more frequent here, because at the end of the day, it's a software and it has to cater to various customer bases. But then even at the end of the day, solving bugs, making your software more efficient, or helping you work with your database management system in a more efficient way, if that requires frequent updates, then yes, MySQL provides that, guys. Then coming to the quick summarization of this particular difference, SQL, as I told you, it has been a big player, it has been a huge player in the world of IT, and it is very, very vital when we have to talk about the applications and its usage in applications, guys. And coming to MySQL, MySQL brings about a software which pretty much makes the best possible way to store structured data into it on the database, and eventually to work with it later on by making the developers or the coders' life a lot easier, guys. And on that note, you have reached the end of this quick comparison between SQL and MySQL.
Just a quick info, guys. Intellipaat provides SQL online training in partnership with Microsoft and mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
Okay, so we've seen that. Next, we'll look into the skills to have as a SQL developer. So we saw what are the requirements and the roles of an SQL developer. Now the skills. First of all, data management, obviously, because database manages, has data in it. So to manage that, you will need to know a very good knowledge of SQL, so that you will be able to manipulate it and also manage the data accordingly. Software programming is required. It is not mandatory that you can only become an SQL developer having a very thorough knowledge of a programming language, but having the basics or having the intermediate knowledge of software programming. So let's say your company uses Java, then learning how Java works will obviously help when you build a database for that company. So because that database should be compatible with Java. And yes, so that's what you should also know, software programming. Server development and maintenance. So this again, you can learn on the go. So server development in the sense to run virtual machines and to create databases on it and also maintain it. Problem solving, if there is a problem arised, if there is a problem, so this particular person should be able to create a query which solves that problem, or should be able to make the database more compatible. And then TSQL, which is basically related with transactions. So learning this is not compulsory at the beginning for an SQL developer, but learning this will also improve their chances of getting a job. Then process enhancement, this is to make better business decisions. So you can be an SQL developer and also be involved in process enhancement. That is, a company might go with a set of processes which is already organized and they go with that flow. So let's say an SQL developer can go ahead and change that process if that benefits the need. Okay, so these are the basic skills which you need. First of all, learn SQL. So that is the most basic thing. So if you learn SQL, you'll be able to manage data and understand software programming, because without software programming, without knowing how an application works, you will not be able to build an compatible database with it. Development and maintenance, problem solving, SQL, and process enhancement. So make sure to go by the flow. Start off with SQL, software programming, and then move ahead with the other tools. And then the career path. So once you have all these skills, you can obviously start applying for a job. Then as an SQL developer, there are various profiles. It is not just developer. There are so many different profiles within a company. So as I told you, a database, an SQL developer should be able to maintain, should be able to build, should be able to manipulate. So let's say if you want to maintain a database, so you can become a database administrator. So the basic task of a database administrator is to administer the usage of the database in that particular company. So you will be the head of the entire database system. You will be able to administer every single transaction. So it's basically maintaining. And then a database developer is a person who builds and also manipulates databases. So you can also become a database developer by having the skills. So let's say for a database administrator, you should go with more of a view that you'll be able to manage any kinds of problems which are arising. You should be able to solve any kinds of problems which are arising. A database developer should go with, let's say, this person should be able to create SQL queries for any scenarios given in the company. Okay, so next is data scientists. So obviously data scientists need SQL. Without SQL, it will be very hard for them. So SQL is a need for data scientists as well. So learning any SQL, that is any SQL engine, will help the data scientists. And then ETL developer. So this basically involves big data, extract, transform, and load. And again, you can also become an ETL developer by learning databases. Then BI developer and administrator. So BI is business intelligence. So in business intelligence, you obviously need to create visualizations, and to create visualizations, you need to manipulate or query data. And to do that, you should obviously know SQL, and it will help in becoming a BI developer. So to become a BI developer and an administrator, you should not just know these skills which I showed you for an SQL developer. You should also learn BI tools like Tableau or Power BI. So only then you can move ahead with BI. Okay, so now we've seen that. We'll look into the certification path for an SQL developer. First of all, what are certifications and why do you need it? First of all, it's a stamp of excellence. That is, if you have it on your resume, it adds value, so that you don't need to even explain that you know database. If they see that you have a certificate from Oracle, or let's say a certificate from Microsoft, they will understand that you have prepared and cleared that exam and you know well enough. And then substantial increase in pay. So once you get earning certifications, obviously you are putting in time and effort to make yourself better in your career. So that will obviously give you a good hike. Clear corporate requirements. So as I told you, every single company needs a database developer. So for that, for clear corporate requirements, that is, few companies might have a requirement of having a particular certification, and that will help if you are going to go for that particular job and helps get you hired. So obviously everything goes back to that point. So these are certifications. Why do you need a certification? And also, while you do certifications, you'll be able to understand a lot, and also will be able to experiment with a lot of projects before you enter the corporate career itself. Okay, so these are some SQL developer certifications. First one is the IBM Certified Database Administrator, DB2. So this involves the database called DB2. Then Microsoft SQL Server Database Certification. This involves Microsoft SQL. And then Oracle. Under Oracle, there are two. One is Oracle Certified Professional, or MySQL Database Administrator. So MySQL is one of the most popular databases in the world, and you can go ahead with MySQL Database Administrator without any hesitations. But the one more thing you'll have to remember is there are n number of MySQL Database Administrators or Oracle Certified Professionals. Also, Oracle Database 12c Administrator is also one more certification which you take up to go for a particular role. So these are some of the most popular certification courses. So for SQL developer. So if you want to, it is not just, so let's say if you complete the IBM certification, it is not just you can go for IBM. The thing is, you can go for any company which uses DB2. Or if you do the Microsoft SQL Server, so any company which uses Microsoft SQL Server needs a database developer or an administrator with an apt certification, and you can be eligible for that, and same goes with Oracle. So these are some of the popular certifications. You can check out more if you want to check out other, so let's say MariaDB, or there is a number of database engines out there. You can go ahead and check them out. So these are some of the popular certifications and highly recommended. Okay, so we've seen that. Now let's look into the most important part, which are the job trends, because obviously at the end of the day, you will need a job, and also salary. So first of all, SQL developer in the USA, they are getting about $72,282 per year as an average. So this is the average amount. There is a low, there is a high to this. And in India, it goes around 6.5 LPA. So these are the two variants in US and India. So this is for an SQL developer role, and this is totally relative because this data is collected from Glassdoor or Payscale, and those data is based on the salaries which other let's say there are 100 users in Glassdoor who are SQL developers. If they post their salary, it is aggregated and the mean is given to you as the salary which is provided here. So it can vary. It can be it can be lower than this for a beginner, and it can be higher than this for a experienced database professional. So we've seen that. So who's hiring? So every single company which uses the database. So that puts under Uber, Spotify, Netflix, Instagram, Dropbox, Airbnb, Twitter, and any other company. So you can go ahead, learn this, and you will have to pick out. You will have n number of companies to pick out. You can attend a lot of interviews, and if you're talented enough, you will be able to bag a job in a couple of days or maybe weeks.
So what exactly is SQL? So this is a very basic question. So to answer this, SQL stands for the Structured Query Language, and according to ANSI, it is a standard query language for relational database management systems, which is used for maintaining the relational database and also to perform different operations of data manipulation on different types of data. So SQL is widely used language for maintaining relational database, and in the year 1986, SQL became the standard of American National Standards Institute, or ANSI. So basically it is a database language which is used for creation and deletion of databases, and it can be used to fetch and modify rows from the table and also multiple other things. So let's head on to the next question. So we are supposed to explain the different types of SQL commands. So the SQL commands can be divided into 4 categories. So we've got data query language, data definition language, data manipulation language, and data control language. So the data query language comprises of just one command, select, though it can be accompanied with many clauses to compose queries on a database. Then we have the data definition language. So DDL is that part of SQL which defines the data structure of the database in the initial stage when the database is about to be created. So it is mainly used to create and restructure the database objects. So you can see commands like create table, alt table, and drop table in DDL. And after that we have the data manipulation language. So DML is used to manipulate the already existing data in the database. That is, it helps the user to retrieve and manipulate the data. And it is used to perform operations like inserting data into the database through the insert command, updating data in the database through the update command, and deleting data from the database through the delete command. And finally, we have the data control language, which is used to control access to the data in the database. So these DCL commands are normally used to create objects related to user access and also to control the distribution of privileges among users. And you see commands such as grant and revoke in DCL. Right, so this is the next question. So what exactly are constraints? And we are supposed to explain about the default and the unique constraint. So constraints are basically used to specify some sort of rules on the data and limit the type of data that can go into a table. Alright, so let's understand about default constraint. So the default constraint is used to provide a default value for a column. So the default value will be added to all the new records if no other value is specified. For example, if we assign the default constraint to this e-salary column and set the default value to be equal to 85,000, then all the entries of this column will have a default value of 85,000 if no other value is assigned during the insertion. So similarly, we can also assign a default value of analytics to this eDEPT column. Right. So now we'll go to SQL Server and we'll work with the default constraint. Now I'll start off by creating a new table and I'll add the default constraint to one of those columns. So I'll create a new table and I'll name this table as stu1. So the syntax would be create table stu1 and this would comprise of these columns. So there would be SID, which basically stands for the student ID, and the data type of this column would be integer. After this, there is SName, which stands for student name, and the data type would be varchar, and the length of the string, or the maximum length of the string, would be 20. And then I'll finally have the marks scored by the student, which would be SMarks, and this would be of integer type. Now after this, I will give in the default constraint, and I will set the default value to be equal to 50. Right, so I have successfully created this table. Now let me have a glance at this table first. So select star from stu1. So this is our table, which is empty as of now. Now what I'll do is I will go ahead and insert some values into the table. So I'll type in insert into stu1, and then I'll give in the name of the columns. So this needs to be insert. So the name of the first column is SID, and then I've got SName. Now I'll type in values and give in the values for these two columns. So let's say the first ID is 1 and the name of the student is Sam. Now I'll click on execute. Now let me have a glance at this modified table now. Select star from stu1. So now we see that we have this default value of 50 in this SMarks column, and this is because we had assigned the default constraint to this column. Now similarly, let me add two more records into this table. So insert into stu1 SID SName. I'll give in values. So it'd be 2, and the name of the second student is Bob. Right, so I've also added the second record. Now let me add in the third record. So the student ID is 3 and the name of the student is Matt. Right, so now I have 3 records in this table. Select star from stu1. So these are the 2 new records, and the default value is 50 for these 2 new records. So this is how we can work with the default constraint. Now comes the unique constraint. So the unique constraint ensures that all the values in a column are different. For example, if we assign the unique constraint to this ename column, then every entry in this column should have a unique value. So here we see that all the names of the employees are different. Now again, let's go to SQL Server and work with a unique constraint. So again, I'll create a new table and add the unique constraint to one of the columns. Create table, and this time the name of the table would be stu2. Again, there would be the ID, and this is of integer type. Now I would be assigning the unique constraint to this SID column, and there would be a second column which is basically the student name, and this is of varchar type. Again, the length of the string would be 20. Right. Now let me have a glance at this table again. So select star from stu2. So this is our new table which is empty as of now. Now let me go ahead and add values into this. So insert into stu2 values. I'll add in the first record. So 1, which would be the student ID. Name of the student is Julia. Now let me look at this table. Select star from stu2. Right, so we have successfully inserted this record. Now let me add a new record. So insert into stu2 values. Now what I'll do is I will again give the ID of the student to be 1 and the name of the student to be Matt, and let's see what happens. So this time we get a message or a warning message, and this states that violation of unique key constraint, and we cannot insert duplicate key in object dbo.stu2, and that is because we had given the unique constraint to this SID column. That is why this has to be different. So let me change this to be 2. Now let me again run this, right? So now since this is a unique value, 2 is not a duplicate. That is why we were able to insert this record. Now again, what I'll do is let me add another record with the ID 2. So let's say now the name of the student is Annie. Now again we get this warning message because ID number 2 is already present. So let me change this to 3. Now let me run this again, right? So now we are able to insert this record. So this unique constraint basically makes sure that there are no duplicate records inserted into this column. So now we have the next question. So again we have this employee table with us and we are supposed to find out the second highest salary from this table. So let's go to SQL Server and find out the solution. So let me start off by having a glance at the employee table. Select star from employee. Right, so this is our employee table over here, and we see that the highest salary is 159,000 and the second highest salary is 125,000.
Just a quick info, guys. Test your knowledge of SQL by answering this question. Which SQL keyword is used to retrieve a maximum value? A. Most. B. Top. C. Max. D. Upper. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So we are supposed to extract this particular value from this data set. Now let's see how can we do this. So we can perform this operation with the help of subquery. Now let me just type in the command select, and since we want the maximum value, I'll use the max aggregate function, and this would be E salary. So I want the maximum salary from the name of the table is employee. I'll give in the where clause and given the condition where E salary is not in. After this I will give in the subquery over here. So the subquery again would be the same. So select max of E salary from employee. So now if you have a glance at this, you would see that both of these queries are same. So select max of E salary from employee and select max of E salary from employee. Now this subquery would give in this result, which is 159,000. So, and then this main query would make sure that this salary does not lie in this. So this would give us the 125,000 result. So select max of E salary from employee where E salary is not in 159,000. That would mean 125,000. So let me click on execute, right? So we have successfully got the result, which is 125,000. And this is how we can extract the second highest salary. So we have our next question over here. So what do you understand by normalization and denormalization? So this is a question which is very frequently asked during the interviews. So let's get to the answer. So normalization and denormalization are basically methods used in databases. And normalization is the process of reducing data redundancy and dependency by organizing fields and tables of the database. So it involves constructing tables and setting up relationships between those tables according to certain rules. And the redundancy and inconsistent dependency can be removed using these rules in order to make it more flexible. So I'm repeating it again, guys. So simply put, normalization is the process of reducing the data redundancy. And we are able to do this by organizing the fields and tables of the database. And then we have denormalization, which is a contrary process to normalization. So in denormalization, we basically add redundant data to speed up complex queries involving multiple table joins. So in denormalization, we attempt to optimize the read performance of a database by adding redundant data or by grouping the data. Right, so this is our next question. Now we are supposed to find out what exactly is wrong with the SQL query. So this is the SQL query over here. Select gender, average of age from employee where average age is greater than 30. And again, we are grouping this with respect to gender. So this is our employee table over here. Now let me go ahead and just type in the command, which would be select E gender. And then I would want the average of age. So average of E age from the name of the table is employee, where again the average of E age needs to be greater than 30. And this is being grouped with respect to gender. Now let me go ahead and click on execute. So let's see what is the error. So this warning message states that an aggregate may not appear in the where clause unless it is in a subquery contained in a having clause or a select list. And the column being aggregated is an outer reference. So this basically means that whenever we are working with aggregate functions and we are using group by, we can't use the where clause. So instead of the where clause, we would have to use the having clause. Now, let me change this to having. and let me click on execute. So now again, we get an error over here, and this error says that incorrect syntax near the keyword group. And this is because if we are using the having clause, then group by would come first and having would come second. Now, let me cut this over here and let me paste this before having. Right, now I'll click on execute. So this has to be gender over here. Now we've successfully got the result. So just to reiterate, the error was whenever we are working with aggregate functions, we cannot use the where clause and we would have to use the having clause. And if you are also using group by with having, then group by would come first and having would follow it. So next question. So what do you know about the stuff function? So the stuff function deletes a part of the string and then inserts another part into the string starting at a specified position. So this is the syntax of the stuff function. So stuff, this takes in these 4 parameters: string 1, position, length, and string 2. So this string 1 is basically that string which would be overwritten. Position would basically indicate the starting location for overwriting the string. And length is the length of the substitute string. And string 2 is that string which would overwrite the string. So again, let's go to SQL Server and work with an example with the stuff function. So now let's say I have this string which basically stands like this: SQL tutorial. Now I'd want to replace this SQL tutorial with Python tutorial, right? So for this purpose, we can actually use the stuff function. So let me go ahead and write the syntax for that. It would be select, I'll give in the function stuff. So let me start with the first parameter, which is the string which is to be replaced. So the string which is to be replaced is SQL tutorial, and then I'll give in the second argument, which is the position. So the position would be 1, that is I want to replace this, so this is position number 1, and then I would have to give in the length of the string which is substituted, right? So the length of SQL is 3. I'll just type in 3 over here, and then finally I will give in string 2, which is basically that string which would replace this over here. So I would type in Python over here. Now I'll execute. So initially our string was SQL tutorial, and with the help of the stuff function, we were able to change this from SQL tutorial to Python tutorial. So next up, we'd have to explain about views in SQL. So what exactly is a view? And then we'd have to give an example of view. So you can consider views as virtual tables which are used to limit the information that we want to display. And these are actually nothing but the result of an SQL statement which have a name associated with them. And since views are not virtually present, it takes less space to store. So let's take this example. From this employee table, let's say we wanted to perform multiple operations on the records where the gender is female. So we can create a view only for the female employees from the entire employee table. So let's go ahead and perform this in SQL Server. Now let me type the syntax for this. So I would want to create a view which would comprise of only the female employees from the entire employee table. Now let me just have a glance at the employee table first. So select star from employee. Now I would want a view which would comprise of just these 2 records. Now let me go ahead and write in the syntax for the view. So it would be create view, and the name of the view would be female employee. And after this, I will give in the keyword AS. After that, I'll type in select, and then I'll give in the condition. So select star from employee, where after the where clause I will give in the condition which actually matters. So gender needs to be equal to female. Right, so I have successfully created this view with the name female employee, which would comprise of only the records of the female employees. Now let me delete this and let me have a glance at the view which I've just created. So select star from female employee. Right, so this is our view which comprises of these 2 records, and the names of the employees are Anne and Julia. Now similarly, let's say if I wanted a view which would comprise of only those employees whose age is greater than 25. So let me go ahead and write the syntax for that. So create view, and then let's say the name of the view is age, and then I'll type in the keyword AS, select. Now over here, let me give in the statement. So select star from employee, where, and then the condition would be age needs to be greater than 25. So we have created this view. Now let me have a glance at this. So select star from age. Right, so this is a view which would comprise of only those records where the age of the employee is greater than 25, and we've got 4 records over here. So Sam's age is 45, Julia's age is 30, Matt's age is 33, and Jeff's age is 27. Right, so what is a stored procedure? And then we'll have to give an example of stored procedure. So a stored procedure is a prepared SQL code which can be saved and reused. Or in other words, you can consider a stored procedure to be a function consisting of many SQL statements to access the database system. So we can consolidate several SQL statements into a stored procedure and execute them whenever and wherever required. And stored procedure can be used as a means of modular programming. That is, you can create a stored procedure once, store, and call for several times whenever required. So this supports faster execution when compared to executing multiple queries. Now let's look at the syntax of a stored procedure. So we'll give in the keywords create procedure, and then we'll give the procedure name over here. After that, we will give in the keyword as, and then we'll give the SQL statement for which we'd want to create the procedure. And then we'll end the procedure with the go keyword. Now, after we create a procedure, we need to execute it. So this is the syntax to execute the procedure. So we'll type in exec and then give the name of the procedure which is to be executed. Right, so again, let's have an example with the stored procedure. So now I'm going to create a stored procedure which would help me to extract the age of the employees in a very easy way. So let me type in the syntax for that. Create procedure, and then I'll give in the name of the procedure. So this would be employee age. After this, I will type in the keyword as, and then I'll give in the select statement. So select age from employee. Now that this is done, I'll give in the go keyword. Right, so now I have successfully created this stored procedure with the name employee age. Now I'll go ahead and execute this. So it'll be exec or execute employee age. Right, so we have created the stored procedure which would help me to easily access the age column from this employee table. So next question, what do you understand about join, and explain about different joins? So a join clause is used to combine rows from 2 or more tables based on a related column between them. So there are various types of joins which can be used to retrieve data, and it depends on the relationship between tables. So first we have inner join, which basically returns records that have matching values in both the tables. Then we have left join. So left join returns rows which are common between the tables and all rows of the left hand side table. That is, it returns all the rows from the left hand side table even though there are no matches in the right hand side table. Then we have right join. So right join returns rows which are common between the tables and all the rows of the right hand side table. That is, it returns all the rows from the right hand side table even though there are no matches in the left hand side of the table. And finally we have the full join. So full join returns all rows from the left hand side table and all the rows from the right hand side table. So now we'll have to explain about inner join properly. So the inner join basically gives us those records which have matching values in both the tables. So we've already learned this. Now let's say we have two tables, table A and table B. And when we apply inner join on these two tables, we'll get only those records which are common to both table A and table B. So this gray portion which you see over here, so this would be the result of the inner join. Now let's look at the syntax of inner join. So we'll give the keyword select, and then we'll give in the list of the columns, following which we'll give the from keyword, and then we'll give the name of the first table. Then we'll use the keywords inner, join, and then give the name of the second table. After which we'll give in the on keyword. So this on keyword tells SQL that this inner join needs to be done on some condition. And the condition over here states that the values from column X of table 1 should be equal to the values of column Y from table 2. So let me just reiterate this. The values of column X from table 1 should be equal to the values of column Y from table 2. Now let's go to SQL Server and work with this inner join. So I have two tables over here. So the first table would be the employee table and the second table would be the department table. So let me have a glance at both of the tables. So select star from employee. Now the second command would be select star from department. So this is the employee table over here, which we've already seen, and then we have this department table. Now I'd want to have an inner join on both of these tables where the EDEPT column from this table is equal to the DNAME column from this table. That is, wherever the values from these two columns match, I'd want only those records. Now let me go ahead and write the syntax for this. So I will type in select and then I'll give in all of the columns which I want. So I want the ename column and eDepartment column from the employee table. So this would be employee dot ename. Then I would want employee dot eDepartment. After that, I would want the department name and the department location from the department table. So I'll type in department dot dname. And then I also want department dot dlocation. Right, so these are all of the columns which I want from both the tables. Now after this, I'll type in from, and then I will type in the name of the first table, which is employee. And then I'll just type in inner join, and then given the name of the second table, which would be department. Then I'll give in the on keyword and then given the condition. So here the condition is the values of the DNAME column should be equal to the values of the EDEPT column. So employee dot ename should be equal to department dot dname. Now I'll execute this. Right, so this is the result. So we have our employee table over here. This is the department table, and finally this is the result of the inner join. So here we see that we've got only those records where the departments match in both of the tables. So the matched departments are support, analytics and sales, right? So we've got support, analytics and sales from over here because only those departments are present in this department column. So next question. Well, what do you understand about temporary table? And then we'd have to write a query to create a temporary table. So simply put, temporary tables basically help us to store and process the intermediate results. Now these temporary tables are created in the temp DB and are automatically deleted when they are no longer used. So the temporary tables could be very useful in cases where we need to store temporary data. Now let's look at the syntax of a temporary table. So first we will give in the keywords create table, and before we go ahead and give the name of the temporary table, we'll have to precede it with a hash. So again, let's go ahead and create a temporary table. So now what I'll do is I'll create a temporary table and I will name this as, let's say, book, and then before the name of the table I'd have to precede it with a hash. Alright, now this would have two columns. So first would be the book ID and this would be of integer type, and then this would have book cost, which is again of integer type. Now let me execute this. Now I'll refresh over here. I'll click on the plus sign. I'll go into system databases and I'll go into temp DB, and over here let me click on the temporary table. So we see that we have successfully created this temporary table with the name book. Now let me see what is present in this table. So I'll type in select star from, I'll put in the hash symbol over here, and then I'll give in book. Right, so as of now this temporary table is empty. Now let me go ahead and insert something into this table. So the command would pretty much be the same. So insert into, and then LB book. I'll type in values over here. So the only difference which you see when you're creating or working with a temporary table and the normal tables is you'd have to precede the name of the table with a hash. So as simple as that. Rest everything would be the same. And over here, let me give in the values. So the book ID is 1 and the book cost is 100. Right. Now let me also add another record. So the second ID would be 2 and now the book cost would be, let's say, 232. Alright. Now let me have a glance at this modified temporary table. So select star from, hash book. Right, so we have added 2 records into this temporary table. So now we'd have to explain the difference between OLTP and OLAP. So let's start with OLTP. So OLTP basically stands for Online Transaction Processing, and you can consider it to be a class of software applications capable of supporting transaction-oriented programs. And an important attribute of an OLTP system is its ability to maintain concurrency. So OLTP systems often follow a decentralized architecture to avoid single points of failure. And these systems are generally designed for a large audience of end users who conduct short transactions. And queries involved in such databases are generally simple, need fast response times, and return relatively few records. So the number of transactions per second acts as an effective measure for such systems. Then we have OLAP. So OLAP stands for Online Analytical Processing, and it is a class of software programs which are characterized by relatively low frequency of online transactions. So queries are often too complex and involve a bunch of aggregations. And for OLAP systems, the effectiveness measure relies highly on response time. So such systems are widely used for data mining or maintaining aggregated historical data, and this is usually used in multi-dimensional schemas. So then we have the next question. So what is the difference between the delete and the truncate command? So again, keep this in mind, guys. This is a question which is very frequently asked in interviews. So let's start off with the delete query. So the delete query is used to delete or remove one or more existing tables. So let's have a look at the syntax. So we'll start with the delete keyword, and then we'll put in the keyword from. Then we'll specify the name of the table. After that, we'll specify the where condition, but then that's optional. So let's see an example of this delete command. So we have this table. So the name of the table is STU, which basically is the student table. Now from this table, I'd want to delete the record where the name of the student is Bob. So let me write the syntax for that. So delete from, and then I'd have to give in the name of the table. So the name of the table is STU. So delete from STU. After that, I'll give in the where clause and give the condition where S name is equal to Bob. Let me execute this. Right. So we have successfully deleted that record from this table where the name of the student was Bob. So similarly, let's say if I want to delete that record where the student ID is 3. Right. So over here, the condition would change. So delete from STU where SID equals 3. So now this time we have deleted that record where the student ID was equal to 3. Now let's look at the truncate statement. So the truncate statement deletes all of the data inside the table. So here we'll give in the keywords truncate table and then give the name of the table. So let's go to SQL Server and work with this truncate command. So now we have this stu1 table. So let me go ahead and use the truncate command of this table. So I'll type in truncate and then I'll give in the name of the table, which would be stu1. So before that, I'd have to type in table. So truncate table stu1. Let me run this. Right. So we have deleted all of the records from this table. Right. So this is how the truncate command works. Now let's understand some differences between the delete command and the truncate command. So when it comes to the type of language, truncate would be a DDL command or a data definition language command, and delete is a DML command or a data manipulation command. Now another difference would be we can't really execute a trigger in case of truncate, while with delete we can accomplish a trigger. Now also, if a table is referenced by any foreign key constraints, then truncate won't work. So if you have a foreign key, then you'd have to use delete and you wouldn't be able to use the truncate command. So next question. What is the difference between union and union all operators? So the union operator is used to combine the result set of 2 or more select statements. For example, if the first select statement returns these 3 fish and the second select statement returns these 3 fish, then the union operator would return the result of these 2 select statements. And if there is a record which is present in both the tables, we'll get only one of them in the final result. So here we see that this blue fish is present in both the tables A and B. Now, when we apply the union operator on these two tables, the final result of A union B would have only one of these bluefish. And this is the syntax of the union operator. So we'll give the first select statement. After that, we'll give in the union operator, following which we'll give the second select statement. Now you also need to keep in mind that the number and the order of columns must be same in both the select queries. So let's work with this union operator now. So we have these two tables over here. So the name of this table is student details 1 and the name of this table is student details 2. And if we have a glance at the columns, we see that both of the tables have 3 columns and the names of the columns are same and also the order of the columns are same. So here we have SID, SNAME and SMarks. Similarly over here we have SID, SNAME and SMarks. Now let's go ahead and apply the union operator on this. So I'll type in the first select statement. So it'll be select star from student details 1. So let me change the spelling to student details. After this, I will apply the union operator and then give in the second select statement. So select star from student details 2. Now let me click on execute. So this is the result over here. Now let me also print in the first 2 original tables. So select star from student details 1 and then I'll also put in select star from student details 2. So let me just change the spelling to student over here. Let me also change this over here. So this will be student. Right. So this is student details 1, this is student details 2, and this is the result of the union operator. Now, if you have a glance at these two tables, then you see that these two records are repeating over here, right? So there's Anne, Julia over here in the first table, and there's also Anne and Julia in the second table. Now, when we apply the union operator, then we'll just have one record coming from each of these tables, right? So we've got Anne over here, we've got Julia over here. And then we finally have Matt, which comes from the second table. This is how the union operator works. Right, now let's look at the union all operator. So the union all operator gives all the records from both the tables, including the duplicates as well. So here, since this blue fish is present in both the tables A and B, the final result of A union all B would also have the duplicate value. So here we see that we've got both of the blue fish from table A and table B. Now let's go ahead and implement this in SQL Server as well. So here we have these two tables already ready, which are student details 1 and student details 2. Now what I'll do is I will copy this, I'll paste this over here and just type in union all. So union all, I'll click on execute. So student details 1, student details 2. Let me just expand this over here. Right, and this is the result of union all operator, right? So if you have a glance at this, you'll see that these two are repeating, so we would have duplicate values. So we've got Anne twice over here and also Julia twice over here. So next question, well, what is the use of the intersect operator? So the intersect operator helps to combine two select statements and returns only those records which are common to both the select statements, right? So if we've got table A and table B over here, and if we apply the intersect operator on these two tables, then we'll get only those records which are common to the result of the select statements of these two. Now let's look at the syntax. So over here, this is the syntax. So we'll start off by giving the first select statement and then we'll give the intersect operator, following which we'll give the second select statement. Now let's see an example on this. So again, we have these two tables over here, student details 1 and student details 2. Now let me apply the intersect operator on these two. So let me just type in intersect over here and I'll click on execute. Now let me maximize this over here, right? So student details 1, student details 2, and this is the result of the intersect operator. So we see that since Anne and Julia are common to both of these tables, this is the resultant of the select statement, right? So the select statement on the first table gives out Anne and Julia, and the select statement from the second table also gives out Anne and Julia. So the intersection of these two would be this. So we have our final question. Now let's say you're given a table. Now you'd have to copy the data of this table into another table. So you have this employee table. Now you'd have to go ahead and copy the data which is present in all of this table into another table. So let's see how can we do this. So this is our employee table over here. Now we'd have to copy all of this into another table. So for this purpose, we can use the insert into select operator. Now before we go ahead and do that, we would also have to create another table which would have the same structure as this table. So if the table doesn't have the same structure, then you wouldn't be able to copy the data. So let me go ahead and create the table first. So I'll type in create table and I'll name this as employee duplicate. And then I'll give in all of the values over here. So my first column would be EID and this would be of integer type. Second column would be ename and this would be of varchar type. And the length of the string would be 20, and then I would have the eSalary over here. This would be of integer again. After this, I would have the EAge, which is of integer. Then I would have the gender of the employee. So the gender of the employee would again be of character type. Now I'd have to make sure that I give in commas after all of these. So let me just put in a comma after this as well. And then the final column would be EDEPT. And this again would be of variable character of length 20. Right. So I've successfully created this employee duplicate table. Select star from employee duplicate. Right. So as of now, we see that this table is empty. Now I'd want to copy all of the table present in the employee table into this table. So let me write in the command for that. So I will start off by giving the keywords insert into. Now after that, I'll give in the name of the table into which I want to insert. So the name of the table would be employee duplicate. Then I will type in select star from, and then I'll have to give in the name of the original table. So the name of the original table would be employee. Right? So 6 rows have been affected. Now let me have a glance at the new table, which would be select star from employee duplicate. Right? So we have successfully copied all of the data which was present in employee table into this employee duplicate table.
Just a quick info, guys. Intellipaat provides SQL online training in partnership with Microsoft and mentored by industry experts. The course link is given in the description below. So guys, we have come to the end of the session. If you have any doubts, please put down in the comment section below. We will try to answer it as soon as possible. Hope you all enjoyed the session very much. Thanks for watching.